If you want to go inside, there's a lot of open seats in there, so you're more than welcome to go in. We're going to be starting in about 5 minutes. So if you want to go inside, if not, I mean, it is really beautiful. You're more than welcome to stay out here. So it's whatever you're comfortable with. But we will be starting inside about 5 minutes, and you'll see the screen up there. I think everybody's home. Yeah, I definitely got it loud and clear. Everybody's comfortable. I have to stage some people there because if you've ever talked to an empty room, it's really hard to keep your energy up. Okay. There's some of us. Thank you. I'll be using it all for you then. We're going to be going inside in about 5 minutes, but you can stay out here if you like. I know.
Good morning, everyone. Welcome to this year's 2020 Wastewater Conference. It's the one that almost didn't happen. So, it's been quite the year. And typically, we would have been meeting with you in the spring, and we were all geared up. We were super excited about it. We had this great theme going on with all kinds of videos, and then we were shut down. And so it was hard to kind of rev it back up and get excited about doing this. So I sent out an email and asked the 96 people that had signed up for the spring conference, do you want to come live and in person? Would you like to roll it over to next year? Because I really didn't want to give anybody their money back. Or do you want to do it virtually? And we were just so excited by the responses we got. It energized us. And in 3 weeks, we have a wastewater conference. So it's also our national precast days. And so this is the last day of precast days. And so we're super excited that all of you decided to join us today and brave this pandemic. Greg, you want to add anything before I go through housekeeping?
So for us, this whole pandemic has been a really strange experience, I guess, for everybody. But early on, we're an essential business and there's no way to make the stuff virtually. So we thought there were some things that we could do virtually, like CAD drafting or project management. What we realize is, we're not huge, but there's 8 different distinct departments here within Gainey's. And what we realized the hard way is every single department communicates with all the other departments. So we found that we needed to stay full staff. So we went through terrible times where we were so shorthanded on people, and then the business was strong. It got stronger. And so with fewer and fewer people, with real customer demands, we had to keep on finding a way to get it done. So here we come out of it at the end, and it's our experience. Well, it's, yeah, let's hope. It's our experience. And so it's become our new normal. But the good news for us is we've been coming to work every day. We've had real things to do, real things to worry about other than, sitting at home and wondering. So we're glad that you guys are adventurous enough to come out here. It's not so bad, right? So welcome, enjoy yourself today. I think we have some great speakers. I myself am speaking at the end of the day. I'm the graveyard shift. Lisa, you want to say anything about that?
I have a lot to say, Greg. Okay. So what we want most for today is for it to be a really relaxing day. We want you to enjoy yourself. We ordered perfect weather and God complied. So that's always good. And so we thank you. We want you to eat, relax, and have a great time. Everyone with the pink shirts and the name tags are here just to make sure that that happens for you. So please grab one of us if we can do anything to make it more enjoyable. If you need to step away and work, all of our offices are available to you. I do ask for just a couple of housekeeping things. If we could turn our phones on vibration, so that way, well, not that, I guess in here, as everybody's outside enjoying that beautiful weather, it probably wouldn't be that distracting, but if we could do vibration. Also, there's plenty of restrooms, so if you don't know where one is, please ask and we'll let you know. I want to thank our sponsors that we have. So our gold level sponsors are Delta Process, Ferguson, Technical Coatings, and Coastal Process. And all of them will have a speaker, except Ferguson, but we'll have a speaker sometime through the day. So if you see one of our sponsors, please say thank you. Our silver level sponsors are J.H. Wright, Gulf States Engineering, and Polylock. And our bronze level sponsors are D&W Systems and Ohio Electric Control. So we really very much thank them for always being on board and helping us make this possible. So again, relax, eat, drink, and be merry, and just have a really good time. We want it to be a great day.
Most of you have been here to our conferences before and taken a plant tour. I encourage you, please take another plant tour today. There's a lot that's changing out there. We've got 3 expansion projects going on. We have some really interesting product on the ground. I know that Cindy's going to be going over that during the lunch hour. So it would be great if you saw what she is going to be talking about. A lot of it's right out in the yard. Okay.
Yeah. So something really exciting that'll be happening this spring, other than our wastewater conference, which is going to be April the 26th? 30th? Okay. All right. Well, Cindy knows. I think I've been saying April 26th, but it's the last That's why it's so, yeah, it's the last Friday in April. So that's going to be our wastewater conference. And hopefully all this will be over, no masks needed, and we'll be good to go. Then in May, what we're really excited about is we're going to be the national plant tour for the National Precast Concrete Association's convention. And so they will be here. We'll have somewhere around 500 precasters just like us from around the world coming in to visit. So Greg has finally let me spend money here. So you will see lots of improvements at Gainey's because finally the purse strings got loosened just a little bit. Just a little bit. Remember, he's the conservative one. So if it was up to me, we'd have no money. What?
She simply doesn't tell me what she's spending. Not like I said yes.
Well, if you ask me a direct question, it's really hard for me to lie directly to you. That's when I just deflect, but something like that. Okay. So anyway, thank you for joining us today. We're super excited. And for those who joined us virtually, thank you for zooming in. We appreciate it. So let's talk about our first speaker. Oh, don't you look nice? Yes, we have a change in the agenda. So if you saw your agenda, Trad flaked out on us, and he didn't. He is just delayed in traffic from Lafayette. And so he will be here in a little while. And Elias was just good enough to say, hey, put me in, coach. I'm ready to go. Yeah, and give me more time. If Trad doesn't show up, I'll just take his spot too. So, or something like that. So let's talk a little bit about Elias, who's with the Hunt, Gilead and Associates. Okay, and we got a lot to say. His areas of expertise are structural engineering, civil engineering, architecture, and construction management. He barely knows anything. So he's got a degree in mechanical engineering and structural engineering and a civil engineering degree. Where were you born?
Lebanon.
Okay, yeah. So he was born in Lebanon, but you've lived in a lot of spots. Tell us where.
Yeah, I lived in Dubai, United Arab Emirates, and the rest of my life in United States. I lived in Ohio, Michigan, Georgia, and Louisiana for the past 25 years.
So I know exactly. Let's do that math. I know. So I would think you probably lived in Louisiana the longest of all the spots.
Correct.
Good. So there's a lot to say about him. He has been a friend to Gainey's for a long time. He's been coming to the conference, and we're really excited to see what he has to say about reinforced concrete calculations and design overview of retaining walls. Greg, you act like you want to say something. Do you want to say something?
He's best known for making really cool stuff that Gainey's gets to make. So we've done a bunch of projects with him.
Yeah, we even have your picture in a couple of slides. And he always wears the pink tie, so it makes him really popular around here. Okay, here you go.
Good morning, everybody. I had handouts, but they just informed me they're not going to pass them because of COVID. So my presentation usually takes few hours, and I'm going to do it in 30 minutes. So to do that, I might have to skip a lot, and I was hoping the handout, you all can read it by yourselves, but maybe we can email it. Yes. So I picked a subject about retaining walls, which is partially when you design a retaining walls, you can design the same for any concrete submerged structure, whether it's a catch basin, an underground storage tank, sewage treatment plant, all of them are designed similar. So the retaining wall is just a small part of it. Yeah, you can move on. So this is some nomenclatures. I'm not going to go over them because there are a bunch of them. Most civil engineers that design concrete, they know them by heart by now. Oh. Okay, here you go. More of them. Now, there is different kind of walls, non-bearing walls, similar to concrete walls that act like fences, for example. They just have to support themselves and wind and seismic loads. So I'm not going to go over details on how you design these because I'm going to go over an example at the end. Now, For bearing walls, there is empirical methods to do calculations, and those methods are derived by experimental. So that's why we call them empirical methods. Now, and there is bearing wall design using strength design methods, and this is the example we're going to go through soon. And I'm going to skip. Now, the way you design those retaining walls are a cookbook method, we call it. They give you steps in the book, and you follow the steps, and everybody can do it. You don't have to be a advanced in civil engineering to do that. So mainly, I drew a picture here also, which duplicates what we have there for the example. Usually, this is where you have the fill, and this is where you have the cut. So the retaining wall is here. This part is called the heel, and this part is called the toe. It's opposite than our feet. The heel is bigger than the toe. They give you all the steps and a bunch of equations that you have to follow to calculate everything about the wall, the thickness of the wall, the reinforcement in the wall, and everything else. And once you get the email, you'll have all this information handy. Now, when it comes to the dimensions that you have to worry about for the stem itself, is this: the stem has a width of T, and the location of the rebar at a distance D, and you go up a distance D where you have to calculate the shear of that wall, and you derive a D prime based on the thickness of the wall at that D location. This is if the wall is tapered. If the wall is straight up, you don't have to worry about these dimensions. Now, when it comes to the heel, the way you do the calculations is we assume that there is no support below it, and this part from here to here, which is the critical section for shear and flexure, works as a cantilever beam. So you load it and you calculate the rebars and the thickness of concrete required. And since the concrete is cast in place, we need a minimum 2-inch clear on the top, and plus half of the diameter distance. This is where you place the rebar. And this is T is the thickness of the heel. More equations for fun. When it comes to the toe, we do consider the pressure underneath it, because that's the more significant load on the toe, and it acts the opposite way than the heel, and you have to calculate the shear at a distance D from the stem, and the critical flexure moment will be at this location here. Now we're going to go through this example, which I drew the same sketch here on the board because I need to explain a few more things that what they show you in the book. So what's given, it's a cantilever retaining wall. It's 17 feet of earth above the toe of the cut, which is this 17 feet, which is the difference between how much you have fill on one side and how much you have cut. So that's how much we're loading the wall, is 17 feet. The backfill is level, as you see here. It doesn't slope up. If it slopes up, it complicates a bit more the calculations, which can be done. I've done it so many times. The backfill is level and has a unit load of 100 pounds per cubic feet, which is typical for backfills. Usually they're between 90 and 100, 110 pounds per cubic feet. For this example, we're going to use 100. The angle of internal friction of the soil, of the backfill itself is 35 degrees, that's a good soil when you have 35 degrees. Here in Louisiana, most of our soil is clay, which has a low angle of friction up to 0.2. The allowable soil pressure is 5,000 pounds per square feet. Also, it's good allowable pressure under the wall. Usually in Louisiana, we get 1,000 to 2,000 pounds per cubic feet. The coefficient of friction between the concrete and the soil is 0.6 or 60%. We're using a 3,500 PSI concrete and 60,000 PSI steel. So we're going to follow the cookbook method that is illustrated before. So first, we're going to find what is the equivalent fluid pressure density behind the wall. This is the first thing we're going to do. And since we have the angle of friction, which is 35 degrees, there is a coefficient of active pressure. We calculate that it's 0.271, which is about 27% of the vertical load of the fill that acts on the wall horizontally. So this fill in this area acts this way, and 27% of it acts horizontally. And since the unit weight of soil is 100 pounds per cubic feet, so you multiply it by the coefficient is 27.1 pounds per cubic feet. And this value acts at the bottom here. So you'll have a pressure gradient that acts like this, all the way up. And that's the value at the bottom. Similar to if you have water and you want to get the water pressure, the deeper you go, the higher the pressure is. Now, second, we're going to calculate the active earth pressure resultant, which is the resultant of this triangle that I drew here. So basically, you go with H, which is, we're calculating everything to the toe over here. Let me put an X on it so everybody knows what I'm talking about. Everything is calculated with respect to this point over here. So we take 17 plus 2 plus 2 give you 21. And the formula is, since it's a triangle, it's half of the length times the width, and times this value, which is already calculated, and you get a resultant of 5.976, almost 6 kips, acting in this direction. And this is called RA. Next, what is the overturning moment? So we need to calculate an overturning moment. And this is basically calculated based on RA and how much it turns it with respect to this point at the toe. So, so you multiply RA times a distance y where it acts. And usually it acts at a location 1/3 from the height, because it's a triangle and this is where all the center of the area is. So when you do the math, you get 41.83 foot kip per foot of wall, because we're doing all the calculations based on a wall a feet into the board. What is the resistant moment? So this is, we calculated before the acting moment is the moment acting to overturn the wall this direction. And the resisting moment is the concrete plus the load of the dirt acting on the heel. All of these loads will counteract the overturning moment. So the way we're going to do it is take some dimensions. We have 5 feet 5 inches, which you see it here, times 19, which is the 17 plus the 2. That gives you the area of the dirt over the heel, times the unit weight of the fill over 1,000 to convert it to kips. So you get 10 kips of load acting down, which is this load over here I drew acting down. Then you take that load and you multiply it by the moment arm from the toe all the way here. This load acts, since it's a rectangular load, it acts midway at the 5 foot 5 inches. And so we take it numerically, 3 foot 4 plus 15 plus half of 5 foot 5 inches, and you get the moment arm. So you multiply the moment arm by the load acting down, and you get a resistance of 57 kip foot per foot of wall from the backfill only. So similarly, we calculate all the loads from the battered soil, battered stem, 9-inch stem, and base. So technically, what we're doing, we took the load of the soil only above the 5 foot 5 inches. There is some soil in this triangle because the wall is 9 inches on top and 15 inches at the bottom. So there is additional soil here. So we take the weight of this soil times the moment arm to the same point. And the stem has a 9-inch straight, and they have 15 minus 9, which is 6 inches. So 6 inches tapered up as a triangle. We take the weight of this piece of concrete times the moment arm, plus the weight of the 9-inch concrete times the moment arm, plus the weight of the base times the moment arm, which I might show you that. That's the easiest, because it's 2 feet times 10, that's 20, times half of the distance, which is 5, times the unit weight of concrete, which we're taking it as 150 pounds per cubic feet. So we tabulate that over here, all the loads acting down, plus the sum of the resisting moment. So they sum up to all the loads acting down, 16.63 kip per foot of wall. All the resisting moment at 103.11 foot kip times foot of wall. And this is how you calculate the resisting moment. Now we do compare it directly with the overturning moment. So we divide the resisting moment over the overturning moment, and you get a factor of 2.46, which is greater than 1.5, so we're okay. Usually we'd like the resisting moment to be 1.5 times higher than the overturning moment. If it's lower, what we do, we increase the length of the heel, so you'll get more backfill resisting and more concrete resisting, or you thicken the concrete at the bottom. You need more mass to take care of the overturning moment. If you have any questions, please feel free to ask, because I do that for a living every day, so to me it's straightforward. Mainly what we're doing is geometry. So most of the things we do in engineering is geometry, you know. It's nothing hidden yet. So F, what is the factor of safety against sliding? So we did the factor of safety against overturning moment. It turns out more than 2. Now we do the same for the sliding. So the sliding, what we do, we take all the weights that we just calculated, the 16.63. I can try to go back, which is this. Those all the vertical weights resisting the moment. Now, I want everybody to notice that we ignored the backfill on this side because sometimes it washes out and it goes away. So we did not depend on it, which is more conservative. So we took the 16.63 over here times the friction, which was given in the example that this is the friction between the concrete and the soil itself. We multiply these, so we have a resisting friction load of 9.98. We divide that by the acting load, the RA that we calculated before, which was 5.976. Let me see if I can go back that far and RA, this one here, 5.976. So we take that in the denominator and we find out the safety factor of the friction is 1.67, which is again higher than 1.5, so we're okay. And again, if it's lower than 1.5, you have to do other things. Sometimes what we do, we put a key in the slab itself so it will resist more shear. So we take the concrete and we just add a key in the concrete. This will give you more shear resistance. Or you can make it heavier, longer, bigger. Anyway, G is any part of the heel soil in tension. So this is to see if there is any uplift on the heel side, because everything is turning around this point and we need to make sure that there is no uplift. And that's the exercise we're going to go through. So we need to locate the resistance from the toe. So again, we're calculating everything from the toe edge here. So we have the resisting moment minus the overturning moment, which is the balance moment acting on the structure. We divide that by all the vertical loads on the structure, and we found a value in feet, which is mainly known as eccentricity. So it's 3.685 by basically dividing all the moments over the load. So what that tells us that if we take all the loads acting on the structure and put all those loads at the distance from the toe, 3.685, it will balance. Now, the location of those loads is very critical. So if you divide 10 by 3, is 3.33. So we notice that number is higher than 1/3 of the base. So it means we're within a so-called the kern, if anybody heard of it. So because, let me use another color here. So usually the soil distribution is somehow like that. So under the base. So since we have loads pushing towards this direction, you'll have more soil resistance on this side than this side. Now, how do you calculate the total? Because the total soil resistance is equal to the total acting load. So you take the highest plus the lowest over 2 times 10. So if the resultant is acting, In the 1/3 region, that's the shape you have. It means you don't have an uplift. If the resultant was acting on the first 1/3, you will have automatically another shape, and that shape will look something like this. So the loads will be in the same direction, but it reaches a point where you start having uplift. And this is where the resultant of this triangle will be in the 1/3 up to this point. So since it's more than 1/3, automatically the shape is what I drew in brown. If you do this a lot, you'll notice that's what's called the kern, which is 1/3 to 2/3 of the base dimension in all directions. H. What is the maximum pressure below the toe? So we're going to go on and calculate the pressure over here and over here, and that's prove the point of the current theory. So since we have already an eccentricity we just calculated, and what we do, we take 10 feet divided by 2 minus the 3.685 that we calculated, and it's 1 foot point 31. We perform all the calculation per foot of wall. So the summation of the loads already calculated, 16.63. The area of the base is 10 times 1 foot wall, so it's 10 feet squared per foot of wall. So then we calculate the moment from those loads acting at this point. We get the 21.87 kip foot per foot of wall. We calculate the section modulus of the base, which is the 10-foot base times 1 foot in. So it's equal 1 foot in the wall, in the board, and 10 feet squared over 6, you get 16.67 cubic feet per foot of wall again. So the stress at both ends is calculated with this formula, which is the load divided by the area, give you a stress, plus or minus the moment over the section modulus. So we do the math and we find out that the pressure at the toe is 2.97 and the pressure at the heel is 0.35. So again, there is no uplift, and the shape is what I drew in brown over here. We need to specify the stem reinforcement. Now, we're done with geometry. Everything we did so far was geometry. Weights and where they act, moment arms, it's all basic geometry. Now the fun starts because you have to follow some codes. So enabling us to calculate the reinforcement required for the stem, we need to do some assumptions. And after we do the assumptions, we do the math. And if it works, it works. If it doesn't work, you start over. Because engineering, most of the time, is trial and error. You try something, if it works, it works. If we overdid it, we can try again and try to reduce the assumptions. So we're going to assume that we have 1 inch diameter bar, which is number 8. And we're going to have a clear cover of 2 inches. So we're going to assume D, which is the distance from the edge of concrete to the center of the rebar, is 15 inches, which is the stem width at the bottom, minus 2 inch cover, minus half of the diameter of the rebar, and it's 12.5. Now, we calculate the factor shear at that critical section, which is we multiply the loads by 1.6 because We do assume that all the loads acting on the wall are live loads, although it's backfill and it's dead, but to be conservative, we assume this is a live load, so we multiply it by 1.6. So if we take those loads, similar to what we calculated before, and which we calculated that already at the beginning of the example, 27.1, it's acting halfway in that distance, you get 6,992 pounds per foot of wall again. And this is the shear acting on the stem at the bottom of the stem. So D prime, which passed in one of the pictures we had before, what you do, you go a distance D up from the bottom, and this dimension here will be D prime, which is because the wall is tapered up. So that D prime, at 12.5 inches, and you do some geometry again, you go up 2.5, and you have a ratio of 15 minus 9, which is the 6 inches, and you divide it by the height from here to the top, which is 19 inches. You convert it to all in inches, you get 12.2, which is a bit smaller than the 12.5 down here. So D prime is a bit smaller. And this is what we do to calculate the capacity of our concrete, which is phi Vn, which is equal to phi W D prime lambda times the square root of F sub C prime. This is where we use formulas from the code that most of the time they don't make sense how you have to use a square root of a strength, but that's how it works. So even if you try to work your numbers out, it will work out to 12,992 pound-foot. So if you compare the capacity of the wall versus VU, it's way higher. Oh my God. Did the second speaker show up? Yes. You're here? Oh my God. This didn't. Did it move the right way? Huh? No. Oh, I have it upside down. That's why it looks symmetric, you know, like I'm. Why it's going the wrong way? All right, here you go. All right, I said that already. Since phi Vn is higher than Vu, so the stem capacity is okay. We do similar with the moments. Mu is again factored by 1.6, so we get an Mu of 49,000 foot-pound, and we use a lambda, which we assume is 10% of D, and we use phi of 0.9 for beam flexure, and we calculate the area of steel required, which is the moment divided by this formula of phi of 0.9, Fu is 60,000 psi times D minus lambda. Lambda is the compressive area of the concrete. That's the part that the concrete takes the compression, and we're calculating here the rebar. So rebar goes in tension, concrete goes in compression. So we make an assumption of lambda of equal 0.2 of the total distance from the rebar all the way to the external fiber of the concrete. So to have a rebar of 0.89 inches squared, it can be covered by number 9 at 12 inches. Or you can use number 8 at a smaller distance. If you do use number 9 at 12 inches, you have to redo the calculations, by the way, because we assumed it's 1 inch, so everything else changes. So that's why it's best to stick to your assumptions. So now we need to check the development lengths of this bar. So we put number 9 over here, and we have only 2 feet. Is 2 feet enough? Usually no. Number 9 requires way more development length. So by doing the calculations, we find out we need 57 inches of development length for that number 9. So we have only 2 feet, it's not enough. So you have to do the following. Either you increase the thickness, which is not so good, that will be too much concrete for nothing, or you use hooks. You bend the bar, and there is other ways to calculate how much the length of the bend should be, which I'm not going to go over now. I ran out of time, or? Sure.
So we will be sending the handout to you with his contact information, because I think he could talk to you for a couple hours about this subject.
Yes. Now, this is from the reference book that I have on the first page, and it's chapter 54, and it has 12 things we have to solve. They usually give you 6 minutes each item in a PA test. 6 times 12, that's an hour and 12 minutes. So to do it in 30 minutes is very rough.
It's just like a teaser.
Yeah, I know.
It's a teaser.
But anyway, this is how you go about it. If you have any questions, I'll be around all day. Come and ask me. If you need my business card so I can do the calculations for you, I'll be happy to do that, because that's what we do for a living.
I do it very well.
Yes, day in, day out. We dream of it too.
Thank you so much. Thank you.
And I have to say how proud I am of you, Elias, because I taught him all that.
So yes, if you've never had a chance to work with Elias, he thinks of everything. So that it is, yeah, it's you feel like you're in good hands when he's on your side. So our next speaker, who is late, let's remember that, okay? And he is speaking on drones uses and applications in construction. So Greg and I have been watching Homeland. We're in season 5, and they talk about drones all the time. But I think it's a little bit different in what you're talking about, just a little bit, okay? So I gotta think, Trad Trahan, don't you think that's like the best name? His mom or dad? Who did that? Your mom. She did such a great job. I mean, like, she must have thought you were going to be a rock star with that name. But you're an engineer. You want to read his bio?
No.
Oh my gosh, you keep taking it. Take
No.
ours.
We just finished a project for Trad on a subdivision, a treatment plant and lift station. And I'm telling you, the whole time I'm out there, I hear this slight buzz, and I look up, and there's a drone watching me.
So he knows something about it. Okay, tell us the name of your engineer that you co-own.
Henskins Engineering is the company.
Okay, but we know him when he was with Southern Lifestyle Development, and we did a lot of subdivisions with him. And so there's a lot to know about Trad, but he's not going to go into all that. He's going to go into drones instead. But a couple of personal notes. He has the 3 most beautiful little girls that you could possibly imagine. So he stays very, very busy. It says you have hobbies, but we know better, because you work all the time and you have 3 little girls. So yeah, but here's Trad.
Thank you, Cindy, Greg. Happy to be here. Sorry, everybody, I'm the late one. and I appreciate my first presenter for picking up the slack. Just a little quick intro. When me and my partner started our engineering firm, we were looking for alternatives to try and stay efficient and possibly use some technology to keep track of our job sites, our clients' job sites. And for any of you that are in construction or engineering, you know that can be a very daunting task, because we're not always working with just one project at a time. That would probably be great, but that's not reality. So me and my partner sat down and we tried to do some research on drone technology. And most people think when you hear drones, a lot of people have them for hobbies, just kind of pretty pictures, pop them up in the air. But the technology has really advanced in ways that you can get meaningful data from the picture. So it's not just put the drone up in the air and get a view of the site, but we can actually get elevation data, geolocation data from these photos. So we started using them in construction and inspection for our engineering firm. Always like to go through, a lot of people, some people don't realize that the FAA does regulate drone usage if you are going to use it commercially. So even as a hobby flyer, if you do have a drone and you don't know this, as a hobby flyer, you are required to register it with the FAA. You don't fall under the same regulations, but they do have a $10 fee. They make you put a tail number on your drone. More so in the case that if you do crash it into something, they want to be able to find you. So that's, but the FAA originally came out probably 8 years ago when drones were really starting to take off. They kind of threw everybody, if you wanted to do it commercially, you were under, I believe it was Part 61, which is your private pilot's license. So I think a lot of people wrote into the FAA and said, look, this is a little unreasonable. We're trying to fly drones. I don't have an intention of flying an airplane. So they got together, put together what they call Part 107, and it's only for remote pilots. It applies if you want to fly a drone commercially on a job site or for a fee. And that's kind of how they categorize it as commercial.
Hey, John, I hate to interrupt, but we have a viewer that just came in and said they have a drone. They don't fly commercially, and they registered it for $5.
Oh, hey, fine. So they went down.
Yeah, it went down.
I'll take that correction. So that's great that they were responding, because there's a lot of people that are getting into drones. I mean, I think it's a cool technology that now has come down in price to where the everyday user can actually purchase a drone. I believe at the onset, drones that you could use on commercial sites ran upwards of $50,000. Now that fee, you can still get drones that expensive, and they've definitely upped their game in the software world. But common commercial drones right now run anywhere between $2,500 and probably about $15,000. So with that, on the Part 107, they do have a study guide that you can study. You go and actually take the test at a proctored location, and you are issued a license. So that way, if you're ever on site and you get stopped, I can tell you, as Greg just let you know, the minute you put it up in the air and people hear the buzzing, somebody will come meet you. So I think out of probably a couple hundred sites that we've flown, there's maybe only 5 that we didn't have somebody come up and ask us what we were doing. So really important to get this, just in case somebody decides to take it a step further and call the law on you. Sometimes people don't understand the different types of drones. So just wanted to kind of give you a brief overview. Drones originally started out as just fixed wing. So what you would think of as a normal airplane with a propeller on the back. They became pretty problematic, and it was known quickly. If you weren't in the agricultural world, which is where this kind of got kicked off, farmers were trying to get overviews of vast pieces of property that they may be trying a new grain or a new pesticide, and they want to get a view on how well it's working. The problem with fixed wing is that if you don't have a large area to take off or land, you might not be able to take the drone off, or you might not be able to recover it without hitting something. So when you talk about commercial applications and job sites, those fixed wings really got in trouble with obstructions, and you didn't have enough space to take them off. So although the technology was advancing, it wasn't very practical at that time. And people still have these, and they're actually good drones, but they are hindered. Then came along multi-copter, which is what you see here in the middle. Those gave you more of what they call a VTOL capability. So vertical takeoff and land. And the importance of that is you can be in a very dense area with a ton of obstructions and land it pinpoint on one spot, take off from the same spot. So much more flexibility, especially when you're talking about very dense urban environments. And this is actually the drone that we run right now. So it has, let me get in. It's evolved. Sorry, it's evolved now where fixed wing and VTOL is capable. So some of these companies are now having drones that will take off standing straight up that look like an airplane. And then when they get into the air, they transition into a fixed wing airplane. So the importance of that, the fixed wing is able to cover much more ground than the actual multi-copter. So for the same amount of time in the air, and these drones run roughly 30 to 40 minutes. So the fixed wing can probably cover anywhere between 150 and 200 acres in the air in a 40-minute flight, to where the multi-copter, we're getting roughly 30 to 50 acres, which is still, when you think of normal surveying or inspection applications, there's not many crews that are going to be able to cover 30 to 40 acres in 45 minutes. So that just kind of gives you a quick overview of the different types of drones that are out there. And I fully believe that, give it another 2 years, and there are so many new companies that are getting into the game that you're really going to have your pick of the litter on a precise application. So then we get into types of data collection. So one thing I don't have on this slide, drones kind of get categorized into photometric drones or LiDAR drones. So the stuff that we use it's photogrammetry, where it takes 100 or 1,000 pictures and stitches them together. And from that, we can use software that knows where those photos are based on GPS locations from the drone, and stitch them together into one image to create that data. LiDAR drones are a little different. They use light emitting sensors that give feedback. So you don't necessarily get an image with it, but you do actually get the horizontal and vertical data from it. So with that, drones have evolved from 3 different types, I guess, of collection, if we want to gather them at least where they are today. So at the onset, a drone typically had a GPS sensor that was built into it, but probably not the highest quality. So if you really wanted to tie down where your drone was at and be able to use the data accurately, you would work with the surveyor. They would set up ground control points. And essentially the photos would overlap and pick up those ground control points to tell the photo, here's where you are in space. And then each photo, you would try to set the ground control points where you picked up more than one over a grouping or set of photos. That became problematic on larger sites. One, now you still have a survey crew that's going out. So timing to get them there, set up the control points, and were all of them actually visible to the drone. So that was at least the onset, and there are some softwares that help with that now. The big move was when they went to RTK. So if anyone is familiar with survey equipment, RTK stands for real-time kinematic. And the way that works is you have a GPS base station, and then you have a rover. So in this instance, we set up a base station similar to a piece of survey equipment, but the rover is actually the drone. So at any point in time of the flight, the drone and the base station are talking up to satellites to get GPS position, but then they have to actually route back to one another to make the correction. So it knows where it's at in space, the base knows where it's at, and then they're correcting each other to make sure that they have better accuracy on where the photos are being taken. The issue that you come in with that is when you're walking with a rover on a normal survey, if you lose lock with the base station, it can let you know, and then you can stop and essentially wait for the lock to come back. When you're flying a drone, that's not so easy because it is on an automated flight path and it's taking pictures every 2 seconds. So if it loses lock, you might have a group of pictures, 15, 20, maybe up to 40 pictures that really don't have an accurate correction. So it could muddy the model that you're trying to put together or cause other photos to be offset. So what they've done to try and combat that is move to what they call a PPK system. So it's post-processed kinematic. So at this point, it still works the same as RTK. You still have a base station. You still have a rover, which is the drone. They're both still talking to satellites, but they are retaining their own data. And what happens is there's companies now that put out software that it takes those two data sets, and each data set records a GPS location. So it's got an X, Y, and Z, and a timestamp of when the photo was taken. The base station is doing the same. You can set it up to where it takes 1 minute readings, 10-second readings. But when you put it into the processing software, which a lot of this stuff is done in the cloud now, it does that correction after the flight. So from a useful standpoint, I don't get back to the office and have a huge data set that might be corrupted because we lost lock with the drone for 45 seconds. To where here, you don't run the chance of losing lock on the drone, and you do all the post-processing to correct the photos in its correct location. So we kind of give you a different slide to show you a little bit more in detail. Again, base station is getting a signal from the GNSS satellite. Same thing with the drone, but then the corrections are applied in real time, which is why they call it real-time kinematic. But again, if you lose this lock, the drone might not know precisely where it's at. It still is getting a GPS signal, but it may shift it ever so slightly that now your data is corrupted. And I have an example later on in the slideshow that'll show you that. To where on post-processed, again, still getting the signal from GNSS satellites, rover still getting it, but then both of those are fed based on a certain file into the cloud, and then you get the actual corrected images. So what's going on in this process is all of the images are now getting re-stamped with information. So they're all going to get a northing and an easting and an elevation. So we can then take that, depending on how you're collecting your data. We can do longitude, latitudes, and export that to certain files. We can do state plane coordinate systems, which gives you northing and eastings. So once you get that data back, it's pretty versatile in what you can do with it. So then you go into the actual processing software. There's two sets of software. The first one makes the corrections to the images so that all of your images are stamped in the correct location. The second set of software actually stitches the images together. And this is the important step on the software, or the important part of software. This is what's going to give you what we call a point cloud. So from the images, it's going to literally generate a point cloud, which then can be used to make a mesh surface. And this gets important if you want to try and collect elevation data. So the processing software that's out there right now, the three main ones, Pix4D, Drone Deploy, AggieSoft, which was originally developed for more agricultural processes, but they've kind of morphed into taking advantage of the software they've already written to compete with Pix4D. And I say multiple others now are entering this field. I'd expect probably in the next 2 years that you probably have 5 others to choose from, or they get bought out by one of the bigger ones. But Pix4D is what we typically use on a day-to-day basis. They've kind of been the industry leader at this point. And they have some stuff that you're able to go in and check the file to really validate. A couple of these other ones, you have to send it up in the cloud. And once it goes there, you don't have as much control over it. So you really pick the software that you need based on how accurate do you need the data. So this is kind of an overview of what the software looks like when it tries to process the images. So this is a site that we flew out in Scott, Louisiana. Each red dot represents an image. So this is a compilation of, I think, roughly 1,200 photos. And if you look kind of in this location here, we were still running RTK for this run. And if you can see, we have a gap in the data because the drone actually picked up some interference and was not able to process those photos correctly. So what the software did was say that, look, it's too far out of calibration. We're not going to put it as part of this data set. So that's one of the nice things about using some of the software that can pick that up. Because if you don't know that this is wrong, or you know that it's wrong and the software still processes it, you can actually get a shift in the data that would be pretty hard to track down. The blue dots that you see, or the blue crosses, are actual control points that we set in the field. So those are set by a surveyor to where we have a northing, an easting, and an elevation, to where when we come back to process these photos, we actually set, and it's going to sound real technical, but we get a 5-gallon bucket lid, and we have a dot in the center, lay those out across the field, have a surveyor set up on them and pick them up, to where when we actually fly the drone, we can pick up each one of those dots, and we know exactly what the elevation, the northing, and the easting is in the center of the cone. So it's just another check. The drone is able to run it without the control points. Yes, sir. Yes. So we typically now, and we flew this one probably, I guess, about a year and a half ago. So we've picked up the do's and don'ts off of it. So right now we try and set them up in almost a diamond shaped pattern, to where it's kind of a replicating diamond, to where you know that each control point is equidistance apart, and it prevents the images from having a warp. On this, because we were running RTK on the system and we had a rover, we had a base set up, we weren't so worried about, is the ground control spread out in a orderly fashion. The site hadn't gone under construction just yet, so it was hard to get them in that diamond shaped pattern, but in areas that we could and get a good block from the actual survey equipment with the total station, we set a ground control point. But that is a good observation. Typically, and you really don't need quite so many. You would pick them off in a diamond shaped pattern to where the edges do not warp on you when you come to process the data, or the center does not have a big bowl to it. And I'll show you some of the point clouds that come up out of that. But that's a good question. Yes, sir. Yeah, so that's a really good question. The under port 107, they try and keep you 400 feet and below. This right here, we found that the sweet spot for getting higher quality images, but still high enough to get good elevation data, because you run into, if you fly too low, the elevation data gets skewed because you're not seeing far enough out on that oblique angle for the drone to overlap other photos. These were flown at 200 feet. And we find that the 175 to 200 foot range, one, it keeps us below kind of the FAA regulation, but it does give us a much crisper image on the sites. So this is just kind of another view inside the Pix4D software. This kind of shows you all of the blue dots represent an image that has been taken. All of the green dots represent a correction factor that's been added through the RTK process. So just kind of gives you a neat overview, and you can see how many photos are actually stitched together to make this complete model. Oh, look, 1,256 photos. Yeah, it's a few. So we utilize a 128 gig SD card inside the drone, and it'll fill up about 100 gigs of that on one flight at about 1,200 photos. So they're super high res. They're a couple hundred megs per photo. So the camera that's actually on the drone that we have is a 42 megapixel camera. So when you get it at 200 feet, it's giving you some really crisp images. So this is another view, and again, you can see kind of these control points spread out. But what's interesting about this picture is it's not really a picture. It's hundreds of thousands of little points, and it's a point cloud. So if anybody is familiar with some of the laser total stations that are out there to where you essentially generate a picture from a point cloud. That's what's happening here, which they have some people that are much smarter than me that have put together the Pix4D software that they're able to pick up because of overlap on images. They'll create those and they can actually see elevations through those images. So when we take this and kind of turn it on its side, you're starting to pick up where you can see the point cloud and some elevation changes. And then if we zoom in even more, you can pick up and see that this is a pond in the subdivision that's been dug. You can see roadways cut out and then another pond further down. So it's hard to tell from you kind of go through a 10,000 foot view down into some really detailed data, but you can pick down, and each one of these points has a northing, easting, and an elevation associated with it. So if you really want to drill down and say, hey, are we meeting the grades that we called for in our design, which is to kind of touch back on what we're using it for, more inspection purposes on the engineering side. Hey, we designed a subdivision that has a pond that's supposed to have X amount of volume above the water surface. So one thing that you see here, it kind of cuts off black. That is the actual water in the pond. So once it hits that, it doesn't really have a way to where LiDAR would more or less penetrate that. Photogrammetry is not going to penetrate it. It's going to stop those elevations at the water surface. But from the engineering perspective, we're just trying to make sure we have enough volume in the pond based on our design. So from this, we're able to create a surface model that we can go back and check it against our design. And it's a really quick way of doing some inspections on the subdivisions, especially if we're going to go back to the municipality and certify that, hey, this was built, according to the plan. So again, this is the same view, but kind of shows you how the photos overlap to generate that point cloud. So then you have multiple outputs that you can get out of the software. So on this here, we can actually generate a contour model from the point cloud. And you can generate it all the way down. I actually, for this presentation, we amped it up to all these contours represent 1/10 change in elevation. Now, we don't typically go in that tight because your tolerance on the drone is right at about 1/10 to 1500ths when you do RTK. So we typically keep those at 2500ths per every contour, but it really shows you that you can come in and see, roadways that have been put in, areas that haven't been filled yet, ponds that have come in, and you can see the triangulation right where the water happens. So what we typically do is come in at those point clouds, trim out those triangulations to where that's exactly where the water surface occurs. And this is just kind of a zoomed in view from that previous model to show you that you really can delve down and get some pretty accurate data from it. Yes. Yeah. So sometimes contractors don't like us either because it's, you missed a little spot there. But
Yeah, I can see that.
a couple tenths off, try and get that with the dozer. The dozer operator doesn't like you too much.
Yeah.
But we're not really using it as a gotcha on, hey, you're a 10th shy here or not. Is it draining where it's supposed to drain? Do we have some areas that either didn't have enough fill? And we're talking, if you're off 3 to 4 inches, then we're going to start having problems. So that's really what this is used for. And from our standpoint, because we're trying to stay, as lean and efficient as possible, it's really hard to get this data from, if you have a 3-man crew and you have 10 projects going on, how do you get this data? So in this instance, we can make a site visit. If you're going to be there anyway, you take 30 minutes to put the drone up in the air, let it do its course, talk with the contractor, and then when we get back to the office, we have a data set from our site visit that's much more than us just snapping a couple photos around the site.
Is that clear cut or no?
This here?
The whole thing?
Yes. Yeah. So the other thing about photogrammetry is it's going to work best on active job sites or cleared sites. It does not do well with grass or heavy treed areas. So we use that for inspection purposes in those instances, but it's not going to be able to generate, definitely not a very good elevation model because it can't see through or penetrate those areas. The software does give you capability to where if you do see some overgrowth in certain areas, but you do have 2 clear points across, it can actually triangulate through and say, look, you know, on average, this is where that elevation should be. So this is another job site that we had that we were just doing some inspections on. Again, 896 images that were stitched together. From this, it's really hard to get a PowerPoint to show the high resolution on the image, but we can actually delve down and you can see the actual expansion joints in the concrete curb. So when you want to go in and do inspections, it's really nice for us to run this. We might be inspecting something on a job site, but then we get back to the office, start looking at it, and it's like, oh, wait, we got another problem over here, but we just didn't really have time to address it on site. So if you look at the red box there, kind of zooms in, this gives you a better idea of kind of the quality that you get out of it. I mean, you can see sewer manhole picked up there. You can see joints in the curb, got a water valve there. So it from a as-built standpoint as well, we're able to go in because all of these images are overlaid in a state plane coordinate system. We can, with relatively good confidence, pull it in under our plan set and say, yes, all of this is installed where we designed it to be. And again, one more example, roughly 600 images on this site. And then I added one in at the end just to make sure we could check that Greg's got it in the right spot. Actually, no. So look, I go out to the site to fly it for Greg. And I show up and I look and he's got plumb bobs hanging everywhere. Said, man, he said, well, now I'm worried that you're going to check that I'm off, you know, 1/10 of a foot here. So we're going to make sure it's in the right location. I'm happy to say this one was, and it fit inside the fence. You know, nobody likes to get there and you put the treatment plant in and then the fence is supposed to be here. So that's pretty much it in a nutshell. If anybody has any questions, I mean, there are so many items that we could talk about. And look, I don't report to be the end all be all or the most knowledgeable on this, but it is a very ever evolving field. And I think it's extremely useful in the construction and engineering field.
Well, what's the accuracy between your targets and the real elevation?
So when you use the PPK system, the post-processing kinematic, the software will tell you that horizontally, X and Y, that they will have an accuracy as good as what your base station is, but roughly 6/100ths of a foot to 12/100ths of a foot is kind of the tolerance. And that's when it shoots through and the points that it omits, if it's not hitting that tolerance, it's going to let you know, and you can remove those images from the data. On the Z factor, it's 1/10 of a foot to 15/100ths of a foot.
Would you have someone giving feedback? If you get a question, would you mind repeating the question so they can hear?
Oh, yes, sure. And he had asked, what was the accuracy of the points that we collect from the survey? So again, horizontally between 6/100ths of a foot, 12/100ths of a foot, and vertically between 1/10 and 15/100ths. So for what we're looking for in verification of as-built and did it get built, I'm going to say within 1/10 of a foot is going to be good for me, at least as it pertains to site construction.
What do you do if the site has a lot of equipment, cars, parking lot, and they want you to take it on over the parking lot full of cars
Yes.
in the mall?
So that is a challenge.
Black Friday mall.
The question is, what do we do if we get into a commercial site that has cars parked or equipment staged, material staged? That is a challenge. We try and coordinate when they call us, or when we go out to a job site that it's either, you know, in a time where we know there's not a whole bunch of equipment, but it will pick up. I wish I would have had one on there. Let me see if I do have one that I can show you. It will pick up vehicles, and you do have to parse that data out. I'm trying to see if there's one I should have zoomed in on one, but it will recreate the vehicle. So your contour lines will come up and over the vehicle. So it is, if you're looking for elevation data and there's a ton of obstructions, you're going to have an issue with it. So it's one of those deals, you have to know the limits of the technology. What can it be used for usefully? What is your tolerance, and what will be your downfalls?
Do you want to ask if there's anyone else that has a question?
Yeah, is there anyone outside that has any questions?
They need to get to the mic if they do.
Wait, I'll let you say that.
You need to get to the mic if you have a question. Okay, we're going to assume you just educated them completely and thoroughly. So it's all good. Thank you, Trad, for joining us. Everybody give him a round of applause. So, Greg, you want to tell the story of where Trad educated you last week? Come on. Every now and then it really shows that you're a chemist. Come on. No. Take the mic and tell them the story because it's funny.
We had a 100,000 gallon per day to set 2 weeks ago, and it had to be precisely put on this property, LA War Vets. It's a veterans home in Jackson. And so I said, all right, if the engineer would take the four corners of the plant and give me reference points, and he was very polite. He said, sure, let me do that for you. So we had these numbers at each corner, and I kept on trying to figure out how that related to polar coordinates, and it just wouldn't. So I went out there with our contracting manager, 3 hours, and I'm triangulating, and I'm checking to this and checking to that and checking to this. Finally, we're done. And I couldn't figure out I said, I hope I'm good, you know. And I finally called Trad. I said, what are these numbers? He goes, that's northing and easting. I said, oh, what's a northern and easting? Because I tried to use polar coordinates and they don't equate. He said, well, here's some software. You can put in the northing and the easting, and you'll convert it to polar coordinates. So we did that, and we went out, and I said, how accurate can I get with my phone? He said, within a foot, but you can buy this $15,000 piece of equipment. I said, I'll take a foot. And we went out there and we checked with our phone, and we were within 6 inches of where we're supposed to be. But back to Mr. Plumbob, I sure like my new method of using northing and easting converted to polar coordinates. Yep. So, yeah,
So that wasn't a class you had when you got your
no. So thank you, Trad.
He just loves, and what I love about Greg is, I mean, while he doesn't look it, I mean, he is 63, but he is like a kid, and he forever wants to learn everything. So at night, he has to watch 4 different channels of the news because he says, I need to be open to everyone's way of thinking. I have to know what they're thinking. I'm like, oh my gosh. So he is continually trying to learn. And so he gets so excited when he learns something new. So thank you for helping him there. I got an important public service announcement. So Trish, the dish, who's in charge of registration, she says that these people need to go to the reception desk because she wants to make sure you get credit for being here today, and she doesn't have you down. Gerald Keller, and she has horrible handwriting, so I'm going to just try to, Benny Harrington, Noah, I think that's supposed to be Noah, Taylor, Thomas Bollinger, Ashley, and Drinkwater, James Gibson, Tim Smith, and David Beavers. So if I called your name, please go see Aurora. That's Princess Aurora, you know, from Sleeping Beauty. For those of you who know, that's her name. So anyway, go see her and she'll get you all signed up. And if you don't have a cool little name tag, that means we don't know you're here. And so you will get no credit for today. So that's another reason that you need to go to the reception desk. So now it's Tim's turn. Tim Sander, that's you, Tim. Come on. Hey, where's your little thing that I got you? Yeah, no, okay, thank you. All right. So we're doing Plant Tour Live, and he really kept thinking I was joking about that. I wanted him to have this to wear around his neck.
I should know better by now.
And so he's going to be doing Plant Tour Live, and so that's going to be right here. And when I have my reality TV show, I'm going to wear it all the time. So you get to see. It's a neck thingy. So anyway, Tim is our operations manager. He's been with us for roughly about 3 years. Time flies when you're having fun. So let me tell you what we do here. Well, just this last year. So for everybody's anniversary this year, we've given them a T-shirt that just represented them to us. And so Tim's T-shirt, just to know a little bit about Tim, is I only work to support my fishing habit. And that really is true. He just thinks about, oh, when's the next time I can go fishing? And he has twins that are 1.5-year-old. So he doesn't nearly get to fish enough because his wife thinks that they should do this 50-50 thing because he's part of the modern manhood and fatherhood. And so he has to do his share, which, yeah. So anyway, Tim started out as an intern with us and stayed on after graduating from Southeastern, and he's doing a great job. And Tim, why don't you tell them a little bit about what they're going to see out there? You want to go on and put all that on? That needs to have a phone.
So I'm glad we're clear that everyone knows this is her idea.
Yeah, definitely. They do it without me saying it.
So we're going to take a walk out there. We're actually just about to start production on. One of the structures. We're about to start pouring. These are some marine dolphins that will be taken out to Calcasieu Pass, and they're pretty intricate. They've got a weld ring that are cast into the bottom of them. They'll be set on top of a piling, and then the connection will be welded. And then they've got electrical conduit going through them. They've got ground plates and different weld plates for ladder attachments. So we're about to start pouring that. You'll be able to see that. And we have, for those of you who have attended in the past, quite a few things have changed out there. So we recently erected another 50-ton gantry crane, which doubles our capacity for the heavy precast, where we do the bridges and a lot of the large structures. We're in production, or we've already poured the slab. We're getting ready to erect another crane building that will house a 5-ton crane, I believe we're going with. And in there, we'll take a lot of the smaller structures that we have in our main crane building and move that production out there just to give us a little bit more space, because you'll see as we're walking through, it's getting a little crowded in there. Yeah. So that's it. We'll have a few other people joining us. Anybody with the Gainey shirts, if you have questions, just grab one of us and we'll be happy to answer.
And for those of you who are online, you can join us for Facebook Live. It's so exciting. I've always wanted to do this. So yeah, I know. It's not that complicated. You've had plenty of time this morning. Okay, so we need everyone to meet at the pedestrian gates. You can go out this door and get your hard hat and safety glasses. And Tim will be joining us. And Tim, don't get too distracted with all this going on in front of you. No, it's all good. It's all good. Like he's trying to get out of it. He is. This is so perfect. Take a picture of that, Cindy. That is just wonderful. I would love to have that around my neck all day.
Lucky for everyone joining us and watching this. I have.
pictures taken off yesterday. Yeah. But I mean, my HCs, like now. You do get eight. You do get eight. Yeah. So,
Not good. What about a new motor?
hey, yeah, I had to do surgery on the 28th. So I'm on FMLA right now.
Yeah, what above and beyond over here.
I just had my stairs taken off yesterday. Yeah, so. Like, yeah. Spurs, so they just moved out.
Well, they're already in there, so.
No. Okay,
I just want to confirm. Oh, two-bedroom home, that is rented. That's my home.
skipped over.
They just put this in up.
So, anyway, I finally convinced him, I said, look, also said, I said, I can design this stuff day and night. I said, I believe I can put it in.
Make sure.
We're gonna buy a little plant, put it in and small. So anyway, I got it convinced. So, we had it all installed. We had to put it in. I called maybe. Come out to do this inspection. I don't know if you want to go on. He said, I'm not coming out there to do this inspection. He said, right here. He said, you will hire someone to do it and it's certified. That's so that you don't have to go out for an inspection. Next paragraph it said, if you install it yourself, the health department has to come out and inspect it. I said, I'm calling, I did it myself. I said, I'm calling you to come out and do the inspection. He said, oh, Eric, he said, she's covered up.
What was she gonna do? Sheet the braids? She knows
I mean,
it's gonna float another or something.
no, that's right. I mean, we had all the equipment, all the know-how to do it.
Yeah.
And,
What did y'all install? I saw a system.
we just, it's a,
It wasn't a second thing.
we have a tail line that go out this little creek. Like a foot. I was trying to explain to her, I said, I'm not qualified to do it. We got problems. I said, I'm prepared for the work and prepared to engineer. I can't get it done. We got to have it.
I know it's something people were on, like, from like, over to the house. I see it's 130 people. It's gonna cost you more for that than it would if you put in a ETU.
Well, that's like, different years before that, I was different man, older man, working tough. I'm 60 Yeah, I need to spray it all. I got the tree growing up. Cut the tree, fire it back up. Yeah. I mean, I understand they'll certify this contractor to put me in. They don't have to see it. Somebody kept on it. One of those people.
This is kind of a mini conference, this is our standard, so let's try to make sure we still run
had a cowboy hat on, a white cowboy hat on, and Cadillac, he was involved. But he one day I said, "Hey, Bob, how long?" I said, "He quit." So, anyway, he made a comment that he wanted to be able to read where radio, the city name, from the interstate. That's about 2,000 feet from the interstate. It's power. How big is the weather there? That's really that far. So I'd seen some things that you couldn't see. Right. I started calling all the how big it had to be to see it. I calculated it out. It was like 9 feet. Then I had to worry about got the tank sitting up there. He brought on here radio. I'm going, well, I don't want the hard to be over here. Why over here? So I had to plan out, space up, so that I feel on one side. So it was working. So I go up there and say, what's that big tank? I do something. I'm not going up there. I'll hire somebody. I'm not going up there. Yeah. That tank's still there. After you got it. It's like 60, 65 feet. It worked out. There's a lot of math. I mean, you don't do that much math. Practice. That's just all learning. I don't know if you hear first guy was reinforced concrete calculation. I don't know all those calculations. See what he's doing, but I got a lot. Do that.
used to look for air gaps and stuff like that. Now we have a contact the buyers, have the buyers do it. We still look to see if we have different departments that we can not see and all that. But anything else we look. They look.
So that's a code,
Yeah.
structure. Yeah. We had that, building inspector, all, they was gonna ask us, y'all would mind getting this building. Yeah, that would be good. I mean, I did a little bit, few inspections and stuff, people out, they see it, and that kind of stuff. That was, I got to sit on, but I enjoyed it. I had to go back and stuff like, what you use parking lot.
Hey, can you hear me now?
Can't hear you. You can hear me?
Hey, can you hear me now? I don't think you can hear me. And I don't know sign language.
Two sets of wires inside the building.
I can't see it. Let's see. Hi, Sandy. Hmm. Okay. Right. And I was trying to swap that. So let me see if I can do that here. Good deal. It's
Heads up, we'll be starting in roughly about 4 minutes. So if everybody wants to grab that cup of coffee, snack, or the bathroom, we'll be starting in 4 minutes.
Try that again to share. Well, I'm trying to swap the screen views. That's the problem. Yep. Yeah. Well, usually it just use. Okay. There we go. Okay. Okay. Yeah. Okay. And let me, you can hear me? Okay. I will, just give me a thumbs up or something when I should start, or should I just start immediately? Okay. Okay. Okay, Paul, Paul, Nelson, Nelson.
2 minute warning.
Paul, Nelson, Nelson. Paul, Paul, Nelson, Nelson. Okay, last time. Paul, Paul, Nelson, Nelson. Is that working? Mhm. Okay. Well, what do you got for a local group there? How many? Okay, good, good group. Mhm. Good. Not a problem. You have another speaker right at 10:45. Yep. Okay. All right.
Okay, everyone, let's get to our seats for our next speaker, who's speaking on advanced filtration through cloth media disc filter. This was actually arranged by Coastal Process, and the speaker is Paul Nelson. He's with Aqua Aerobic Systems, and Paul is actually out of where today, Cindy? You don't know? Okay. All right, we'll just
Cindy,
make it
you
up.
want me to start?
Yeah. Yes, let's let him start.
Okay.
Good morning to all of you. Unfortunately, I can't hear any of you, but I understand that you can hear me just fine. This is Paul Nelson. I'm with Aqua Aerobic Systems. I've been asked this morning to talk about cloth media filtration. So I'm going to spend the next 25 minutes or so talking about that subject. And hopefully at the end, maybe we can get some questions the last 5 minutes or so. So to get started, I wanted to give you a brief introduction to Aqua Aerobic Systems. We're a company located up in Rockford, Illinois. We're about 10 miles off the Wisconsin border, right in the center of the state. And we have approximately 160 people working at our facility here, made up of engineering staff, manufacturing, and customer service people, about 25 people in customer service that travel around the country starting our equipment up. We were founded in 1969, and we have an applied engineering focus. And what I mean by that is the fact that we have engineers on staff as well as application people that work with consultants and end users to make sure that the equipment and the processes are applied properly for the application intended. We also do something a little bit different than a lot of other companies, a lot of our competitors. We continue to contribute more than 10% of our profits every year into research and development. And you'll see some of the results of that today, especially on the side of the cloth media filters. Before we get started on the filter, wanted to give you a little exposure to what Aqua Aerobic Systems offers. We have a full line of aeration and mixing equipment, both coarse bubble diffused air, fine bubble diffused air, and mechanical surface aerators and mixers. Biological processes, we're probably best known for our sequential batch reactor process, as well as a more recent addition, which is the Aqua Narita process, which is aerobic granular sludge. We have cloth media filtration. We'll talk about that, of course, today. Membranes, both polymeric and ceramic membranes for water and wastewater applications, and also ozone for oxidation and disinfection, and finally some process control capabilities to assist in applying all these processes to the applications intended. So let's talk a little bit about cloth media and the timeline basically for Aqua Aerobic Systems. The first in 1975, just to give you an idea, we've been in the tertiary filtration market for 40 plus years now. And the introduction was with the traveling bridge sand filter back in 1975. Over the years then, and starting in 1991, we actually brought a technology over, the cloth media technology from Switzerland. We took about 2 years to get accustomed to it, Americanize it, and get ready to market it and take it to the marketplace here in the United States. We ultimately received our first order in 1993 and installed it in a facility in Southern California. Since that time, we've added a number of other improvements and additions, different configurations. You'll see this throughout the years. This is a result of a lot of our research and development work that we do at the Research and Technology Center that we built in 2013. You'll notice throughout the years, the two things that really kind of stand out here is the development of 5 different cloths that are applied on the cloth media technology today, as well as a number of different configurations. We have our standard Model 54 unit, we have a mega disc, we have a diamond configuration, and we'll talk a little bit about all of those in the upcoming slides. So let's look at the design itself of the cloth media unit. There's 3 critical points I want to emphasize today. Basically, the media, the backwash mechanism, and the flow path through the unit itself. All 3 of these combined work together and form a very good unit, a very effective unit of removing TSS, phosphorus, and any other particulate that might be in your wastewater stream. You could say that maybe the media is the most critical, but if you can't get the media clean, then that would be a problem as well. So the backwashing certainly is a big factor. We'll talk about that a little bit further as well. And then finally, the flow path. Unlike any other filter that you see in the marketplace, the cloth media filter technology is one that does things a little bit differently in the fact that 100% of the solids and 100% of the flow into the unit. I should rephrase that, I guess, that 100% of the flow goes through the unit, but not necessarily all the solids are applied to the media itself. Because we're outside-in configuration, the solids, heavier solids, can settle out in the bottom of the tank, unlike any of the other types of filters, pressure filters, deep bed filters, etc. They all apply 100% of the solids onto the media. The end result, of course, is lower backwash rates and less volume going back to the front of the plant. So let's look at the cloth media itself. It's a woven cloth scenario versus, say, a knit or a screen type material. You'll see that in this case, we have 13 millimeter length fibers. We have a support backing, and there's a lot of variations here, a total of about 43 or 44 different types of variations in the media that we can construct. And of course, that's where our research and development pays off. We've had this particular cloth, as well as the other 4 cloths, developed specifically for an application that we see here in the U.S. marketplace. This particular blue cloth is what we call our PES 14. It was developed and designed for applications required for reuse, as well as lower phosphorus numbers. And again, we'll talk about the media a little bit closer when we're looking at all 5 of them. But what's common with all 5 cloths is that there is a support backing, and it's very important that you have a backing that is designed, again, for good cleaning and good backwashing. If you can't get the cloth media clean, you're going to have a real hard time getting the necessary flow through the unit. So the backing has this specific backing has wide openings. We call it an open back support system, and it allows a free path of filtrate water to be used as backwash source and for cleaning of the media. We'll go to an animation here in a minute and show you exactly how that works. Before we do that, though, we'll talk about the unit itself, give you an idea what the configuration is. In this particular case, this slide shows you a packaged disc filter. They're available both in concrete and package units, but it's common with all of them is a center tube that goes down the center of the tank. The filter disc is made up of 6 segments. It might be a little bit difficult to see, but there's 6 segments, what we call pi segments, that make up the disc assembly. We have a control panel that's typically mounted on the side of the tanks in the case of a package unit, and they're freestanding in the case of concrete units. In a 12-disc unit, we have 2 backwash pumps, normally about 2 horsepower each. We have 1 backwash valve for every set of 2 discs. So in this case, with 12 discs, we have 6 backwash valves. We have a solids wasting valve and a collection manifold in the bottom of the tank. And we have an influent weir that flow comes in, flows over, and then of course, finally, a 3/4 horsepower drive that turns the center tube and the disc assemblies. One thing I want to certainly emphasize to you is that the disc assembly or the disc unit has a static filtration mode. So basically flow comes in over the weir and there's no movement in the tank whatsoever. The only time the unit rotates is during the cleaning process or the backwashing process. And that typically would be every, on a conventional activated sludge system, anywhere from 20 minutes to maybe up to 3 or 4 hours, depending on the solids that would be coming over the clarifier weirs onto the filter. So let's look at an animation of a 6-disc unit here, and we'll break it down a little bit. But basically, flow comes in. The solids, of course, are in the wastewaters. It drops into the tank itself, and of course, the solids are going to accumulate on the surface of the media. As the solids accumulate more and more, we're going to build up a dirty layer. We're going to build head in the tank. Once we reach about 14 inches above the top of the disc assembly, we're going to initiate a backwash. When we do that, we're going to turn on the backwash pump, turn on the drive motor, open up 1 backwash valve, and basically we're going to vacuum the solids off the surface of the media. We have a backwash shoe that's on each side of each disc in a very close proximity. We're vacuuming the solids off. What we're doing is pulling clean water from the inside of the disc back out in the opposite direction. We're going to rotate for about 67 seconds, close the first backwash valve, turn on the second backwash valve. We're going to, again, backwash and rotate for 67 seconds in the next set of 2 discs. And then finally, we're going to open up the third valve and backwash the final 2 discs. At the end of each backwash process, the operator has an opportunity to evacuate the solids off the bottom of the tank, any solids that might have settled out in the bottom of the tank. Typically, an operator would have that occur every 5 backwashes. Depending on the plant, it could be as many as maybe 10 backwashes, depending on how many solids would be coming off the clarifier and not getting filtered out. We do that with a 4th valve, which is our solids wasting collection valve. And you can see we have a manifold system in the bottom of the tank that we evacuate those solids off the floor from. So again, the filtration mode is static filtration, nothing turning in the basin. It's just flow coming into the tank, flow going through the cloth media, solids being collected in the media and on the media, into the center tube, into the effluent chamber, over the weir, and downstream to your disinfection system. So it's a very simple process and provides a very effective effluent quality. Typically, following a conventional activated sludge system, you should expect about 5 milligrams per liter or less TSS. Now, as those solids accumulate on the media, we have to get them out off the media. We use depth filtration. The media has depth to it, and so you have the ability to store solids in the media and build a dirty layer of solids on the surface of the media. As you ripen the filter, we call it a ripening period, you actually get better and better effluent quality as that filter ripens. But at some point, it gets so dirty that it recalls or calls for backwashing. And during that process, we're going to backwash at a rate of 130 GPM per backwash pump. You may have one pump or two pumps depending on the size of the unit. And basically you have this backwash manifold or shoe that sits adjacent to the cloth media. We're going to pull the clean water from the inside of the disc back out in the opposite direction and collect it in that backwash manifold. As you can see, during this process, we continue to filter the rest of the through the rest of the media. So we're taking out less than about 1% of the filter area for backwashing. The other 99% continues to filter and remove solids. It's very important that you get a very high velocity of water through the backwash manifold to scour all those solids off the media and make sure that you get a rejuvenated filter media after each backwash. So this video here is a video where we actually were asked to take the water level down in the tank of a dirty filter. A mayor of a city actually wanted to see the effectiveness of the cleaning of the media. And so we drew the water level down, and you can see, let's back up here. You can see we drew the level down in the tank so you could have a little better look at the media itself. And as it turns around here, you'll see where the backwash actually started up. And you can see that right here, the backwash pumps came on, we started rotating, and now it's rotated to the top of the tank here. And so you can see the dirty media here, and after backwashing, the clean media. So it does a very good job of cleaning the media, keeping it clean to allow a good filtration and long-lasting filtration. So now let's look at the media itself. We have 5 different medias that are available. This is a PA213. This is a 10 micron, nominal 10 micron cloth media. Has a polyester cloth with, nylon cloth with a polyester backing. This was one of the original nominal 10 micron medias. Then we developed a PES13. This is the polyester fibers on top of polyester support backing. Again, nominal 10 micron for TSS removal. Then as the tighter limits became more prevalent around the country and lower phosphorus limits, we have been working on getting better effluent quality media. We developed a PES14. This is a nominal 5 micron cloth. Again, polyester over polyester, but it's used for low levels of phosphorus removal as well as reuse applications for lower TSS limits. And then another one that we've developed more recently, this is a UFS 9. This is a nominal 2 micron. Very uncommon that you would need this in a typical wastewater application, but we do see some industrial applications and some specific municipal applications that call for a really tighter cloth here. And so it is a nominal 2 micron. Where you pay the price there, you get a greater capture of solids, of course, but you also backwash considerably more, and the flux rate is considerably less. So some drawbacks with it, but it also gives you much better effluent quality. And then finally, we have a PF14 cloth. This cloth is a nominal 5 micron rating. This cloth is used for applications in 2 other auxiliary type treatment processes, and that would be what we call our AquaPrime unit and an AquaStorm unit. AquaPrime would be used as a primary clarifier replacement. So if you have a chain and flight clarifier mechanism that needs replacement, you could consider a AquaPrime unit with cloth media technology to remove TSS and some BOD. Typically, through a primary clarifier, you're going to get 65% TSS removal. With this cloth media technology, you should expect about close to 80% removal of the TSS. BOD removal is going to be around 60%. Another application that we see, some plants that are requiring additional capacity, rather than expanding the plant, they can take some of the organic load off the biological system and get a little bit better removals up front by removing some of these TSS and BOD loadings from the system. And the problem is you would need maybe anaerobic digestion, because you're going to have a lot of solids. It's like a primary clarifier. And so you would have to deal with the solids that you're going to be removing. But it would take some load off the treatment plant and allow you to pass more flow through the treatment plant without expanding the entire plant. The other application would be the AquaStorm, and that again is designed for higher solids. And what we're seeing in the Southeast now with a lot of the storms, I know down there in Louisiana, you've been getting more than your fair share of storms with high flows. Typically, a plant might be designed for 1 or 2 MGD with peaks maybe double that. But during some of these storm flow events, we're seeing flows 5, 6, 7, even 10 times the factor for flows through the plant. And in order to get the flow through the plant without having some overflows or spills or anything, you could put in an AquaStorm unit and you take some of the load off the treatment plant, the biological treatment plant, get some BOD removal, get some TSS removal, and then recombine it with your plant effluent to still remain in permit level with the AquaStorm unit. So let's look at the design itself. We talked about the media. We rely on the benefit of depth filtration significantly. And there's some mechanisms out there, a disc configuration, which basically is a microscreen type unit. When you look at a textbook and you look at the removal mechanisms of taking particles out of a flow stream, you'll see 6 mechanisms. And with a microscreen, you have one of those mechanisms working for you, and that's surface or straining mechanism. And basically what that is, if the solid is larger than the opening in the screen, then you're going to probably most likely remove it from the stream. Unfortunately, what you see is some of those larger particles sometimes actually can slide through the screens because of their actual makeup or configuration of the particle. And so you're not able to remove some of those larger particles even, and definitely anything smaller than the mesh size opening, a 10 micron or 15 or 20 micron mesh opening is going to pass right on through. It's a lot like your headwork screen. If you look at depth filtration, and that's associated with sand filtration and cloth media filtration, you have not only the first mechanism working for you, but you also have the other 5 mechanisms working for you. Sedimentation and impaction, flocculation, adhesion are some of those other mechanisms that are working for you. And basically what it means is basically you've got a toroidal, treacherous path for any particles to get through the media. And as you store more and more solids in the media itself, it's more and more difficult, of course, for solids to pass through. So those mechanisms are working for you with cloth media technology, just like it is in a 1 foot deep sand filter, or maybe even a 3 or 4 or 5 foot deep sand filter. Depth filtration is certainly a big advantage. So here's a good example of a wetted condition of the media. Typically, these are 10 millimeters in length, the fibers themselves, but when they lay down in a wet condition, they're about 3 to 5 millimeters. And so there is a great deal of depth filtration capacity there. You're going to store solids in the media and build up that smoosh deck or dirty layer of solids on the surface of the media. As that filter ripens, you're storing more and more solids, more and more built up on the surface area. Your straining effect gets even greater, and you're going to remove more and more TSS, which is the main objective. So the longer the filter run, the better the effluent quality. In contrast, then, in a microscreen, you have a screen that's 0.06 millimeters in thickness, And you can see it's labeled 10 micron here. And if the particles are less than 10 microns, they're probably going to pass right on through the screen. If they're larger, you're probably going to strain them out unless they're able to because of their configuration or makeup of the particle itself, they might still be able to squeeze through there. But typically, you're going to do a pretty good job of removing anything larger than the 10 microns. This is a graph of a study that was conducted a few years back, comparing the microscreen versus pile cloth media filtration, rapid sand filtration, and pressure sand filters. And you can see on the x-axis the micron size of the particles, and you can see in the graph itself that the microscreen did a pretty good job all the way along there until it got less than 10 microns, and then you got poor and poor results compared to the other technologies using depth filtration. So just keep that in mind, I guess, when you're looking at technologies. If you want to be able to remove as much TSS as possible, you want something that has a depth filtration working for you. And finally, we'll talk about the mechanical configurations here. This is what we call our mini disc. It's, again, available in concrete or package, but each disc has about 11 square feet, and that relates to about 50,000 gallons per day on average flow capacity and 100,000 gallons per day on a peak flow basis. You can put up to 10 discs in a single mini disc unit. In contrast, we have our model 54 unit, which is 54 square feet per disc. That's 250,000 gallons per day on average, with a peak of 500,000 gallons per day per disc. And we can put up to about 14 discs in a package unit or a concrete unit. Larger units, we call our Aqua Mega Disc. This has 108 square feet per disc, 500,000 gallons per disc, with a peak of 1 million. And we can put up to 24 discs in a single tank, so up to 24 MGD peak flow capacity. These are the types of units that we're using on some of the larger plants for AquaStorm and AquaPrime to take some of the load off the systems. And then finally, the last configuration is our Aqua Diamond. This is basically developed, and again, relating back to our research and development work, to replace traveling bridge sand filters. There's a lot of them out there. We have Aquarobic Systems has a lot of them themselves, but also some of our competitors. And the cloth media technology can be used in replacement of those traveling bridge sand filter basins. Here you can see a little bit of our experience, about 3,000 units throughout the world. Our largest plant in the US is San Antonio with 312 MGD, right on down to some smaller units. You see Conway here at 9 MGD, but our smallest installations are less than 50,000 gallons per day with mini disc filters. Some of the applications, of course, discharge for surface water is just basically TSS removal to stay within the permit limits that you might have for TSS. Reuse, typically about 5 milligrams per liter, depending on what state. And then phosphorus removal, that's probably the most active growing area that we see across the country, is the removal of phosphorus. And a few years ago, a tight limit on phosphorus was maybe 1.5 milligrams per liter. Now we're seeing limits in Alabama as low as 0.043 milligrams per liter. So that area is really growing, and a lot of the reasons for tertiary filters being added to treatment plants. Industrially, we do some work in the power industry, refinery, petrochem, chemical areas, as well as food processing and beverage areas. Just about any industrial type application, textile included. Some of the more innovative applications are primary filtration, stormwater, we talked about that, as well as microcontaminant removal. And one that's becoming more and more popular over in Europe right now is microplastic removal. I think we're going to start seeing that in the US marketplace a few years down the road. Just a quick glance here at pilot filters. We have a lot of them available. These are all for tertiary applications. Our large trailer unit has flocculation tanks in it, chem feed capabilities. We also have other units that have chem feed capabilities, again, maybe for phosphorus removal type applications, but a number of units available should you need to pilot test an application. And then on the AquaStorm and AquaPrime units, we have, again, a number of units that travel around the country. Those units are typically taller units because we have a little more room in the bottom of the tank and a little more room on the top of the tank for floatables and for solids settling out in the bottom of the tank. So again, a lot of applications in that area that might be to your benefit. Lastly, last slide here, the 3 critical points is the cloth media technology and the backwashing. Those 2 points are very, very important, that you have a good engineered application or cloth for the application intended. It's not a cloth that just comes off the street and is applied to wastewater. And then, of course, the ability to get the media clean. You can't overstate that. You can do or find a cloth that removes TSS, but in order to have a good filter, you got to be able to also clean it. And so the backwashing mechanism is very important. And then finally, the flow path through the unit. This cloth media disc mechanism allows solids to settle out in the bottom of the tank. We're not filtering 100% of the solids. We're only filtering the ones that are a little lighter, and we can evacuate the heavier solids off the bottom of the tank. And that is it. Thank you very much.
Yeah, so Todd, you're on. Does anybody have any questions for Todd? I guess Paul did a great job, huh? No, Greg. Actually, I'd rather if you go out on the plant, so that way it can be my show. All right, our next speaker is, let's do a round of applause for Paul, who zoomed in, and thank you to Coastal Process for arranging that for us. We really, really appreciate it. Thank you. So our next speaker is Brandon Lamassney with Technical Coatings, and it's a rare moment that we catch him not on the phone. So we're going to take advantage of this 30 minutes where he's not on the phone and get him to speak to us about Performance Matters. He graduated from the University of New Orleans in electrical engineering, and he has been with Technical Coatings right out of graduation, making it happen.
That's it.
That's right. Okay, here you go.
Thank you so much. I'm gonna probably just scoot over here, or does it matter?
Yeah, I'm sorry, real quick, I just want to make a quick announcement that's been bugging me about
Okay.
this. If you don't have a name tag, please see the front desk and get your name tag. Thank you. Yeah, you gotta click it over.
Okay. All righty. Well, listen, thank you for Lisa for the opportunity to be here. I guess 3rd or 4th consecutive. Wouldn't miss it. My name is Brandon Lamassney. I'm with Technical Coatings, and we are a manufacturing representative for a couple of different products that maybe you're familiar with, one of which would be Zypex concrete waterproofing, and the other one is a company called Tanemic High Performance Coatings, and that's sort of really what we're here to talk about today is coatings. The title of the presentation is called Performance Matters. And as you'll see, what we're trying to get into here is a life cycle cost analysis and what provides owners the best benefit, best bang for your buck. So we titled it Performance Matters because it truly, truly does. All right, so just to give you a little bit of an overview, we want to talk about life cycle cost, what components affect the life cycle cost, and more specifically, what components really drive life cycle cost. And ultimately, our goal is to try to reduce the life cycle cost as much as possible. We'll talk a little bit about formulation. There's no chemistry on this thing, but we'll just dabble into it a little bit just because some of the questions that we get is, hey, listen, all paint is the same, right? And the clear answer to that is no, it's not. different coatings perform differently, and they can affect the life cycle and the life cycle cost. And then the third is evaluating and predicting life cycle cost. So really what happens here is the life cycle cost is driven by the life cycle. Okay. And in order to determine the cost, we need to have an idea of how long these coating systems are going to last. So that's the concept behind this little aspect. Okay. So by definition, life cycle cost incorporates several factors, right? It incorporates the initial cost, it incorporates the maintenance cost, operating cost, and the cost of maintenance as things go along, okay? For the purpose of our presentation, though, we're just going to talk about the initial cost, because once the coating needs to be reapplied, that life cycle is essentially over, okay? So for the purpose of our presentation, while it does include a maintenance component, and while it does include an operation component and a final cost value component, that's not really what we're going to talk about today. We're strictly going to focus on the initial cost. Okay. So what we can say without question is the system that provides the lowest life cycle cost provides the owner with the best value, right? The system that costs the least amount of money per square foot per year of service life is unquestionably the best value. We also know that life cycle cost is a function of two variables. It's a function of, in our case, the initial cost divided by the life expectancy of the coating system. Okay, so our goal should be to minimize the life cycle cost that provides the best value to the owner. In order to do it, we see it's a function, right? It's just an equation, okay? So we can either reduce the cost of the installation, or we can increase the life expectancy of the coating system, okay? All right, so when we talk about initial cost, there's a lot of variables that affect the cost, okay? You've got the actual cost of the coating. We've got the cost of the consumables. That might be the gasoline or the diesel or the propane or the rags, the brushes, those types of things. We've got containment. Okay, sometimes a situation arises where we have to contain the blast media. We have to dispose of the blast media. The contractors are in it for a profit, right? So all those things affect the life cycle, the installed cost. But the material component is a relatively small percentage of that, okay? So we've got this complicated equation up here, which I hope nobody asked me exactly what it means. But what's most important is what's highlighted. Okay. I'll give you the mic if you'd like to have it. Don't make me look bad, though, okay? All right. So what's most important is what's highlighted, and it's that ratio, okay? It's as a general rule, the material cost is 15% of the installed cost. So even if you're talking about a material that costs 20% more, it only represents 3% more of the total cost. Okay, so clearly saving money on the material isn't necessarily going to help us reduce our life cycle cost. Okay, is all paint the same? Hopefully, I'll be able to explain to you that we don't believe it is. Very simple analogy. Okay, most of the high performance coating products that you're using or would be using are two component products. So you have a part A, then you have a part B, then when you mix them together, you have the final product. Okay, very, very simple. Okay. But in that part A, and really you could make the argument for the part B as well, there's different ingredients, there's different components. Just like when you bake a cake, you might have milk, you might have eggs, you might have butter. In paint, you're going to have resin, you're going to have solvents, you're going to have pigments, you're going to have fillers, you might have 6, 8, 10, 12, 15 different components that go into just that part A, and you probably have a similar number of components that would go into the part B. Okay. Each different ingredient would have a level of performance. Okay, so maybe this particular resin system, you've got an epoxy, you maybe have a really high quality epoxy. You might have more of a cost-effective epoxy driven more by economics, and then you might have one in between. Okay, so for all those 10 components that we might have, we might have 3 different versions from a quality and cost standpoint. And then of course, so that leads us now, there's 30 different variations between, what we can have, the different components, different ingredients in just this part A. And then when we figure that there's not just one single manufacturer that's providing these epoxies, okay? There might be manufacturer A, manufacturer B, manufacturer C, maybe D, E, F, okay? And they all are providing a different product that's a little bit different than the others, maybe a lot different, okay? So what we're winding up with is this little part A component that initially seemed very, very simple now has 90 different variations that you can have within this component. And we didn't even get into different ratios. So you can have different products. You can have a one epoxy coating that could have 40% epoxy resin. The other one could have 20%. My point on this is there's a lot of ways these products can vary, both in terms of cost and in terms of quality. All right, so again, I'm going to defer to the formula. I'm going to skip over the formula, but if you just look at the result, what I do know in my simple math mind is 1.75 to the 10 to the 26 power. It's a big number, right? It's a big number. So the point on this, hopefully I haven't beat a dead horse, there are a lot of formula variations between products, okay? There's a lot of formulation differences, okay? So most of the guys and the folks in this audience are not chemists. I think Greg is, right? Okay, so we have one, but most of them aren't chemists. So we don't really have the ability to look at a technical data sheet and look at an MSDS sheet and determine how well these products are going to perform. It's or smell it. Okay. So maybe there's different methods, okay? But the point is it's very difficult to look at the information on a data sheet and an MSDS sheet and really determine how well a product is going to perform. So what do we use? Well, one method is testing. This is a way of sort of differentiating the products, okay? So if we go back conceptually, what we talked about in the first couple of slides, our goal is to minimize the life cycle cost. We've already talked about that. That provides the owner the best value. And we've also determined that the material cost plays a very small role in the life cycle cost, but the life cycle or the life expectancy of the coating does. How do we determine life cycle, right? That's the big question. If this is what really drives the cost, we need a mechanism for determining life cycle, okay? The best approach are case histories. If you can take a product that's been used in a similar environment to what you're going to use, then you have some way of estimating and gathering how long this product is going to last, okay? In this case, this is a Port of Baton Rouge tank. It's one we did back in 1996. It's right on the southwest quadrant of I-10 in the Baton Rouge Bridge. So this owner in the mid-1990s made a decision to use a high-quality coating, and other than the logo, the coating system is 25 years old. Now, if he could have, spent a little bit less money, and he may have had to repaint this instead of once in 25 years, he might have had to paint it 2 times or 3 times. So there was a tremendous value to his coating selection in this particular case, okay? Now, if we're using case histories to determine life cycle, how do we introduce new technology? Because, right, it's the chicken or the egg. If you're telling me I need case histories to be specified on a project or to be used on a project, how am I ever going to get case histories with my new product, right? So what we can do is we can use accelerated test data. So we have a project or a system that was used successfully, in this case, 24 years. We have test data associated with that particular product. We can use the accelerated test data for the newer technology. And if we see similar performance on the 2 tests, then we can reasonably conclude that we would expect similar results, similar performance, okay? How not to determine life cycle, okay? The product rep said the product was good. Okay. A news flash, right? All right. Be leery when you're told all products are the same. Trust me. You can't rely on test data. There's just too many variables. Okay. What I can tell you is if you don't have case histories and you don't have test data, it's very difficult to really have an understanding of how long a product is going to last. Okay, what accelerated testing is not used to? It's not used to predict how long someone is going to last in and itself. Okay, what do I mean by that? Well, you have test data that says this product is going to last for 5,000 hours in this accelerated test. How long is it going to last? Well, conditions in Florida are different than conditions in Kansas City. Okay, this is one standard test in one situation. So you can't draw those types of analogies. But what you can do is you can use the test to, number one, compare the different materials, similar materials, generically, epoxies with epoxies, zincs with zincs. Okay, or you can use them in the case that we just said. You have a basis for comparison. You have a product that you know has performed to your level of satisfaction for a number of years. That product maybe had 6,000 hours of salt fog testing. The newer product that you're looking at maybe has 5,500 hours of salt fog testing. They both perform very similarly. You have a good indication that this test data or that this product is going to perform, similarly to what you're already using. Okay, so I've included just a couple pictures. This is from the Tanemic lab. The products that are tested are heavily vetted, not just initially, but during market introduction and then further on. And don't forget, all manufacturers are using this testing, right? Because you have to have a way of determining if the product meets at least a benchmark, a minimum level of quality. So everybody's using these tests, but there's a couple here that you can see. He's actually doing an adhesion test. So he's got a coating that was applied to the steel. He's cross-cutting it, and he's doing a tape test. He's measuring adhesion, which would be an important property to have. This is actually a salt fog chamber. I'll talk about this a little bit more, but just thought I might throw a few of these little images in here, what takes place in the labs. So what I've mentioned a little bit about accelerated testing, what tests are available. You have weathering tests. So you've got QUV tests, you've got a MAQUA test. If you had a finish coat in an exterior environment, these tests would be very important for you in order to determine how long the color and the paint is going to look good. In the case of salt fog or prohesion, these tests are used to determine corrosion resistance. So they would be very, very important for a primer. If you had a pipe project, maybe a force main, abrasion resistance at that point might be an important criteria for you. But there's a whole host of tests in the coatings industry that allow you to evaluate and compare the products. All right, so the weathering test, and I promise I'm not going to get into the weeds, but just some basic information to know. Okay, so this ASTM, this is ASTM D45, 4587. It's a QUV test. It's an accelerated bulb. We use what's called an A bulb because it more closely resembles the sunlight. It's a cyclic test. So you're measuring, it's 8 hours, 4 hours of UV, 8 hours of condensation. You take the initial color, the initial gloss, and you compare it to the final gloss and the final color after a certain amount of hours. There's no minimum, there's no maximum. You're just running these tests to see how long these products will last. A MAQUA is a little different test. What we're actually doing is we're taking these big, large mirrors and we're focusing the light. Now, this is actual sunlight onto the panels. Okay, so in this case, it is a real world test, but it's 6, 8, 10 times the energy that regular sunlight would see. So it gives us quick results, but it gives us actual UV results. Okay. Of intensity. Yeah. I was going sci-fi on you today. Okay. All right. So here's what I'm showing you, right? So this is how the information would be reported to you, or this is actually the results graphed. So the one on the left is the Omaqua test. It's 5 different products that were tested. Okay. So what you're looking at here is the vertical axis is your gloss level. Okay. So everyone starts at 100%. And then your horizontal axis, your x-axis, is a function of the intensity. Okay. The amount of megajoules of energy that this particular panel saw. Okay. So you can see immediately that, and ideally, the longer and the flatter the curve, okay, the better the product's going to perform. So in the case of the gray and the black, those almost crashed immediately. That's an aggressive test, but these all products are all generically similar. They're all fluoropolymers, high color and gloss retention, okay? But the black and the gray lost its color retention almost immediately. The green and the yellow, it went out further, but, it crashed after about 3,000 hours. And then the red one outperformed them all by a considerable amount. So it lasted almost twice as long. So why do I bring this slide up? Okay, it gets back to what we talked about before. If you look at a technical data sheet, these products are all going to say that they're fluoropolymers. Okay, but if you don't look at the test data, you could wind up with that performance. Okay, and you may have to repaint your water tank or your treatment plant in 6 or 7 years, as opposed to being able to go out 15 or 20 years. Earlier, I skipped over, but I had a picture of the Jefferson Parish water tower. Okay, those water towers, they were painted in 2001. They're just getting ready to start painting these towers. Truth be told, they probably could wait a little bit longer, but the problem is they have so many tanks that they got to start the process moving along. Otherwise, by the time they really need it, the last set will be just, will be too far gone. So my point on this is formulation, the quality of resins, the percentage of resins that you use, they drive the performance. And there is quite a difference in the level of performance between materials. In the case of the graph on the right, this is actually real world South Florida. So South Florida has the most intense sun. That's where we go to get our suntans, go to the beach. You'll see similar results, right? The black and the gray crashed first. The green, crashed somewhere in the middle. And then the red outlasted everything. So whether it's an accelerated test or a long-term test, the results are repeatable. They are consistent. Okay, this is just a blown up version of the last slide. Okay, so a graph is one thing, data is one thing. How does this actually look to my eye? What does it really look like? So the 3 on the left are the fluoropolymer. They were after about 9 years of exposure, UV exposure. And the third one is what we refer to as a polysiloxane. Now, truth be told, polysiloxanes and fluoropolymers, different technology, but it just gives you an idea of how these products will look, after a similar exposure, right? After 8, 9, 10 years of UV exposure, that red is almost pink for this particular product, but the fluoropolymer, the red, it's fire engine red. It's just like the red that you got, on the service road here on those fire trucks. The light blue has almost turned to a gray, whereas the 2 dark blue, the blue and the gray, they've maintained their color and gloss retention very, very well. Okay, salt fog test. So this is another accelerated test. It's probably one of the oldest corrosion tests in the industry. It's ASTM B117. It's a 5% salt solution, 100% humidity, 100 degree weather. So it's really a ripe situation for corrosion to take place. You take these panels, the coated panels, you scratch them down to the steel. So the idea is to try to evaluate the panel both for the blistering, rusting on the plane, as well as how much rusting takes place in the damaged area. We refer to that as screepage. So that's the cabinet. And then these are the different panels, right? So what you're seeing here, the panel on the left is uncoated. After 32 hours, it's caked in rust. No big deal. That's really what we would expect, okay? Salt and moisture bad combination for uncoated steel. As we kind of move from left to right, the second panel is an alkyd, okay? This is technology that is still used today, but primarily more 30 years old. You can see after 500 hours, we've got creepage at the scribe, which basically means that in that scarred area, I've got rust taking place between the steel and the coating. And I've also got breakdown on the panel. And then as we move to the epoxy, now this product has been tested for 4,000 hours, so 8 times longer than the alkyd, and there's no rusting on the plane, no blistering or anything like that, but we do have some creepage at the scribe of about 1/8 of an inch, okay? And then as we move on to the zinc is the best, most corrosion-resistant product we can offer you. After 10,000 hours, it looks better than the epoxy did after 4,000 hours. So you can look at these pictures, or you can look at the way the test data is reported, and you can clearly determine that if you're looking for corrosion protection, this type of technology is your best option, okay? Now, there are not just ASTM tests, but there are ASTM methods for evaluating it and providing a rating, a number. 1-inch creepage at the scribe, 1/8 inch creepage at the scribe may correspond to a 7. 0 might be a 10, but there are ways of quantitatively evaluating. So again, you could look at this and you can determine this is the better way to go. You could also look at the data and see if one zinc primer is as good as another. Okay, so really to kind of summarize what we want to share with you, life cycle cost, it offers the owner the best bang for the buck. It really, really does. The lowest life cycle cost offers the best bang for the buck. The product that offers the lowest life cycle cost offers the owner the best value. Because material cost is such a small component, we showed it earlier, it's only 15% of the total cost of the installation. It has a very, very small bearing on the life cycle cost. What really drives it is the life cycle. So if you can find something that can last longer, you can, you can really do yourself some good. Product quality can vary from formulation to formulation, just like it can with concrete. The ingredients in the products make a difference on how well it's going to perform. The combination of case histories and test data can be used to help predict the life cycle, which is a key component in finding the life cycle cost. And I guess the main point here is performance matters.
I have one question.
Okay.
Here comes the chemist.
Okay.
And then a comment. So thank you. So
Right, they're not gonna be, you gotta get the mic up here. You gotta get the mic.
when you were giving the accelerated weathering with intensity of light, did that alter the surface temperature and did it turn it into a temperature resistant test?
Okay. So the short answer is I'm not sure if it did. It's not necessarily like a magnifying glass that actually focuses in a very small area. It distributes all that energy over a large panel. In fact, this is not exactly what the test, but it'll kind of give you an idea. Okay, that's probably a better idea. So that's kind of how this would work. So you're not necessarily focusing all this on a small area. You're focusing it over the entire panel. Okay.
Other questions? Do you test each of your paints with different levels of plastic also?
Just repeat the question for the audience, please.
Okay. Do you test the products at different levels of blasting? It's a really good question. The answer to that is yes and no. And so let me see how I can answer that. When you're using the accelerated test, the idea is to take as many variables out of the equation as you can. Okay. So when we run our test, and most manufacturers run the test, we run it over what we would call an SP10, which is a near white metal blast. As you start reducing your surface preparation, then you introduce other variables in the equation. An SP7, for instance, could really vary in terms of what you wind up with. So in most cases, the data we're going to run is going to be over an SP10 high level of prep. but we do have some products that we test over an SP7 more because those products are more designed to go over that type of surface. So yes and no, but the vast majority of what we test is going to be over a really well blasted surface in order to eliminate variables as much as possible. That's a great question. Okay. Okay.
So I pride Gainey's on not really just buying proprietary claims. And so we're evaluating materials for use here in our precast plant or out on contracting. I want engineering data, and I want comprehensive engineering data. And then I want somebody that I can talk to that is familiar with that data that can answer questions. And so Tnemic, as a brand name for me, the minute I see it, I know that they're professionals. I know that their products are well qualified. They're high quality. And it always comes with somebody who has studied the data that can actually have a conversation. So they're at the top of the chain for me when I'm selecting materials, because I know I can count on the brand. I know I can count on the data, and there's somebody for me to talk to. Back to you.
Thanks, Greg. Okay, appreciate that. Thank you so much.
I think you knocked it out the park.
Okay, well, good. I hope was it long enough?
Exactly on time.
Oh, geez.
Now you can go get back on the phone.
All right, sounds good.
I'm telling you, this man is always on the phone. Yeah. And speaking of someone else who's always on the phone, who's not with us today, is Gary Carbine from Delta Process. And so he has sent, are you like Robin to Batman? Are you like his Robin? So Gary was slated to speak today, and he told us that he sent someone much better looking. Look at that dynamic smile. You'll take that one? Okay. And so it's Stephen Bearfield with Delta Process. He's 32. He's a graduate of LA Tech. He's been in manufacturing in Delta for roughly about 2 years. He says he doesn't have any hobbies because he has 2 little boys who run him ragged. So remember those days? Oh, I know, it's painful. Yes. So one of the questions that we get asked the most from our design team side is about sewer lift station design. And so whenever we're looking for topics to talk about during these conferences, we always look, okay, what's the one that we've got the most questions on? And this is one that we get a lot of questions on. And so thank you, Delta Process. Yeah, Cindy was going to have to do it, and so she was really, really glad when Stephen stepped up to the plate. Here you go, Stephen.
Thank you. You ready?
Yeah, you're on.
Okay, my name is Stephen Bearfield. I work for Delta Process Equipment, and today we are going to discuss sewer lift station design. Quick commercial here. Like I said, we work for Delta Process Equipment. We operate primarily in Louisiana, Mississippi. We have offices and full service shops in Ruston, Denham Springs, and Mobile. We offer water and wastewater equipment. So if we can ever help you with design or equipment selection, please let us know. Okay, today we are going to discuss sewer lift station design. All the components that come along with it. We're going to go through determining our flow rate for the applicable dwelling. We are going to run through wet well sizing, elevations being established within the wet well. We're going to talk about force main data, static head, friction loss with the associated discharge line, you name it. And then we're going to get into some down and dirty pros and cons of some different pumps available for selection today. So if you need a nap, now is the time. Okay. We use the State of Louisiana Administrative Code and associated DHH information. It is the 10 state standards. And what these standards do is act as guidelines for the design review and approval of plans and specs when it comes to sewage collection or sewage treatment systems. I think the 10 states comes from, I believe it's 9 domestic member states plus a Canadian province. And these rules and regulations are enforced and monitored by the DHH or the LDH, I think as it's known locally, to ensure compliance. In fact, These 10 state standards are now codified in Louisiana and are ultimately the law. So when we're asked to design a sewer lift station, question one is typically, what's the application? What are we serving? Not only does that ultimately help with the ultimate equipment selection, but we got to start somewhere, and typically where we do is flow rate. So if you dig deep into the Louisiana Sanitary Code, you come across Chapter 15. Within Chapter 15, they list a number of different dwellings as well as the daily average flows associated with said dwellings. So if I wanted to, I don't know, design a sewer lift station for a bowling alley, I would come to this nifty chart and say, okay, I need to account for 75 gallons per day per lane. Please do not ask me how they come up with those rates, because I cannot answer that question. I assume that was the responsibility of someone significantly smarter than me. Continued, you can look at flow rates assigned to mobile home parks, motels, office buildings, retail stores, you name it. They typically have everything required in here or the equivalent.
I'm going to jump in.
Please do.
So he is 100% right. When you are sizing hydraulically to do your lift stations, please use those numbers. Hear me, engineers. Please do not use those numbers to size your sewer treatment plant. We have to size off organics for the most part, and that's usually going to be a higher, different number because we have higher concentrations in sewer. So everything he's saying is completely accurate, but think of it only in hydraulics as the amount of flow we're putting through the lift station. And pop quiz, can you tell me which one actually has more hydraulics than organics? Which application on DHH code?
No, absolutely not.
Hotels. Think about all that washing they have to do.
That's a fair point. Yeah, look, another shameless plug. If you ever need to design a sewer treatment plant, just call Gainey's. Don't call me. Okay, I think we are actually going to run through a real world example here. Let me lay this out for you. We are apparently going to build a 200 home subdivision. It's going to be a single central collection of the sewage system. We're going to look at, like I said, the elevations associated with the wet well. We have apparently chosen to pump 3,000 linear feet to a receiving manhole. The customer and or the engineer would like a submersible pump station, and we do have 3-phase power available. So like I said, my starting point when it comes to lift station design and ultimately sizing the system, I'm going to start with my flow rate. This is a 200 home subdivision. So for every home, we need 400 gallons per day. So let's start down that trail. I've got 400 gallons per day times 200 homes to complete the subdivision. That gives me 80,000 gallons of daily average flow. We will take that number and divide by 1,440 minutes per day, and we will get a gallons per minute version of our daily average flow rate, and it comes out to 55 gallons a minute. Okay, here's where it gets fun, okay? So when it comes to actually sizing the pump, we need to run through some additional calculations. And what we're going to do here is we are going to determine the minimum flow rate or the minimum pumping capacity, as well as the maximum acceptable flow rate or maximum acceptable pumping capacity. I think what we typically see when it comes to sizing a pump for a particular station or application, we often see it stop at the first calculation. It's easy to divide a total flow by 1440 and get a gallon per minute rate, multiply it by 4, which is the peak factor established in the 10 state standards. And we often see it stop there, which is fine. That's perfectly acceptable. But I do want to note that that is the minimum acceptable flow rate. To get the maximum flow rate, we take that same 55 gallons a minute, the daily average flow, we multiply it by the max detention time, which is 30 minutes, And we come up in this example with 1,666 gallons. We know that the minimum acceptable pump run time is 2 minutes. So we will divide the 1,666 gallons by the 2-minute pump run time, and we will get a maximum pumping capacity of 833 gallons per minute. So that tells me that is the wheelhouse, which lends itself to being an acceptable pump selection, somewhere between 222 gallons a minute and 833 gallons a minute will allow us to operate within the rules and regulations set by. What else do you need to add?
Please don't go at that maximum rate for your pumps, for your treatment plant. We don't want to shove that much through.
Yes, and look, I will say this. I very, very, very rarely do we see anyone lean towards the maximum rate. Typically, it's in or around daily average flow multiplied by your peak factor. So for this particular example, we have actually selected a pumping capacity of 300 gallons a minute. Now that's based on a couple of different factors. One is velocity, which we'll touch on in just a second. The other is the friction loss associated with moving a given amount of water through a certain pipe material of construction or diameter, which we will also get into detail on in the coming slides. So we have selected a detention time of 15 minutes, which is half of the 30-minute maximum. So we are going to take our originally established daily average flow rate, 55 gallons a minute. We are going to multiply it by the 15 minutes detention time. We get 833 gallons. Like I said, we've selected a pump capacity of 300 gallons per minute. So our pump cycle time will be the 833 gallons divided by our established flow rate, 300 gallons per minute, and we get 2.78 minutes, which exceeds the 2-minute minimum requirement. We've also apparently arbitrarily chosen a 6-foot diameter wet well, which we know, based on some engineering tables, has 212 gallons per foot of depth. So this is where we determine the storage capacity that we need within the wet well. And this will ultimately help us identify and pinpoint all of the elevations set within the wet well. So we will divide our 833 gallons by 212 gallons, which again is the per foot capacity within a 6-foot diameter wet well. And we get a requirement of 3.93 feet. So let me show you how this comes into play within the wet well and where we ultimately set our elevations for floats. So if you remember on the first slide, the natural grade at the station was 35 feet. The elevation of the lowest gravity invert is 25 feet. So we know that we need at least 10 foot of wet well before the fun begins. The general rule of thumb is to set the high water alarm, and again, this is a 4-float system, very standard. The general rule of thumb is to set the high water alarm half a foot below the lowest gravity invert to ensure that when and if you do get a high water alarm as an operator, you've got some time to tend to the system because we don't want to surcharge that line. From there, we will move another half a foot down to get our lag pump, an additional half a foot to get our lead pump. And then if you recall, we had 3.93 feet of depth required for capacity, storage capacity in the wet well. The jump from your lead pump on level, 23.5 feet, to your pump's off level at 9.57 or 19.57 feet is that 3.93 feet of storage. We've gone with an additional 2 feet to the wet well bottom. I assume this is for minimum submergence of these pumps. They're submersible. I can't imagine they're very tall if we only need 2 feet of submergence, but I'll take it. So the total depth of the wet well is going to be the top at 35.5 feet minus the bottom at 17.5 feet. We get 18 feet. So we're 2/3 of the way home. Okay, we've established a flow rate at 300 gallons a minute, and we've got our wet well depth and float elevations. Here comes the rub. The force main data. When you're looking at sewer effluent and any sort of force main or discharge line, you have to maintain a scouring velocity of 2 feet per second. This is enough velocity to ensure that the solids in the wastewater do not settle at any point in the line. So we've actually run, we're going to run a head calc, but I'm looking at velocity in both a 4-inch and a 6-inch force main. 300 gallons a minute moving in a 4-inch force main gives us a velocity of 7.66 feet per second. My personal preference tells me that this is a little high. Anytime I see 6, 7, 8 feet per second, I feel like it's not ideal. So what we'll do is actually look at the next largest size, which is a 6-inch force main. There's less friction in that line. So we come up with a velocity of 3.4 feet per second. We are going to go this route because it's less friction and we're still meeting the minimum scouring velocity of at least 2 feet per second. Okay, let's look at friction loss. Two geniuses way back in the day named Hazen and Williams came up with an equation which looks at the relationship of any given flow rate and the effect of friction within a line based on the size of that line or the material of construction. There's a nifty little table available to anyone who has access to the internet, which allows you to come and locate these figures. So we know that friction loss in a 6-inch line is 1.32 feet per 100 feet of line. We've got 3,000 feet, 3,000 linear feet of discharge line within this particular example. So we're going to take our 1.32 and multiply it by 30. We get 39.6 feet. And we're going to multiply that by 0.54, which is the K factor from the Hazen and Williams table. For a C of 140, that is the coefficient associated with the PVC discharge piping that we're laying. Now, that number would change if Mr. Engineer said, hey, look, I realize PVC is the latest and greatest, but I want to go back to the 1800s and let's lay some clay pipe. Maybe that has a C of 100 and obviously affords us a little more friction in the line. Regardless, at the end of the equation, you come up with roughly 22 feet of friction loss within a 3,000 foot run of 6-inch PVC force main. Now, your total dynamic head is really a factor of two things. One is going to be your friction loss in the line, which we just calculated. The other is going to be the static head, which is the difference between the off level within the wet well and the high point in the force main. In this particular example, the force main is exiting the station at 32 feet elevation. We are apparently not pumping uphill, so it's going to remain at that 32 feet. So again, we've got 300 gallons per minute as our pumping capacity. We ran the total dynamic head calcs to get a friction loss in the line of 22 feet. Again, our max static is the difference between the off level and the high point in the force main. We have 13 feet there, and we've accounted our losses through the station valves and fittings to be 150 feet equivalent length pipe, which is roughly 2 feet at the tail end of our head calc. So we've got our friction loss at 22 feet, our static head at 13 feet, and our station losses at 2 feet. That gives us a total dynamic head of 37 feet. Fire away.
Is using the 150 foot equivalent, is that pretty standard that you typically use that go in and out a station with alcohol?
We do it, and it really depends on the size, the configuration. We kind of use anywhere between 2, 3, or 5 feet almost, depending upon the setup of the station as an acceptable station loss addition.
Max is at 32 feet, right?
That's correct.
And your level switch is going to cut it off at 20 feet.
Make sure to repeat his question so that out loud.
Okay, his question was our max is at 32 feet. That's the height of the discharge line. Okay, that's the max elevation of the discharge line. And you're correct. Our bottom float switch within the station is going to cut both pumps off at 19.7 or 57 feet. Let's call it 20 feet. That's correct. So we've got 12 to 13 feet of static head. At the very bottom of the wet well, these are submersible pumps. That's correct. That's correct. Does that answer your question? I'm making sure. So here's a summary of what we just did. We have got a 6-foot diameter wet well, which was predetermined. We also calculated that we need 18 feet of depth to accommodate the lowest gravity invert, be able to comfortably set all of our float switches, have our storage capacity, and have minimum submergence for our submersible pumps. We have decided on a 6-inch force main based on velocity and friction. We have made a pump selection of 300 gallons a minute at 37 feet ahead. We also have 3-phase power. Does anyone know why it's preferable to have 3-phase power as preferred to single phase? It is. It's clean. It's clean. It's clean. It's reliable. You got 3 legs of power coming in 3-phase. They're all clean. They're all reliable. With the single phase, you essentially have a phantom third leg made up by capacitors, which is basically a glorified battery. As we know, batteries do not last forever. They will go out, and it will cause issues with the equipment. So anytime you can get 3-phase power to available at the sites, I would personally be very appreciative, but the equipment will also be more appreciative. So you've made it this far, okay? You've got your hydraulic duty point, 300 gallons a minute at 37 feet. What do you do at this point? That's correct. You choose pump. How do you do that? You call me. That's right. You can call me. I'll figure it out. No, look, I want to spend a second to just kind of touch briefly on some of the available pumps that you see frequently out on the market today. There are pros and cons to each. I will touch on that for everything that we discuss. Each pump, they've got different features, different hydraulic capabilities. And I wanted to kind of go through those so that you all were more well informed, because we truly do select pumps based on an application. Lisa, if you came to me and said, hey, guess what? Gainey's is going to put a lift station at Jefferson Parish Hospital, you would not ever catch me saying, okay, good, I'm going to put some 2-horsepower grinder pumps in there. Let's do that. So as I said, there are various selections and many different configurations, whether it be submersible, self-priming. You can even do vertical turbines. They can all do the job hydraulically. We typically will go with some grinders for low flow, high head situations. And that's purely based on the profile of those curves. They're very, very steep. Like I said, low flow, high head, or when the force main is very small. We can use submersibles anytime. The wet well doesn't have to be deeper than 23 feet. They are more appropriate for high flow stations as well. So anything over 5,000 gallons a minute, I'm actually absolutely putting a submersible in there. Both submersibles and self-primers can be used, and it's really dependent upon preference. Anywhere from flows range to 100 to 5,000 gallons a minute, and the wet wells are shallower than roughly 23 feet. And I'll get into that reason in just a second. Let's start with submersibles. This is a standard configuration of a submersible wastewater pump. You've got a suction side on the bottom, horizontally flanged discharge, and a 90-degree base elbow, which you mount in the bottom of the wet well. There is a guide shoe on the face of that discharge flange that rides the stainless steel rail system there so that you can pull it up and put it back down if and when you need to. These are some various types of submersible pumps. They're listed what I believe to be in order of solids handling capability. Like I said, grinders are small, 2, 3, 5 horsepower. I know they're made up to 15 horsepower, but they've got small discharge, 1.25 inch, 2 inch, and their hydraulic profile is unique in the sense that it's steep. Very high head capability, very low flows. You move into some shredder pumps, medium flows, typically between 2 and 4. I've seen a 6-inch shredder pump. And then you move into the various types of non-clogs or solids handling pumps. All are typically 3-inch discharge and up, and they come anywhere from 3 horsepower to 150 horsepower and beyond. Not only that, they are outfitted with a variety of impeller types, whether they be recessed, vortex, monodvane, dual vane, and each of those comes with a slightly different hydraulic profile. Just in case you were wondering, this is what a grinder pump looks like. It's a 2-stage pump, which means it's actually got 2 impellers. You hit both of them. You discharge from one end to the other, and that's what gives it the high head capability from a hydraulic standpoint. This is a submersible non-clog pump, very, very good for solids handling. On the right, this is actually a submersible chopper pump. So what you're looking at is the suction side, and what you have is a stationary and rotating face that operate in tandem to macerate solids as the pump processes. So this is something that I would select anytime I'm building a lift station at a hospital or maybe a nursing home or an elementary school, anywhere where the solids coming into the station can be unpredictable. A jail, absolutely. Look, I've got a picture on my phone, and I'll show it to you after this. We put a couple in at a prison in Harrison County, Mississippi, and I got a shot of the wet well a couple of days ago, and it's mind-blowing. It is absolutely mind-blowing, but they got to find a way to spend their time. So they flush stuff down the toilet.
Like a 2-year-old.
Exactly right. You're exactly right. Okay, like I said, there are pros and cons to submersible pumps. To me, it's really all about maintenance. I would say the submersible stations are quieter. They're more aesthetically pleasing. Everything is underground. You're not looking at any sort of pumps or valving, plumbing configurations. Wet well depth doesn't matter. Very wide range of flow and pressure capabilities. A lot of hydraulic coverage. And not only that, the majority of the motors are VFD ready. However, if and when you've got a clog within a submersible pump, what do you have to do? That's right, you got to pull it up. Look, I'm not the strongest guy in the world, but even pulling a 2 horsepower grinder pump that weighs 80 pounds is tough. So anything larger than that, you've got to be equipped to have a truck, pull it up out of the hole. If it's anything beyond a clog that the municipality cannot service in-house, you typically have to send it off to a third party to do some motor rewind and stuff like that. So the in-house maintenance can be a little beyond a small town's capabilities. Typical life expectancy, 7 to 10 years. I've seen them 15 years old. I've seen them last 3 or 4 years. It really just depends on the application and the runtime. Working on it. So now we get into above ground pumps. They've been around since the 30s. Gorman-Rupp came along in the 60s, made a lot of improvements to their design. The current gen Super T series in the 90s, they've come up with a few different iterations of that, the Ultra V series. They've got self-priming capabilities to approximately 23 feet. This is today's model, the Gorman-Rupp Super T series. You've got a suction side over here on the left, and you discharge through the top. This is the Ultra V series, high head capable. It's a different model, the Ultra V series, one pump stacked on top of the other, so you get twice the head capabilities at the same flow rate. Again, pros and cons to the self-priming pumps. For me, it's about maintenance here. If and when I've got a pump that clogs and I've got a system mounted at grade and I don't have to pull a pump up, I can pull out a clean out cover and unclog a pump, I will take that day in and day out over pulling a submersible pump. A lot of hydraulic coverage here as well. And because they're not exposed to the underbelly of a sewer lift station, typical life expectancy can be anywhere from 20 to 30 years. Some of the cons, wet well depth cannot exceed 23 feet. You have to deal with prime and reprime. That can be tricky in some applications. They can be noisier, and truth be told, they're not as aesthetically pleasing because you're looking at all the equipment. What's the best choice? Ultimately determined by the owner, the engineer. What you got? So the question that he asked is, what is the cost difference between a self-priming pump and a submersible pump? Truthfully, there's not a lot of cost difference. It all comes down to personal preference. And typically the operator, the one operating and maintaining the pumps, will make that determination. They want to be comfortable with what they're working on, and it will generally be their preference that comes to style selected. What's the best choice? Like I said, it's down to the operator, the municipality, the engineer. I think what's important to know, what we want to take away here, is that there are many different options out there. You don't need to paint yourself in a corner or be shoehorned into something that you don't want or not comfortable with. So if and when you ever have any questions, or we can help you with lift station design or ultimately equipment selection, please let me know. We would love to work with you. Questions?
I have a question on subdivision design. You have 200 lots, new development, but just say you may only get 20 lots per year,
right?
Maybe 10 years so you get to that capacity where you need the 300 gallons per minute. How you deal with the cycle time on the initial?
It's a good question. I'll repeat it. His question is, within the example, we had a 200 home subdivision. And his question asks, what happens if we phase the homes in? Let's say phase one only includes 50 homes, and then 3 years later, they're going to do another 100 homes, and the remaining 50, down the road. How do you deal with the pump selection? What we typically try to do is size the lift station for ultimate build out. Because if you do that, you won't have to rehab along the way. One thing that we've employed recently is the use of variable frequency drives, which we can speed up or slow down the pump based on demand. That gives you a little bit of flexibility hydraulically and in runtime, while all working within the stop-start recommendations for the motor. So it can be done. But if you were to tell me, hey, I've got a 200 home subdivision coming, I'm going to do 100 now, and maybe I'll do the next 100 10 years from now, I'll say, okay, let's outfit the station for 100 homes. Call me again in 10 years and we'll resize for maximum capacity. But I would build the wet well for the 200 homes regardless.
I've even seen where y'all just upsized impellers.
Yeah, we can do that too. You can trim impellers, you can oversize them. That does change the hydraulics. You're obviously still restricted by the horsepower selected, but we can tweak when and if needed.
Any other questions?
All right. Thank you so much for having me.
Great job.
Yeah, really, really good job. I sent a little text to Ben and Gary and told them, I already did. I told him that your star was born. You're fabulous. And Gary said he knew it. So I don't think Gary will ever speak again. I'm just saying. Thank you so very much. Okay, we're going to take roughly about a 15-minute break, and you can definitely see him to see about the gel. I like to see gross stuff. I mean, like during break, I might be watching Dr. Pimple Popper. But anyway, you can definitely take a look at this lift station and all the interesting stuff that those prisoners had time to flush down. There's a couple of people that need to sign in. Charles Blackstone, Cynthia Samuel, Todd Tarango, Okay, Tarango, Paul Williams. You should see how people pronounce my last name. They try to make me fancy and call me Roche. And so anyway, but so if you don't have a name tag, we don't know you're here, which means you won't get your CEUs or PDHs. And while I know you just love spending time with us, I'm sure you'd also like this. So please make sure you see Aurora, Princess Aurora from Sleeping Beauty at the front desk, and she will help you out. We're going to take roughly about a 15-minute break so you can get your box lunch out there. You're more than welcome to sit outside or come in here with the food. It's fine, okay? And in about 15 minutes, we're going to do our learning lunch in which Cindy, Michael, who's a girl, and Tim are going to be talking about heavy precast case studies and different things that we have done here at Gainey's. That way you can get 8 full PDHs. So that's our learning lunch. Thank you, guys. Lunch is ready outside.
Yes, yeah. It's only a few months away. It's jambalaya, pork and sausage, salad,
Yeah, we missed it. It takes me a second to figure it out. I got my 10 hours with ASCE. Okay. And included an ethics hour. And then this is the rest. Yeah, this will be the rest. I heard that's a good conference. Well, I heard that's a good conference. You know, they that's one thing it's amazing how much the code that changes over time. And now everybody, it's like the answer don't get much different. The way you do it, the way they do it, direct analysis.
that day, like, oh yeah, the forum's today. Oh yeah, we all forgot. Stuck up on it. I almost forgot about this one. Tulane usually has a. You don't have to fight traffic. Parking was easy. My car is right there, literally. I think I got the best spot. Right there. No, last year they had tents and stuff set up in the grass there.
Y'all got jambalaya, your utensils, everything you need in there, your butter, your
Last
salad,
year they had tents and stuff set up
Italian,
there in the grass. So it's like double the size. And they had a crawfish boil. That's not a bad idea. The oysters. I don't know what the price of oysters are. Usually you get them more in the winter. Sounds like they have charcoal.
That's one of the half stuff in that bag.
Yeah. I was about to say it is normally like December.
In November, we need December, oyster season, it's not exactly.
I've never been crawfish. I can say I've never done it.
Multiple ways to crawfish. Multiple ways to crawfish. So when you go to the store and buy Zach's crawfish, mostly pond raised.
Yeah, that's right.
They got little traps and put water in the pan.
I've seen those like driving to lap.
They go from P-Rug, they go from pull them, dump them off the shelf.
Well, I've heard of people like, between Slidell and Mississippi, people pull up on the side of the road there by the Pearl River and they go crawfishing.
Yeah, it's really hard to Highway 90. What they do is they get out and they put traps like 5 or 6 feet into.
I've just never done it, but I've seen people do
You
it.
have everything y'all need?
Very good.
Okay, good. I know, I've been smelling it. I'm about to grab a plate too.
I've done it with the walkthrough this.
Or they're from China.
Those are so like the crawfish that make the mountains in your yard. So they're different species.
They are. They're little brown ones.
They're dark black.
I have seen
They're about
them.
this big.
Every now and then you'll like I found them and they're little.
We used to see
Small.
them as kids.
They're not the same color. They're like more of a brownish color.
You look at their almost black.
Mm-hmm.
Crabs slow me down a little bit. Yeah, my wife. Crabs are good, but they go on YouTube. Look how they go through and they cut certain spots. Flips it open, you can like dump the meat out.
Yeah, I know. I guess the feeling of like everyone else is eating more than me. I know what you mean. But like the way we would kill crabs is typically get like a butter knife, pop the top shell off, and like grab it, split it in half, and I just start picking away the meat. There's a way to cut it just right. The meat just comes out. I gotta look that up.
So
I'm always picking at
so
it.
you pop the legs off, pop the top open,
Yeah.
and you take it and you split in half or leave it whole. There's a way to cut it so you get both the bottom and top meat, like it kind of opens up. You just kind of just 50-50. If you watch YouTube videos, you can do it in like 2 minutes. Like 2 minutes or less. Like an entire crab, like all the long meat
I'm
out.
like hooking my finger in one little slot to get this piece of meat.
That's gonna be turn off for you.
Yeah, you gotta work for it.
Like Maria, I just give it to me in a pasta or we work it like one and she'll sit there and I'm picking away at it and she's like, you feel your own. You just do it so much faster than I think. Let me give you a hint. The problem is not feeling. You pinch the back of the tail with your nails
so much easier.
and then pull it out. I had a lot of love. I'll tell you what I tell my kids. Things that take time to practice and learn are worth doing.
Because once you get it, you won't forget it. Yeah, if you never do it. Right. It's not something you do all the time. But it is kind of like riding a bike. Once you get it, you really don't forget. You have COVID this year?
We didn't go to any boil. We boiled, I think we bought, the guy bought 4 sacks this year and boiled them. It was just for my family.
Hello, hello. We're here for learning lunch. And so we're going to be talking about the heavy precast projects that we've done just in the last, we just went on Facebook and pulled some of the stuff that we put out there on social media and thought we'd talk to you about them. Now, I want to tell you a little bit about the team that we have up here. Everybody smile pretty at the camera. Okay, so we have Cindy, and I know a lot of you know Cindy. Cindy, could you look in the camera? I'm talking about you. Oh, okay. Oh, these are details. Okay. All right, Cindy's going to try to, our AV guy might want to come man his camera. If not, Cindy's going to start doing it for you. I think you might be inspired to come inside.
I touched your camera. All right, so we're all in the picture.
Can you hear me outside? Can you go look? But can you go check? God, it's so hard to get good help here these days. I know. Ooh. Okay, so back to a little bit more about Cindy. Cindy's been with us for 18 years. So she started right after graduating from Southeastern, and she's our design manager. She is a local and national speaker on the dangers of grease and the power of precast. Oh, that sounds so good. She wrote it herself. She's actually going to be doing a national webinar next year for specifiers for the National Precast Concrete Association on the amazing uses of precast. So be looking for that. I'm sure we're going to blast you to death on social media to let you know about it. Now, Cindy's anniversary t-shirt was wake up and make up because she is always put together. I actually have never seen Cindy without makeup. And so this is
Saturday.
okay. Once in 18 years, I saw her without makeup. Okay. She is always put together with like something like a cardigan. And so like the rest of us will be having a down day. Not Cindy. This is Cindy. Okay. Now, Michael, on the other hand, is 7 years with us, and she's always been in estimating. She's our estimating manager, and she's pretty phenomenal. Now, her anniversary shirt said, if my face doesn't say it, my voice will. And she's just that spunky. And that's the nice thing we say to her face about, yeah. And we already gave you Tim's, but so all three of them are really an important part of the Gainey's team and make things happen here on Heavy Precast. So take it away. Who's taking this? You, Cindy.
It'll be between Michael and myself. How about that, Michael?
I'm just for aesthetic purposes.
Okay, Michael's just here for pretty. Okay, so we're going to start with Rubicon, and if Elias is out there, he will recognize this project. So we did these octagonal foundations for Cajun. Actually, Tim and I went to Rubicon when they were just getting started, and we had to go out there and see where they were going to be going in place. We could easily see why they didn't need downtime, because it was very congested and they had a lot going on, and we could definitely see why they wouldn't want to take a lot of time to form and pour these in place. This is some of the pictures where they were forming it up. Tim, you want to talk about it?
Yeah. So from an operational standpoint, when we got this one, some of the challenges that we were faced with was the sloped floor. That was one of the big ones. So I believe it's a 4-inch slope on the bottom side of these structures that were needed. And I believe it was because the foundation that was already in place had an existing slope there. So we were trying to match that up. The struggle was for the floor joists there. Each one of them would be slightly smaller. So what I ended up, we tapered down. So what we ended up doing, I pulled it up in CAD and figured out how thick I needed each one of those floor joists to be. And to save a lot of wasted lumber and labor, we had a local sawmill rip them down. I gave him a list of linear feet that I needed of each thickness board. And he was able to turn that around for us pretty quickly. And then we just sheathed it with plywood, and it worked out really well. The angles on there, our panel forms are typically designed for 90-degree angles. We do have some hinge panels. We didn't have enough to do every one of those angles. So what we ended up doing was welding some angle iron together to make it fit in with our panel forms. And each one of those, we had the 135 degrees.
We're going to say that was Michael's idea.
Yep. Okay.
All right. And then you can see the finished product here. It turned out just beautifully and went out and shipped on the site, and they didn't have any trouble in the installation. All right. Moving on to our next. Oh, look. There's our little inspectors. So they're actually here today with us. They came in to Gainey's every time we were making a pour, got them some hot chocolate and coffee, and would come out and make sure everything was as they wanted it. And Elias has such a good eye for detail. It was really fun working with him. All right, just to mention, and we're gonna have a whole presentation about this later this afternoon. Our very own Greg Roach, who is our keynote speaker and dead last, is going to be talking about our above ground wastewater treatment plants. And so this is just a little preview of some of the above ground treatment plants. This is actually out at Athens. This is the treatment plant we did out there. So Michael's had to learn a whole new way of quoting treatment plants. Yes. And Tim has had to learn a whole new way of making watertight structures, but we've just about got it perfected, and you'll hear more about that. But this was this was a 50,000 gallon per day in Athens, Louisiana, and it was because they had a really high flooding issue through there, so they would get surges of water through this area. This is some ballers that we made for Fleming Construction.
Yeah, I mean, these, I think some of the bigger things for production was the timeline on these. I think we had to pop a lot of them out. They were all identical. Some of the details you can't see here, they had pipes protruding from the side. So one thing we didn't want to do was use our aluminum panel forms and put big holes in those because they're designed to be reusable. So what we did, we built 3 molds for this, I believe. We used mostly panel forms, and then the sections where the pipes would penetrate through, we built wooden form pieces that would tie into this, and it worked out really well.
I mean, they just look so lovely and cute all together like that. Okay, so
long does it take you to price out one of those jobs?
which one?
Any of them?
Any of them? Michael.
It could be 10 minutes. It could be 2 weeks.
And my point is, quick.
Quick.
So if you have something custom or funky, send us a set of plans and we can run through structural calculations and very quickly come out and give you an estimate, a budgetary number to see whether it goes over.
So for those of you at home who couldn't hear what Greg was just saying, he was making a really good point. So Michael said 10 minutes to 2 weeks, but really we can get a budget number out pretty quickly. So usually she and I can get together and look and see, you know, what's the complexity, what's the amount of reinforcement. And within 10 to 15 minutes, we're like, okay, well, this is going to run approximately this amount of money. But then when you get into all the embeds and the buy-in items and that type of thing, it could take up to 2 weeks waiting on quotes to come in. But the beauty of it for us is if you've got a really complex, or Greg said, funky project out there and you don't know if it can be precast because it doesn't look, you know, we've always done it cast in place, shoot it over to us, shoot it to Michael or shoot it to myself, because we can take a look at it and pretty quickly determine, oh, this is a great precast application, or no, we better just leave that cast in place. And we can also tell you, yeah, this is going to save you money to go this route because look how fast you're going to get in and out of the hole. And so we're able to help you with that. And we even have engineering software where we can, you know, plug in the information and get out some quick parameters.
Probably when Tim gets nervous when he sees us huddled up together.
That's
Yeah.
definitely when
But
Tim.
honestly, I was just telling them before this, these are the projects I really do enjoy. I love the challenge of them. So, I mean, it's fun. It is a challenge when you start looking at it. But at the end of the day,
Tim's
once the
eyes
project
get
is
this
finished
big.
and it's getting put on the truck, you know, there's a real sense of accomplishment and pride for the team out there and everyone in here as well.
Tim gets nervous when we say what we're going to make, and then we call him a weenie.
Greg says we call Tim a weenie when he gets nervous about what we're saying we're going to make. So this is a video of them turning an Alaska barrier, and this is brand new for us. And I'll start with Michael talking about it. No, I'm not going to start with Michael talking about it. You had to estimate these crazy little things.
I was winging it.
Yeah. Okay. So we've never made Alaska barriers before. If you've ever, and if you don't know what that is, it's just because a lot of the barriers we found out have different state names. So a lot of people have heard of Jersey barriers. Those are kind of the typical highway barriers you see, maybe going down the interstate or dividing up things. But we also, Texas barriers is one type. And then these are Alaska, and these are really tall. How tall are they, Tim?
I don't have that.
I think they're
about 12.
I think they're 12
Yeah,
feet.
yeah.
Yeah. So I was thinking somewhere between 12 and 14 foot. They're extremely tall. And so they're really neat to make, but they've got a keyway that allows them to fit together. And we're doing this for Fort Polk. So they sent us some drawings of some really interesting bunkers that they're building out there. And then they're using this out at the ballistic site too, right? I don't
They
know.
won't tell us.
It's hush hush. Shh, you didn't hear it from us.
I gotta drop it off at the door.
I found out just today, that's to constrain aliens in the alien isolation zone.
Greg just found out that this is to constrain the aliens in the alien isolation zone in Fort Polk.
I see
So that's
some black
pretty
SUVs
neat.
pulling in the drive. Right
Yeah,
now.
yeah. I think so. I'm gonna go back and let you watch that flip. So each piece we constructed on its side.
Yep.
And then they have to rotate it.
Yeah. So space was a big production obstacle on this one. If you went through the plant tour, you see how crowded the plant tour is, and then I also mentioned that timeline was really big with this one. So ideally, when you have a tight timeline, you want to produce something in the building where rain won't affect you. That wasn't an option on this one. We're casting these on the slab that will be our new crane building. And then the mold design, we were fortunate enough to have a little bit of input into that, because with the timeline situation, they were trying to build molds very quickly to get them into production. And we were allowed to have a little bit of feedback on that because they're not our molds. And
The first set of drawings we got on the molds, they sent them over to us, and I brought it to Tim. I said, "Hey, Tim, they just want you to see if you have any feedback." He goes, "Are those completely bolted together? How many bolts are those?" I mean, I literally thought his eyes were going to fall out. And so we got on the phone with the mold designer.
every piece of that mold was originally designed to come apart with a crane lift or forklift move. And, that's the part when I start seeing that, I start seeing the time that it takes to rig onto all that stuff, the safety issues that you're going to deal with. So we talked to them, and they were able to put hinge designs in, and couldn't really get away from the bolts, but it's not terrible. We were able to get some impact wrenches in there and speed that process up.
It's less than it was. All right. If you went out on our plant tour, for those who were here today, or if you were watching on Facebook Live, we looked at some of these new breasting dolphins. These are much more complex than our old breasting dolphins. You want to talk a little bit about when you were having a quote and everything?
No, not really.
Go get the camera thing for her.
So the first ones how long ago did we do the other ones? Like 5 years?
Yeah, 5 years ago.
And they were much smaller. These, not so much. I wasn't even sure if we could ship them. I mean, some of them are 21 feet wide, and but you can, in case you're wondering. But yeah, I watch them go out every so many days, and they look great. I mean, we were iffy at first, but we pulled through. We pulled through. There's a lot of most of the stuff they provided, correct? All the embeds. There's a little frame that goes around it. But yeah,
they provided the welded embeds and the weld ring, and then the form work there. I believe Blake did a lot of the design work on the form work. So yeah, it worked out really well.
A little tip: when they're 21 foot, they go out by police escort. If you think you're going to be ready to ship them by 8, tell the police escort 10. Because we got Bill.
Yeah. We Greg was just telling us about how to arrange your escorted loads when you have a police escort for these large pieces. So this is some of the pieces getting loaded and onto the trucks as we were talking about it. They really did come out beautifully. We had to do a slight slope, a little taper so that the water would roll off these as they were placed out there on the docks for the ships to moor up to.
You'll notice when they're loading the truck,
Let me
go back to that.
Yeah.
So these structures aren't symmetrical.
No.
And part of it has to overhang on the truck. So if you notice a little line right there, we mark the center of gravity on the structures, and then it makes it a lot easier when these guys are loading it, because you have to get pretty precisely have the center of gravity over that, the center of that truck. So then when they go to make a turn delivering this, they're not tilting or potentially flipping over.
Center.
Right.
Yeah. Can you imagine if the trucker would have centered it and then went to make a turn?
Yeah, that wouldn't be good.
Would not be good. No, absolutely not. This is just another picture. But in this picture, you can kind of see how they were not symmetrical. See how this one has got this jutted out piece from its edge. They were all just a little bit different. They had some that were somewhere together. Blake, you had a few that were twins or similar. Yeah. So we had about 6 pieces of custom form work, he said, that we had to do for these pieces. So they were very complex in nature. Blake has had to baby them all the way through the process, but he's done an excellent job.
So we tell them we come to love them, and then they ship out and we list them.
Greg says that we come to love all of these products, but then we miss them when we ship them. It's like sending kids to college.
We're excited to send them. We can't bill for them.
Yeah, Lisa says we're just excited that they get out the yard. Tim says so he can have more space.
Yeah.
Lisa sent us these pictures. These are actually not the ones we made, but she sent us this as proof of why do we have to be so careful with the surface? The birds poop all over it anyway. So the birds destroy it anyway, she said. But this is similar to what ours will kind of look like out there in the Gulf. Now we get to talk about bridges. Now Brittany's going to have a whole section on bridges during the last plant tours. If you want to sit in here and listen about how bridges get produced, but we wanted to feature Pine Hill Bridge. This is one that we've made this year, and that was very unique.
Yeah, definitely. Sometimes I forget about some of the challenges that we've gone through on some of these projects. So
Kind of like labor.
yeah.
Lisa
don't know
says
about
it's like
that.
labor because you get this dose of forgetfulness, and then you decide to have a second child. Well, then we decide to make another bridge.
Yep. So I pulled the folder to prep for this. I just pulled the folder just to see some of the obstacles, and then it hits you. You're like, oh yeah, I forgot about that. So when we first got plans for this job, sitting there digesting the plans, looking at them, and we realized to cast this this match cast head wall. This is 3-piece head wall that has to be cast up against the bridge. One, positioning those bridge arches together precisely was a challenge, but we realized that we were going to have to flip 2 of these arch sections to get it to match up to the other one, because they're all cast on their side just like this. And we started brainstorming that. How are we going to do that? We have to bring a rental crane in to get the hook height. And he said, just go flip it in sand. Yeah.
Talks big.
So we did a lot of.
You know how I figured out how to flip it? I said, Tim, go out there and flip it.
Yeah.
Greg says this is how he figures out to flip things. He says, Tim, go flip it.
And then he calls me a weenie for.
Yeah. Then he calls you a weenie.
No. So we called Contact, the company that we were producing these for. And there was a lot of feedback back and forth there, like asking how they have flipped them in the past. And the most common way was to get a big rental crane in and do the maneuver. But we didn't want to do that. So they said they would come down, and we did. We rolled it in a bed of sand, and it was very nerve-wracking. But we did it very precisely, and it just rolled right over.
Did great.
Yeah.
Didn't break. And this is how you can see it didn't break. These are the pieces being installed.
Explain the twin leaf.
Okay, so each one of those sections that you saw on the truck before is half of the arch for this particular style of bridge. I believe this is the first time Gainey's has made this style of bridge. I know it's the first one I've been involved
This is the
with.
very first one we did like
So on site, they're putting 2 of those arches together, or arch sections, and it ends up making the full arch there. And then they come back, tying some rebar into the top section there, and they do their closure pour.
So these photos are.
What your wife said about this.
Oh, that was so funny. That was so funny. Wait, first of all, these photos
If she's
are.
watching, you're going to get me in trouble. So I sent her pictures of it, because I love seeing these things installed. And she saw that. She doesn't understand backfilling or anything about construction. She's like, how is a car going to drive up that steep incline there? So I had to share that with everyone at work.
That was fun. I'm sure she appreciates you. These photos are courtesy of Merit Construction. It was really nice of them to send some of these photos to us and share their progress through the project. Here's some more. You can see here the wing walls as they came out. And these are the anchor forts in order to, as they backfilled, that's what would hold the wing down. That's all part of it. And then if you see all these little Gainey logos, that's courtesy of me and Jennifer. We had to put all those on one day when we were a little short-handed after COVID. We jumped out there and got a lot of that stenciling done. But the guys did just a phenomenal job producing this bridge. It came out beautifully, and you can see it stacking out right there. Windmill Farms. This was another Blake project that he had project managed. It was really neat. There's Andre right there out there helping them put it together. But this was the first time we've ever done a lid like this. And it might look, oh, what's the big deal? Well, the big deal is when it's in place, it looks like this. So it was really neat because it was like they took a lid and did it in sections. It was really interesting for Michael to quote. It was geometry. Yeah, so Michael had to figure out, what are they trying to do? Why am I cutting this lid in a million pieces?
Yeah, they just gave me the pieces.
Yeah.
Okay.
Okay, sure. And but it was because when you put it all together, wasn't it like 30 or 35 foot in diameter? It was really big. It was really big. So it's not like you could ship out something this large. So it was done in sections. And then you can see we left rebar sticking up all over it so they could come back and do their pour in the field. So it was really neat. We've done 2 of these, I think, so far. And they've turned out really cool. We've also been doing some custom head walls. That's always fun. We don't have head wall forms. So when someone calls us and says, hey, can you make me a head wall? Michael goes,
Sure.
Sure. And then she has to say, hey, Tim. Surprise. We got to make a new head wall. And so our guys, they really starting to get good at it, making these different custom head walls for us. This was a fun project. Believe it or not, this project started probably 4 years ago when you and I shared an office.
That's about 4 years ago.
Yeah. About 4 years ago, the engineer originally called me, and the whole thing was designed cast in place. And he was like, look, I really don't want to do this cast in place. Do you think we can precast this? We really need to be able to get in and out. We don't need to be holding holes open here. And so I was like, yeah, let me take a look at it. So then Michael and I took a look at it. I mean, we had to go back and forth because there was really unique structures. They have angled sides. This one in particular that you're looking at here tapers in. This is that UV structure that Tim kind of cringes about. But it was definitely a challenge, but like it's what gets you out of bed every day, huh?
No, these are the ones, like I said, I genuinely mean that. I enjoy the challenges with these and trying to figure out, the catch basins and things like that. You're opening a mold, you're pulling a piece out and you're kind of very redundant. But this is the stuff. But now I'm done.
During the quote process, it doesn't sound like this. Three pieces, yeah.
Had the flared section that changed the width of the channel.
Yeah. Yeah. So it's really interesting. It started out 1'11" on the narrow end and then went like 20 something feet and then had a flare out till like a 3 foot end. And so it was really, interesting.
We had to do more of those custom angle iron brackets on that. And anytime you have any kind of angles with these panel forms, you can't see any in this picture, but what holds the walls of those forms together are steel wall ties. And anytime you have, if they're not straight walls, you start running into issues with those wall ties having something to connect to on the other side. So every time we have those angles like that, we end up having to cut custom filler pieces just to get our wall ties to align again. But it was a fun one.
But fun, right? But fun. This is just another one of the pictures of a piece we made for North Thibodaux. There were quite a few structures in that whole bevy.
And we actually just stripped the last piece of it yesterday.
Wonderful. This is Johnny Bro. We made some pieces for Johnny Bro, some large pump stations, and all the pieces before they leave our yard, we dry fit them to make sure they're going to stack. And this is you videoing, Tim, because you hear your voice in a minute.
Beautiful fit.
So it was a beautiful fit. But before it leaves out of here, not only do we dry stack it, but we'll even mark it. So you can see this one has little 3 tick marks. It's because when you get it in the field, you don't want them to rotate it and set it the wrong way. You want to make sure they line up the 3 tick marks to the 3 tick marks and they don't have any issues. I think that's one of the smartest things that we do. So the Johnny Bro project, these are just some of the pictures of it. And our last picture is what you saw out there. We've got a new crane. I just thought these pictures were beautiful that Tim took of it. But we're really excited because we're doing so many different capital expansion projects. Greg loosened the purse strings and Lisa is blowing the money. No, I'm joking. But we're expanding and we can't do it fast enough because poor Michael can't quote fast enough these days, which is a fun problem to have. And as you can see, these are just pictures from this year of some of the crazy stuff we've done, and it's been fun. Greg, do you have any comments? If you do, please come to the mic, please, sir. You've got plenty of
I'm gonna
time.
make you guys cry. So it's nice that we have a plant, and it's nice that we have molds, and it's nice that we can do super duper concrete. But what I cannot believe I see here at Gainey's is everywhere I look. As you look around here today, we have our project managers and people in the office. These 3 are driving this business because you got 2 people who can imagine it and quote it, and a guy who just won't say no to go ahead and make it. And they love doing it. So, there's a need out there and there's a plant that's capable, but without these guys, and I can say that all around our company, from where we were 10, 15 years ago to where we are today, the real difference is we have so many young, bright, talented people who are passionate about doing what they're doing. None better than what you guys are doing to drive this business. So thank you guys.
Thank you.
And you're not really a weenie. I just call you that.
Oh, no. Thank you.
All right, so our next talk, I believe, starts at 12:45. Is that right, Lisa? So you've got about a 15-minute break for those who are here. You want to go potty and meet and mingle, grab another snack.
Sounds like we're five. We're five now.
And those of you who are watching virtually, we'll see you in 15.
Exciting what we've done the last few years. I know, right? If you give us a project, you too can be on camera like us.
A lot of those are going on at the exact same time.
I know.
I realized when I looked at some of my planning, drawing some of the folders,
It's like
and I had a sketch layout. We had Rubicon, and I'm like, okay, footprint. We've got the Rubicon slabs. We've got the Pine Hill arch. We've got. So yeah, it was like fitting it all in. Oh, I'm sorry.
Or you could do something with dolphins also, where they're setting well bars. You put it, come down, well, lead down on both sides, inside and outside, and come back and coat it. You could do it when you can come back and have a plate setting too. So you come back for your ladders. You know, just have plates in there as a precast and rubber ladders right too.
I did a lot of that stuff at tennis with embedded plates in concrete, and then they would just weld it after the tool.
So they do like most of your concrete buildings now are all precast, where they just do repetitive panels and do the same thing over and over. You know, and then like they come back and they'll dress the outside facade of the concrete, and do like stamped concrete with some side. But the parking garage in Covington, that one, it's all. They start rolling 18-wheelers from place down in Gulfport or Biloxi if it's precast. And, you know, it's 8-foot panel sections. They come, flip it up, pull it up, set it. You know, they tack weld it.
Field work.
Oh, I mean, it just goes up like that. It's amazing. You know, you not have to pour everything in place, set the tone, careful in the yard, wait your period of time.
The more they can do in the yard,
And then everything's in a controlled environment. So there's also like, so like you're backing out a plant right there on site. You do all your testing, and you got all your molds, you do it right there, you break it, smaller mold to pull apart, and it's the rinse, wash, repeat thing. You know, if something breaks, there's a new one right there, and you're good to go. They're all like post-tension slab, made post-tension slabs. Where, you know, it's really a cool way to do it stuff now. I mean, I don't think that would be too good for people off to do it. Yeah, I mean, that's all the concept. It's impossible to always do individual boxes, but maybe a lot cheaper than coming out and doing trying to pour a hole in here and then that's the biggest thing, trucking it out. Right now. When you look at build out price,
yeah. For tennis, when I a few years ago, it's like, yeah, wow, that's expensive. I was thinking it was more like 300.
I know. So you're talking about the structural concrete, like you guys, whatever the Class A concrete, their average bidding price right now is
It's going up, man.
so when I did Highway 21, I did the widening Highway 21, $100 cubic yard.
Yeah, and that's the thing. And at Stennis, we use 300 because they were like,
But let me rephrase that. It was like $110 a cubic yard from the concrete plant. That was without the labor. So with labor, you got to be. I can't be $700 a cubic yard.
we were around 300 with labor.
It's got to be like 170, $200.
But we were thinking that Stennis was overpriced.
It would be more structural because you got to have.
It's like a monopoly. Like there's competition.
Here's your price. Here's what it is. It's got to be $170, $200 a cubic yard. I can't
Overcharged. But if it's going up that much,
we're in the wrong business, man. Help design. Let's just sell that shit.
yeah, I know.
I'll look at the last thing you do.
That was kind of like our rule of thumb, 300 per cubic yard for concrete. And it was like $12 to $15 per linear foot of steel. That was the true. Or no, per pound. Per pound of steel.
Yeah, it's almost twice what I used to use. Like steel is usually like $16 a pound.
They were just
And then
price gouging assets.
it was like $120 a cubic yard.
So over there, that's what we had to use. Rule of thumb over there.
My wife would call me.
And even by using those numbers, we were low on our bids, or like our government prices, estimates, cost estimates.
Yeah.
We were low. They came out sometimes higher than that.
What do you drive? 2015 GMC. You like the GMC? I've driven them all, man. I've driven Dodge, Ford, and the GM. On the GM. I thought them to be like the most successful. Out of the Ford seems to be on that same playing field.
I like the Ford F-150s. I don't have one, but
My Tundra was really nice. My Tundra got turbo. I let it run red light and hit the back of the truck. She turned us on the side and everything. So I got pulled out. So now I'm looking at other vehicles. So I'd like to get a Suburban, but that's out of my price range. So you got like the Chevy Traverse, which is similar to like an Acadia, I guess. Yeah. And that's actually pretty nice. Like the whole 6 comfortable seats. It's not bare bones, but it's pretty well equipped, you know. Yeah. It's got a little more space than the Tahoe does in the way back. And then, but I don't really the expeditions too. So I was in my friend's wife has an Expedition. And I really like it. It's really nice. Like I said, Ford is really good company. Not such technology stuff. It seems right. Maybe I just haven't been like others said that. The Expedition is real nice. They got a 2000. It's a newer body style. I think it's either 2019. Probably 2020. That's what I'm looking at. 2020. That's keeping me into. I love the new Suburbans. Yeah, me too. I think they're sharp.
can't go wrong with Toyota Sienna minivan.
Yeah, I got one of those, man.
The Sienna with the automatic opening and closing sliding doors.
I don't even have that on mine, man.
That's convenient.
I went over to Bone, and Bone still owns the Slidell, or not Slidell. So Bone used to own Bone Brothers and
Bone Ford.
The one in Herring. Not Herring. Not West Bank. It's the one on West Bank, all the way off of Palco. Yeah, well, Palco. So I used to go over there and buy cars, but they make so like they would make their money by selling cars and hitting the quotas and stuff. Whereas like in the North Shore, like North Shore Toyota and some dealerships in the North Shore, they make their money by selling individual vehicles. They're not worried about turning over 100 vehicles in a month because they figure, well, we're not going to make that. We're going to do better making because of our affluent area. We'll do better just selling and holding our base around models and telling people not to drive 50 miles to buy a car. Shoot, I drive in Houston the same too.
Yeah.
So
We actually went to some Toyota with us in better than any of the front.
So I went over there. I had some paper where it was like brand new vans or whatever it was. And well, we can't do that, you know. That had expired. You would have had to do it, but you do it 2 days ago or whatever. So I was like, what can you have? What can we do? I think we paid $24,000, $25,000 for a van, like out the door. You know, but it was like they didn't have the CE number on the back of it, the CE letters on it. Like it was 4-cylinder. You know, everything was manual, like manual doors.
So you got the real basic.
And my
I didn't
kids,
even know they made those anymore.
my kids have torn the shit out of it.
What our standard apparently has all the bells and like standard Santas have like all the bells and whistles. You can't get them without the automatic.
Well, that's a safety feature. That's how they sold it. I think too, there was the thing where it cost them more money to do just the hand sliding doors on a separate model than to just have everything come out the same. Right. And so it looks like nowadays it seems like the exterior, the actual vehicles themselves, unless you jump to the V6 or V8 or whatever, but the vehicles themselves are pretty much identical, regardless of your trim line. And then it really gets you with entertainment, electronics, or like the stuff on the interior of the vehicle, or like the rims on the tire, or whatever. You know, the money wasn't enough to get the Z71 Suburban. So they just came out with. It's got an upgraded suspension system. It'll run you everything I want to do. But it's plus what?
Yeah, I priced that up. My wife's looking for a new vehicle. I was really leaning like in that Suburban Tahoe, and we priced out just a basic like an LC or an SLE Yukon. Yeah, and it's easily $60,000.
See, like I was looking at the LS and the LS and Suburban. I forget what it is. The Yukon, like the cloth seats, everything with the bench.
That's what we look at. That's LE.
And you know, I get a brand new Suburban like that for $55,000. You know, and look, I will haggle the shit and I will travel. Look, man, I'll go to deals and walk away. I don't care. And I'm still only.
Hi, Cindy.
Still get the 52. You know, like so I'm still getting $52,000 for a vehicle. And so that's one. So like right now, Matt Bowers has an Expedition for $40,000. So buy it online, you know. Yeah. They must have messed up.
What are we doing?
Yeah. We're looking for a new vehicle, man. I know the sales manager at Mossy really
How to select the right screening for your wastewater from
Another guy
screen.
You should know people that do it.
Could be more.
I used to
Just like the
managers.
filters.
They're all good.
So this could be
I grew up when I was growing up. His dad was
without screen.
manager there for a long time. He works for a FEMA now or something.
Hey, what's your mug look like?
You tell me if you can see my presentation. Are you talking to me? Oh, you're calling. I'm sorry. I was looking at my phone. I am here. I can, yes.
No, dude, I got a little shitty tumbler.
I got a tumbler without a top.
Somebody used it.
Okay. Do I need to keep this phone line on too or not? Sounds great. I can hear you guys too, so just so you know. I can hear everybody. Well, I thought maybe there was like a triple thing that we were doing here, so I wasn't sure. Okay. Well, sounds great. Thank you.
Okay, we're going to be starting in roughly about 1 minute. So if you want to get your seat, I'll make sure the coffee is flowing so nobody dozes off from that sugar crash. The new book I've been reading is called Body Love, because I do all diets at least once, because it's great cocktail party talk. And it's all about your blood sugar. So your blood sugar, you got to keep it in level. And that cake that we just ate, that didn't help our blood sugar. Okay, I just want to let you know. That did not. So we're going to be crashing pretty soon. So we'll have to do some coffee. So we're ready. It's 12:45. And what we're going to talk about now is how to select the right screen for your wastewater stormwater project. And we're very excited to have this Zoom presenter, Tim Miller with Vulcan Industries. It was brought to us by Gulf States Engineering. So the good thing about doing things virtually is that we're able to get some speakers that typically wouldn't have traveled in to speak to us today. So Tim has been involved in the wastewater industry since 1994. That's when I started too, Tim. After graduating from Iowa State University, he joined a family business that sold flight pumps for 20 years. Fun business, family business is fun business. Let's all smile when we say that. And definitely keeps you on your toes. Over the last 5 years, I've been involved more specifically in wastewater headworks equipment, both with JWC and now Vulcan Industries. So Tim is zooming in to us.
Perfect. How are we today? Thank you for the introduction. And I would mention that if travel would have been advisable, I would have definitely loved to have been in attendance today. These are the types of presentations that I actually like to give on a week-to-week basis. We learn a lot, and I think people in the audience tend to at least pause for the cause and think about things maybe in a different way after presentations like these. Brad was kind enough to invite me to get involved with Gainey's efforts here. And Gulf States is an organization that does resemble very similarly what I was involved with in the Upper Midwest as a let's call ourselves an old pump distributor, if you want to call us that. But truthfully, most of the guys that are in the industry and have been in the industry for quite a while, including myself, over time learn something. We try to keep our ears open and don't talk the entire time. And as you learn things and understand what works and what doesn't work in the industry, you try to commit to the wins and let's remind people about what it looks like if you're involved in the losses. So I think over the years, I would say that in the industry, not a ton's changed. We still have this one-to-one relationship. Guys like Brad involved with Gulf States sitting down and talking with clients in various forms, whether that be consultants or that being end users or whoever it might be, operators, mechanics, whatever it might be. That one-to-one relationship, I don't think will ever be replicated. So even though we have this COVID issue slowing us down for now, I think we'll be back where we were soon. So looking forward to those opportunities. So today we really want to talk about based on who the audience that I expect to be over there. Since I can't see you, I don't know if anybody's napping. I don't know who's got low blood sugar issues. I can tell you, I just went and had a nice 2-mile walk, so I'm in great shape and I'm ready to go for the 45 minutes of presentation time. If there is a question, feel free. If Brad's in the audience or somebody, have somebody wave on the receiving camera, and I'll stop when I'm talking. Okay, perfect. And holler at me, because presentations like these, if you have a question, sometimes what happens is you keep waiting to ask the question because I keep talking, and then ultimately you forget your question or it becomes less important. So I'd rather have you just ask it. So today's presentation specifically talks about all things screening. So when we talk about screening in the wastewater business, many years ago, I used to run into applications where an engineer would tell me, it's just the application. And I got to be honest with you, 25, 30 years ago, I got to say that I used to say, what the heck does that mean? I think I know what it means now, but it took a while. It takes a long time. And so if you're a younger person in the audience that is just developing what that means, this presentation may sway you. If you're somebody that's been in this business for quite a while, you may consider something different based on the conversation. So that's what the goal and my efforts are really today. It's not really necessarily talk about a specific product manufacturer. It's to talk about different styles of screens, the why and the wherefore. So if nobody else has any questions, I'm going to get started. And 45 minutes from now, we will be on the other side of this presentation, and we'll be closer to the end of the day on a Friday. So Vulcan Industries, just for a quick little plug, and what the heck are we? It's a family-owned business, been in the family for a long, long time, since '75. That picture is very representative of what it looks like today. The corn is out of the fields, and it's a typical fall day in the Omaha, Nebraska, Council Bluffs, Iowa area. I'm actually talking to you guys from Minneapolis, the power of Zoom and ability to talk from wherever we might be. And I've been a Minnesota guy for a long, long time. Originally from the state of Iowa, which is where Vulcan resides in. You'll notice in the bottom here, we talk about 216 machines in Iowa and counting. That was a little bit of a brag at a recent show I just did 2 weeks ago that was actually in person. And we talked about some of the installations in Iowa. There's well over 2,000 screen installations throughout the United States of our product, and a nice little percentage are in our home state. So a little unusual in our company. Our company is a manufacturer that actually manufactures the entire screen from top to bottom, including controls. That's unusual. There's a lot of buyout stuff going on in the marketplace, and typically what you have is an engineering organization that might draft plans and a fabricator that may build machines. This is actually a machine that comes in as raw goods on one end, or a soon-to-be machine on one end is raw goods, and comes out, and the other end is a certified style screen ready to go. So why remove rather than grind? Types of screens, screen design, screening quantity, screenings alternatives. We'll get through all those. As Cindy mentioned in my bio, I did talk a little bit about being part of the JDBC organization, which is a muffin monster. So I'm familiar with grinders. In fact, as a rep in the upper Midwest, I was involved in selling a lot of muffin monsters over the years as well. So this is not a conversation to say that grinding is the bad way to do things. This is just a conversation that says, why would we want to remove rather than grind? And I've done many, many presentations on the positives and negatives of grinding technology and where it fits. The truth of the matter is that if you're a consultant in the room, and or somebody that just uses probably practical knowledge, you may suggest that the better way to keep problems from happening downstream is to take stuff out. And I think we all agree with that in the room. So ultimately, this is not necessarily a situation where we're saying don't grind because it's bad. It's consider why you're grinding, and is that the only solution? So as we go through all these options, I don't have a bias one way or the other. I will say, now that I'm a screens guy only, we don't, Vulcan does not manufacture any grinding equipment. I would say that my area of expertise and focus would be involved in removing product as opposed to grinding it up, continuing in the stream. So the benefits of screening, just the same benefits as we might imagine. I'm trying to protect some downstream equipment. It's important. Some equipment downstream is more important than others, meaning that it's a little more sensitive than others. I want to maintain a process efficiency. So for process engineers that are in the room, I've got all this biological knowledge that I have, and I know that my equipment that I'm putting in and designing works really, really well until this dreaded debris gets into a plant and changes the outcome. And that's what we're trying to minimize when we start talking about screening and its ability to screen at certain levels of removal. So ultimately, as we all are in this industry, we're after something that's an effluent that we're proud of. It's an ability to take wastewater, turn it into something that's usable downstream that doesn't impact our environment negatively. But good, bad, or indifferent, we're all in this business as environmentalists to some degree, and we all are after that same effort. So screening is part of that, and benefits of screening, good screening, is important. This isn't a trash can, and I can tell you that, like I said, I've done a lot of presentations, and a lot of them talk about all this wipes issue, and that's pretty current technology or current issues in the marketplace. But the fact of the matter is that just like we got through this political cycle here and we're in the middle of it, it is a local level issue. It's you talking to your neighbors about what the heck are you throwing in the toilet. That's the only way to really ultimately minimize some of the downstream effects. So equipment failures. Gulf States guys know about these. They get these calls in the middle of the night. What do? There's a problem. Well, guys like Gulf States, they know what they're supposed to do, but operations and maintenance, it depends on the style, the time of the night, and who's on call as to how well I can resolve that and how safely can I. So really what we start talking about is risk management. We start talking about the benefits of screening, and we're trying to minimize this amount of equipment failure downstream. Sure, pumps are one of those means and methods. So being a pump guy, I can tell you that is one line of defense that we're definitely targeting, is the quality and the efficiency of pumps and their ability to handle debris downstream. Correspondingly, there's going to be more equipment downstream that continues to see some buildup of screenings, whether those screenings have been ground up or if they've been removed. Anything that gets through a screen or anything that gets ground up and it gets reweaved shows up in places like these diffusers. And obviously your efficiency goes to heck in a handbasket in this world. So this would be an example of loss of volume and ineffectiveness of equipment. So these are all negatives of poor screening. Effluent quality, as we talked about, effluent is the issue. How do I meet my permits? Depending where you are, what those regulations are. Some are different, and some states are different. I come from a state of Minnesota that has very, very tight limits. So sometimes it is based on what those limits look like. So I'm going to get a bit into screening types. We have different types of screens in the marketplace, and sometimes we use terminology that's fairly universal. A lot of us like to use the term fine screen. Now, fine screen usually is not, it's almost like my 20-year-old, if he gives me an answer and it's fairly generic, I have to ask him the second or the third question to really drill down what it is that we're talking about. So as we're dealing with this right now, we're talking about mechanical bar screens first here. So there's different styles of mechanical bar screens. There's positive engagement and non-positive engagement. And I'm going to talk to you a little bit about what those are soon. And we'll drill into those details. We use the term also filter type screens, stair screens, continuous belt style screens, and perforated plates, meaning there's perforated plates. They're literally perforations and holes that are in these screens. Differently, positive engagements, mechanical screens, and non-positive engagements. So I'm really re-talking about that same particular design because there is a unique difference in the marketplace. So now in the world of mechanical bar screens, meaning that I have bars that are providing the screening mechanism, there's two different styles of screens in the marketplace now that exist. There is a positive engagement, meaning that somewhere along the way, the bar rack is being cleaned by a trash rack or a trash rake that is either positively engaging in the bar rack spacing or it's non-positively, meaning that the weight of the actual screen and the links lays on into the bar screen openings and pulls that product out. There's a distinction here, and we'll get into that soon. But I just want to make sure you kind of keep that in the back of your mind. It does affect results. So let's talk about positive engagement style screens. I'm going to use two different terms. They're both the same style. This is a screen that in the marketplace originally was referred to as a climber screen. And if you can imagine what really happens is this screen goes down. It has one single rake arm. It goes down to the bottom, wherever that bottom is, and it pulls that debris up through the bar rack and cleans that bar rack and dumps it out into a device downstream, typically a dumpster. So these are typically involved in, if you go to large wastewater plants, you tend to see these. They tend to be a bit wider, meaning, you know, maybe a 6 foot wide, a 10 foot wide channel. So large volume type flows. Typically also might be referred to more as coarse screens in the marketplace. You tend to see more of these that are 1 inch and higher spacing size, just because they tend to be something that says, I want to get the big stuff out and I'm protecting something specifically downstream that may be right downstream, aka a pump. So no moving parts down below. That rake arm, it actually does extend down into the wastewater. If we are going to be down below the water line, we're going to use a submersible style pump, just like we would, or submersible style motor, just like we would a submersible pump. These, like I said, tend to be considered to be in the marketplace heavy duty. It is a screen that over the years has kind of been used less and less. And when I say that, it's been used less and less because of other styles of screens that have become the preferred type of screen in the marketplace in certain geographies. Where you guys are in Louisiana and the southern parts along the Gulf, it tends to be that this screen still is a predominant use style screen. Partly because, if you can do the math, this single rake articulating arm doesn't have to go very far. My sewer is not so terribly deep that my screen doesn't have to travel too far to get to the bottom to come back up. And so I don't need the necessary multiple rakes to clean that bar rack on those first flushes when debris is heavy. So think about it that way. If you really think about the depth, the overall length of the screen, that may be something where you can look at this application and say, this is more of what I'm looking for. This is a little bit of the operation. Just think of this as a screen that's literally walking down into the wastewater flow. It's cleaning off that bar rack and it's dropping it down into a discharge chute and then further into either a washing device or some type of a dumpster for transport somewhere else. This looks a little bit at the articulating rake head. These things can get about 8 foot long, so imagine this is fairly substantial. These screens tend to be the largest and the heaviest in the marketplace in terms of the side frame thickness, the thickest, in terms of just how heavy that rake arm is and how long these screens will last. I haven't been walking a ton of years or anything, but I can tell you this, I know what the installation base looks like. And it's not unusual in the projects that I'm working on that we're not evaluating both either refurbishing the existing 30-year-old screen that has had minimal parts done to it, or potentially replacing it in kind of the same technology that we expect to last just as long. Same design from 30 years ago, a few enhancements that we've made that we think last a little bit longer for the operations staff. These teeth fully penetrate the bar rack. That's really by definition where we get into this positive engagement type issue. Looks a little bit about what we're trying to do here. So some of these screens, actually this picture is in the front of my presentation. It's also here. I believe these are in slide L if you guys want to know where these screens physically are. This would be a canal application. So now I'm dealing a little bit more with debris and grasses, and this time of the year is pretty applicable. So we start talking about a lot of material in terms of pounds, weight. This would be a screen that would be, to me, the only screen that you should be evaluating. If you know you've got a lot of heavy material, screens that we manufacture, different designs, would not last as long in the marketplace installed as this style of screen. A second style of positive engagement rake, second option for a screen is a multi-rake screen. So what's a multi-rake? Remember here, I talked about a single rake screen. There's one rake. Here, I got multiple rakes. In fact, I have multiple rakes in most screens. Every seven feet, I've got a rake. So if you can imagine a 21-foot distance, I might have upwards of 3 or 4 rakes that actually clean out that bar rack. This industry-wise has been around and really been marketed pretty heavily for the last 15 to 20 years. And the advantage of this is with those multiple rakes, I can clean a screen much quicker. And so if I have a heavy first flush, meaning that leaves and debris and stuff comes in on a first rain event, it tends to be kind of the perception that, hey, I better get this stuff cleaned out really fast. Now, it usually only it matters on a rain event, but when it's coming in hot, you got to get it clean. So that's really what the process of this positive engagement style screen is. Why is this a positive engagement? Like the other screen where I'm actually pushing my rake into the bar rack, here I've actually got a sprocket at the lower level of this screen that keeps that chain and keeps that actual trash rack moving into the bar racks. That gives me that positive engagement that we were discussing, and it does allow me to have a high screening capacity. So also what we got is we've got this positive rake engagement, we've got an ability to really get after whatever screenings are sitting into that bar rack. Meaning that if it's in there, I'm going to use horsepower and I'm going to use this positive engagement to go get it and pull it up and get it the heck out of the channel. I don't want it to go on the other side of the screen and drop into the channel downstream. That's obviously not what we want to do. And I surely don't want this to sit down there in the bar rack forever and just beat the heck out of the screen day to day to make the screen last less longevity. So ultimately what we're trying to do is we're trying to design this thing in a way that allows us to do that. We talked a little bit about how we design these screens and the why. So when you're starting to design screens like this, you might look at screens and say, how the heck do I discern between one screen manufacturer or another? Which one's better? Which one's worse? How do I really decide that? I think ultimately what we start looking at as a company I represent, is what kind of size of screen are we dealing with? So if I've got a 4-foot wide screen in a 4-foot channel, obviously, what screen manufacturer would I be looking at, and what are the different criteria within the screen manufacturer that are important to evaluate, whether I like that screen manufacturer or not? We, as a company, would suggest there's 2 things that you want to look at. One being, how thick is the side frame? And the side frames are the frames that are on the side of the actual screen themselves, and they're designed in quarter-inch thicknesses typically. Some manufacturers have gone to 3/16, and some may have gone even a little bit smaller than that. That's where you start minimizing competition right there if you really want to look at it. The thinner a screen is, the more likely the screen will not last as long. And I'll give you some justification for that here in a second. But keep in mind the side thickness being one of those measures, and really the length of the actual frame itself. And we call it wider, but if you think about wastewater going down a stream, the width is the length or the depth of the screen itself. So in the case of the screen I'm showing here, we're 28 inches. The industry is more like 20. Why is that important? There's forces that are being applied on these screens that are important to deal with, and they come at the screen unequally. So when I'm showing you this actual diagram, imagine wastewater coming at this screen, and a large volume of debris today might be over here on this left-hand side of the screen. Unfortunately, what might happen because you're there, I'm going to be loading up the one side of the screen versus the other side, which is unequal. I'm putting equal force to the screen by the sprocket that I've got in the wastewater, but I'm unequally loaded with the screenings that I'm trying to take out. That creates some torsion within the screen itself, and it creates some unbalance within the screen. The thicker the screen, side frames, and the longer or wider the screen is, side frames, the less likely that torsion affects that screen in a long-term way. So that's where we start talking about screen differentiation. Is let's talk about how thick it is, let's talk about how wide it is, and just generally you can look at the weight and kind of figure that out. Teeth penetration is important. I want to be able to get that bucket shape in there as well. So that bottom picture to the right is a picture of what the actual rake is that it's coming up. Some screen manufacturers decide not to even put a bucket there. Why is that important? Well, if I don't want a bunch of stuff just falling back into the front of the screen again because it falls off the front, then ultimately I want to have a bucket there. Now, what we're finding in the business is that we tend to see a lot more grit because of that. I'm not losing the grit down back off and sloughing back into the screen. The good news is I'm getting the grit the heck out of there. Now, if you got a grit system downstream, then preferably you could get rid of the grit there, but ultimately it's really hard to distinguish between them. This would be the reason why a bucket might look better. So this is a bucket on the bottom right. This is no bucket on that same style of screen. So that's a multi-rake screen without a bucket. You can see where everything's just falling off, and it finds its least path of resistance, and it usually looks sloppy and messy just like this. Work a little less difficult, meaning that curve as opposed to stopping right at the bottom and saying, okay, let me go jump into this thing at a very flat bottom and start right there. That's always the highest. And with curb bars, we just make it an easy. That's the whole purpose of a slope on that bar rack. A couple different ways you can use for mechanisms that positively engage. You've got two different designs. The sprocket design is the on number 1 or the left, and item number 2 is a static guide. That's just the manufacturer and the product that we call it with our design. And honestly, we have well over 500 of these things installed, and we have half of each of them. So we don't, and they both last about the same amount of time. We've been building these screens for about 10 years. The industry leader, I guess, let's call them, or the first to the market was probably 15 years. And with these style of designs, and ultimately we have not changed out a sprocket or a static guide yet. So we don't know which one's better in terms of how long it lasts. We know that at about the 10-year mark, most of those bottom ends will have to get rehabbed. And that is a consideration that you should be looking at. So a non-positive engagements type. So now we've talked about two different styles of screens, a multi-rake and a climber screen that were positive engagement. This screen is using a non-positive engagement type. In the industry, it's referred to in a couple different ways. Some people refer to it as a link style screen, some as a catenary. The unique difference is I have nothing in the bottom in the wastewater. There's nothing down there that's connecting that. There's no chain that's driving this. There are actually links that are replicating a chain, and they're actually in the wastewater all the time. So when I talk about this being non-positive engagement, the weight of those links are what's driving those teeth into the bar rack. Only the weight of the links. There is no other mechanism to create that. So good news, bad news. The good news is that if a large amount of debris gets into that screen, as opposed to in a positive engagement, it's going to just jump ahead and jump around or move away and out and away from that debris and say, I just don't need to get it this time. Good news, it doesn't jam the screen. The screen does not stop running. I don't start getting a blinding condition and I got to deal with it in a very, very emergency way. The bad news is that I never get that material quite out of there. And so aesthetically, that product just stays there for a long period of time because I have no positive engagement trying to push those teeth into that rake, into that bar rack. This is what one looks like operating. So we call these, we call ours a knuckle rake, link style, flex rake. Those are going to be the definitions you're going to hear, the terminologies you're going to hear. This is a popular screen in the marketplace you guys are in as well. No submerged sprockets. So that'd be usually the talking points. There's nothing down there to wear and or need to be maintained. I typically have some operational flexibility. So if I'm in high speed or low speed mode based on the amount of flow coming in, it really just talks about what kind of hydraulics are in that station. For the engineers in the room, this is the discussion about free body diagrams. Uniqueness being that when Vulcan designs this thing, we came in the marketplace behind DePerrin being the market leader, original designer of the flex rake screen. We wanted to obviously enhance some of the operational efficiencies. And one of the areas that we did improve on, we think, is putting some extra weight into the links. We just had a conversation about how the links are actually impacting the penetration into the bar rack. And by heavier, meaning that I've got more penetration with our screen than based on weight, based on a free body diagram, and based on the fact that we only like to have our screens designed into a 70-degree and less design. Unfortunately, some of the marketplaces suggested that going to 90 degrees is somewhat acceptable on these flex rake style screens. We just don't believe that. And we don't believe that because there's really no means or method for that positive rake engagement in any way to be effective long term. It'll do a job, it just won't do a great job. Advantages of the disengagement, I think we talked about it a little bit. You know, sometimes I can pin stuff. I don't have any, my operators are going to love it because they don't ever have to go down there and deal with anything in the wastewater. So perception wise and reality wise, this screen becomes maintenance friendly. Not as efficient in terms of its removal of debris, but maintenance friendly. Some of the disadvantages are, as we discussed, I'm not cleaning that bar rack out as effectively as I might with a positive engagement style screen, whether it be a multi-rake or whether there be a the climber style screen. So those two different styles of screens would be much more penetrating. They would be more fully penetrating into the bar rack, and you wouldn't see that downstream effect of debris building up downstream. So we call that housekeeping in the industry. That's really not, it's a nice term, but truthfully, that's a guy with a rake on the backside of the screen, getting down there some way, somehow, and cleaning it off. And it's usually the guy that's down the food chain a bit, which that never makes him happy either. All right, so let's go on. If anybody has any questions on bar screens, let's stay in the bar screen world just for this second here, just so I can make sure that if there's any questions, we keep it tied to the bar screen side.
No, we no questions right now.
Sounds great, thank you. I'm going to move on to a second style of screen. This is what we would call our filter style of the screen. There's a variety of different products that are out there, but ultimately they're not a bar screen and they're not a perforated plate screen, meaning the perforated being holes. So this is kind of a combination. Parks and Mix and AquaGuard, for example, we see some stair screens here. They're just kind of a hydrodynamic screen. So there's a variety of different manufacturers that make this screen. It's a bit of a hybrid between a bar screen and a perforated plate screen. And typically, as we're talking about these products, what we're talking about is some take out more material than others in terms of the ability for screenings to pass through the screen and get into the downstream side. Bar screens being the least amount of efficiency when it comes to how much do I take out. The good news is if I take out as much as I need to, that's all I need to take out. Next level up is going to be this style of screen in terms of how we operate it. A stair screen has a pretty simple principle. There are quite a few stair screens in Louisiana, and there's a reason for that. It's typically pump flow, typically low profile. These work well outside. And truthfully, they do a nice job of removal. Especially if you think about the concept of what a stair screen does, the upstream level is sufficiently high enough based on the screen getting blinded that it says to turn on. And when it turns on, it moves up a stair and it brings that material with it up one stair. Might be two stairs, sufficient enough to get the upstream and downstream water level to seek their balance, and the screen turns off. What am I really doing in a stair screen? I'm building a mat continuously, over and over and over again. That is the idea of a stair screen and its ability to work well. The more the mat you can build and the more you can tolerate the upstream level, obviously the more likely you are going to remove more material. This would be a picture, since we're post-lunch, this would be a picture of what it really looks like in the real world. The picture on the left and the picture on the right, those indicate a screen that are highly blinded. Good news is they're taking out a lot of material. 100% blinded screen always takes out all of it, right? The reality is that we probably designed somewhere around 20 to 30% is what we're looking at. And then obviously when I move that stair up, I'm getting to a screen that might have quite a bit more opening to it. It acts more like a bar screen for the period of time that it's not blinded. This is what it looks like inside. There's actually lamellas that are involved in this, and those lamellas create the bar spacing. Typically, we see 3 or 6 millimeter. In the real world sense, we're definitely dealing with stair screens that would be defined as fine screens. Fine screens in our industry, 6 millimeter or less. So almost all, in fact, all stair screens I get involved with are 6 millimeter and less. Typically, their installation angles are 57 degree, and they are preset in terms of their operating heights and where our discharge points are. Unique thing that we'll talk about another style screen that's going to require brushes and water. These style screens do not require brushes or water on site. That sometimes is a big deal to people. The continuous belt or band screen, you're going to get a bit more capture. It tends to either be perforated plates. You might have lattice. You might have cross members. Different things that are created to create a head loss and or removal of material. These screens tend to have brush requirements and they tend to have water requirements. Removal is a bit higher. Is it important for removal? That's a question that really starts at the beginning of time when you're dealing with a project. And it's a question that we get often since we manufacture different varieties of products that we're discussing today. We are talking about head loss capabilities. What can the system hydraulically handle? What do you want it to remove? What am I protecting downstream? Those are questions that should be happening and need to happen at the front end of a facility management program. And I think it needs to be discussed also at the operations level as well. What do they expect and what do they have for manpower? So that bleeds into talking a bit about hydraulics and channel design. As I mentioned, hydraulically, can I pass the peak flow? When we're designing these things, and when engineers are sitting down with a pad of paper and really just going from start to finish, the first thing we're always concerned about is, can I remove the material that I intend to remove and not overtop the channel that I designed? Because if I overtop the channel that I designed, that's always the worst case scenario, right? We would never do that. So we're conservative in our designs. We make sure that we don't ever do that. But we have to give something away sometimes. Sometimes we have to give away, if it's an existing channel, we might have to give up spacing. We might have to go from 1/2 inch to 3/4 inch and not be able to live with a 1/4 inch. So ultimately, those are the types of things we're working on. So we want to remove as much material as possible, and hydraulically, we want to make sure we work. There's our stair screens. That's what they look like involved. Cindy, do I have till 1:15 or 1:30?
You have till 1:30?
Okay, thank you. I just want to make sure. Brad just sent me a note. He was kind enough to remind me, so thank you. If it was 1:15, I'm already behind.
No,
all right,
so I kicked you off.
So for the engineers that are in the room here, when we start talking about designing, we as a company, and I think all the manufacturers that are out there really want to talk about, how do we design our system? What's the maximum velocity based on what's out there in the world of WEF? Using MOP 8, we use all those principles. We want to maintain no more than 4 feet per second at peak volume, and we want to try to keep a minimum velocity going through that channel that doesn't get a lot of settling out. You got to decide which one's sometimes the one that you're going to live with the most, but ultimately, I want to make sure we have that conversation in the front end of these designs. It helps. There are ways to minimize, especially our downstream level, that also impacts velocity. How do I keep that downstream level high enough at low flows that I create, or high flows, I'm sorry, that I create an ability to keep that 4 feet per second maximum. So we're reviewing all those things. We're using that information. We're putting it into our, every manufacturer has his own spreadsheet, but ultimately they're all based off of these types of principles, Bernoulli's or the Kirshner's method. We're using both, and we'll show you both in our designs because one is a little more conservative than the other, and we'll tell you the reasons why. But this gets into the math side of things, but ultimately we've got like I said, we've got a formula and a data sheet that shows you where the heck that's coming from. So consider both. Make sure you're okay with freeboard. So the screenings, capture and quantity screenings, that really gets into a math equation as well. Ultimately, I want to do something with these screenings, and I want to do something smart with them. I want to take that product and either minimize the amount of water left in the screenings, which also corresponds to the organics left in the screenings. And I also want to dry that product down. Most of these places are going to some type of a landfill and or a trash facility. And ultimately, to be a good steward of the environment, we really don't want a bunch of sloppy screenings going out into a dumpster somewhere. It just doesn't make a ton of sense. So when we do that, we're actually looking at the volume of screens based on the size of opening of the bar screen, of the per plate screen, of the band screen stuff. So wise operator once said, I'm not sure the guy's name, the more you take out, the more you got to deal with it, right? There's more operations and maintenance requirements, the more material you take out. And based on what we're talking about today, a bar screen is going to take out the least amount. Hopefully that's enough. If not, stair screen style, per plate style being the next screening style that's going to take out the most. So when we start talking about conveyance systems, now we're starting to talk about what goes on the back side of the screen. Doesn't matter whose screen manufacturer we utilize, I got to deal with those screenings in some way. The simplest and easiest is to have it just dump into a dumpster and let the trash man take care of it. The truth of the matter is all these systems are becoming much more elaborate, and a lot of considerations need to be made based on what's going on. We manufacture all the different styles of equipment ourselves, belt conveyors, screw conveyors, sluice troughs, and we also build obviously our washing press and screw press. Vulcan's a unique organization in that years ago, since '75, we've always built a wash press, and actually our wash press is behind a lot of people's screens over the years. So here's just an example of what it might look like. Here's a screen, obviously, dumping into a wash press, and then I've got hard piping that actually takes that product straight to a down sloping device. They're a closed vessel, and typically what's down there 5 feet below, 10 feet below is a dumpster. And it's, by the time he gets there, it's pretty darn clean and dry. Why is it important to keep it clean? What, you know, if you're out in the middle of nowhere and I don't care about odor, the reality is I want the organics to stay in my wastewater plant as well. It helps everything work much more effectively, organically. And truthfully, I really don't want the smell in the dumpster or anywhere else. Screenings treatment. I'm trying to take that volume of screenings, whatever that volume we've calculated, I'm trying to reduce it significantly. In most cases, we're dealing with 75% reduction of screening volumes, and I got a 90%, up to a 90% organic removal. I never know exactly what the number is going to be, and you never know, and it changes day to day, hour by hour. But the truth of the matter is that's what we're always targeting towards. This is what the difference of screenings types look like. On the left-hand side, you can tell that the left-hand picture is much more organically unfriendly, much more organics available, and it's quite a bit wetter. On the right-hand side, we're talking about the drier product, less organics, much more sheer volume and weight is reduced significantly as well. So really, what's that mean? Some guys can go a couple weeks with a dumpster being picked up versus somebody might have to do it 2 or 3 times a week, depending on the volume of solids. Different design thoughts when you're dealing with wash presses. You want to try to get away from wear items like wear bars. You want to start looking at design and mechanical design. The picture on the left shows our thrust bearing. We do not need wear bars. Those are actually rifling bars. If you looked at the previous picture, you can see the rifling bars here. That just keeps that log from spinning inside that tube. This is what happens on the bottom. The screenings are dropped into this screw. Actually, that wedge wire is doing a large amount of the dewatering. And as that material is being moved towards the discharge end of the discharge plug, it's actually squeezing out or pushing that water through those wedge wires down to back into the plant. Typically, all of ours are 2 or 3 millimeter wedge wires, just so you get a little idea as to what we're removing. Some form or fashion of washing that screening is important. Vulcan uses a 4-zone washing. I'm actually washing by putting water through the shaft, which means I'm washing the screenings from the inside out. Nobody else in the marketplace does that. It is pretty typical where you'd see a washing zone here depicted in zones 2 and 3. That's typical of most screen washing manufacturers. And then I've got a filter plate that's down below that's in a drain pan where I'm actually washing those out as well. That's what one looks like running. It's amazing what can get inside. You know, it's funny we show this picture because we're showing you what it really can take and its ability to probably, it's designed in a way that I can take out a lot of nasty stuff. But this is product that is not very compressible. You can see that this actually in the picture on the bottom left is showing the material that came out of the screw. You can see it's not very compressed in this design. I need things like, I need wastewater. I need junk. I need things that are compressible to be able to form that plug and make it nice and tight, like this. So there we go. It's 1:26. Imagine we got all the way to the end. Questions?
Great job. Do we have any questions from the audience? Questions from the audience? Outside, if you're going to go up to the mic and ask any questions, please feel free to do so. We can hear you in here.
What did he say was in Slidell?
I'm sorry.
He said, do you know where in Slidell that was?
Where in Slidell was that project that you were talking about earlier?
It's one of the canals in Slidell. I can't tell you the exact location, but those screens are in Slidell. In fact, they've been in for about 4 or 5 years. I'll let Brad know what I think. Brad might be able. I'll send him over the install information so he can get it over to you.
Great, thank you. We got one more question.
In the same picture, what do they do with the debris?
In that same picture that we're looking at, what do they do with that debris?
In this case, you can see a dumpster on the very right. You can see a dumpster over here, and there's actually a conveyance trough or a, let's call it a screw that's moving that product. It's probably a serpentine belt. I'm not sure exactly what's there. That's something we didn't supply in the project, but there's a back belt here that dumps it to a dumpster to the right.
That's a lot of debris. Yeah, I really enjoyed when the screw auger was crunching up the baseball bat and everything. That was my favorite part. Yeah, I do. I like when the Barbies get chopped up by the pumps. Okay, I think that's all our questions. We really appreciate having you.
Super.
Thank you.
All right, thank you.
Have the rest of the day. See you guys.
Bye-bye.
So speaking of Barbies getting obliterated by pumps, so when my girls were little, there was a toy swap in our neighborhood, and so they showed up. They were so excited about going to swap out toys, and their Barbie dolls were what all the boys wanted because they were going to blow them up. And I'm like, oh my gosh, I'm not sure what parenting is happening there. But anyway.
Like that kid on Toy Story.
The kid on Toy Story. Okay, our next speaker is in the lobby chit-chatting. He needs to come on. I kept asking him, are you on deck? And he kept telling me he was. So our next speaker is speaking on the remote monitoring and wastewater, and it's Glenn Cooper. So Glenn is the Louisiana sales manager for J.H. Wright and Associates. So he got his degree in electrical and construction wiring, but he actually grew up in the St. Bernard Parish government. So he started as a helper in 1982 and resigned as plant manager in December 1999 because you know why? He realized anyone who likes to talk as much as him should have been in sales, right? So
It's all Greg's fault. He literally had him
like that blocked you. Okay, well, good. Yeah, good excuse. Here you go.
Thank you.
Would you rather wear a lapel mark or you go with that?
No, that's good.
No, that one. Yeah.
This one?
No, the bottom.
Oh, the bottom one. Okay. All right. Hello, everybody. And Greg. So anyway, we're here to talk about Mission Skater. If you haven't heard of Mission Skater, you're kind of missing the boat. It's kind of like McDonald's. Okay. It's Skater out of a box. So it's customizable. It started out many years ago, but 20 years now with Skater for lift stations, where we want to say, well, if we have an overflow, we need to know about it before the sewer is running down the street. Well, that has evolved tremendously into not just a standard old auto dial that's been around for years. It's now full-blown Skater. I guess it's been about 10 years now where we're doing 100% wastewater. And about 10 years ago, the Motor Control Center in Lake Charles had burnt up for Calcasieu Parish. And they said, well, they already had Mission. Said, why can't we do Mission on water? And that started the whole thing. And Mission has tens of thousands of water systems now, not just monitoring, but controlling, full-blown control on our water systems. This has been a big help. A hodgepodge is, so just bear with me. You have the operators of the system, directors and whatnot, have to do sometimes do a CMOM report, depending on wastewater, and if they're under consent decree and whatnot. But even if you're just going to maintain your system, like on a water system, how many gallons of water did I make this month? How many gallons of water did I sell this month? What am I missing? Did I have any breaks in the line or what have you? So getting weekly and monthly reports on the pump run times or volumetric calculations on the wet well while putting a transducer in there, we can actually count the GPMs from the pump and then automatically do the volumetric calculations saying that we automatically every cycle are pumping X amount of gallons from the wet well. That's huge information that most operators has never had, and most operators will never know why they need it. But the people above them will know when they have to do all the paperwork and fill out the reports and whatnot. On the wastewater side, on CMOM, the people that have to do I'm gonna bring this up real quick. Anyway, on wastewater side, the people that have to do the actual CMOM report used to have to go. I know because I did it myself when I was in my previous life. You'd have to figure out how many dollars I spent per person at a particular lift station, and this all had to be reported to EPA. Now, instead of having countless hours trying to calculate all this with emission units, you have it at your fingertips weekly, monthly, or whatever, and you can go on the site and download it. But with that being said, we're going to move on because I can usually takes me a couple hours to do this. We can do it in 30 minutes. 29. All right, the mission is very easy. Like I said, out of the box, there's different ways to install it. There's flat packs and there's NEMA 4 boxes. It's all customizable from your system. We can go into anybody's control panel, whether it be very simple relay logic,
pump controllers, VFDs, none of that makes a difference. When they say, well, I have this this kind of panel, and I want to put a machine on it, can it be done? It can be done. A typical lift station can be wired in about an hour and a half, with some experience. Somebody that just opens a box and say, well, what is this? And it might take them a few hours to figure it out. But if you've done one, you'll be able to do, you just get faster and faster and faster. So anyway, there's right and wrongs with everything. We've had some people that this is cellular based. We've had some, let's say, customers trying to do it themselves and save some money, which is fine. So we gave them training, and then I went to one site. The antenna was inside a stainless steel enclosure, so they wasn't getting much signal. Said it's not working. Well, when the antenna is inside a box, inside of a building with a metal roof, you're never going to get a cell service. This is pretty much what you get in the box. All the equipment comes in, everything you could possibly need, even some wiring comes with it as simple as. Now, if you get pretty elaborate on a water system stuff, naturally you have to run wire, change some landings to add the IO. So wastewater, pretty much everything's in a box for a typical lift station. If you go into a package plant or what have you, and you have blowers and whatnot, you want to monitor pressures on the stations. On the treatment plant, then you have to add more. I'm trying to get all this up, but then you have to add more to the extra components to it. So anyway, connectivity. We just had a test. We've had so many storms this year in Louisiana and really across the nation, and missions everywhere, missions in North America and the Caribbean and whatnot. So we've been getting tested on our connectivity. So if the cell tower, let's say the cell tower drops out because a storm went over it, it'll go to the next tower. And if that tower drops out, it seeks the next tower. So these should keep moving down the road. And you can't drive I-12, I-10, or really much anywhere in this country within 4 or 5 miles. You're going to see another cell tower. So, the way missions looking, the way we're all looking at it, cell towers, cell phones and cell towers will be around for a very long time. Probably half the people I know don't even have a home phone anymore. That's how popular cell phones are. And so with that being said, and so many phones out there, the monies to keep the cell towers up and going, the transmission, the upgrades to the system has to be spent. So everybody's sharing that cost. So as the cell service gets better from the providers, Verizon, AT&T, T-Mobile, and whatnot, so does Mission. Mission has to constantly upgrade their system so it keeps talking to the new system. So you hear about these 3G, 4G, 5G. That's all the advancements on different generations of coverage. So Mission, at no cost to the customers, continuously upgrade. I think they up to about 12 electrical engineers on staff now. So they're constantly R&D and different projects, because a customer in certain areas of the country, let's say, well, I'd like to see this, or can I see this? And most of the time Mission says, oh yeah, we can include that at no cost to that customer. And once they roll it out for one, they roll it out for everybody. That's how the water systems grew pretty rapidly. We're still getting into the installation, but a lot of things come standing in the box with the antennas and whatnot. So pretty simple to install. That's the way it should look within at the top up there with the antenna. All the brackets and all come with it. Even a person that is not electrically inclined or mechanically inclined, with just a 15-minute tutorial, I could teach them how to do it. That's the new unit. This came out 2 years ago, and
it started where we can do everything I said before with water, wastewater, and whatnot. But there are a lot of operators, let's say, that didn't carry a cell phone with them or whatnot. And to get all the information, you'd have to have a cell phone, iPad, or a computer and whatnot. And so they had some customers asking, well, it'd be nice if we could see all the pertinent information right there in front of us. Just like the old ETMs and whatnot, where the operators would just check the numbers, put the clipboard, put it back in the cabinet. Most people don't even know why they were doing that. But I don't have time to tell you some of the stories I could tell you about that. But anyway, with the new model, it's a touchscreen controller. Everything that you need to know that's happening in that station is right there. The voltage, if you want to, you can get amperage off and put some donuts on the pumps. You can monitor the pumps. If it's example of drawing 20 amps day in and day out, all of a sudden you're drawing 40 amps on one of the pumps, there's a blockage within that pump. So before it actually fails or it goes lock road or burns up, then somebody would have to go out there and unblock it. Or if it seizes up, we even put on self-priming pumps like a Gomer-Rupp, Wemco, Hydromatic. It doesn't make a difference whose pump it is. We could put a temperature switch on the bowl of the pump, and then if it loses prom, as the water heats up in the pump, it also heats the casing up. So I recommend 140 degrees. Wastewater is typically 85 degrees year round, but if you hit 140, it triggers an alarm and it lets somebody know that they lost prom and it's starting to ball. So like an above ground pump, self-priming pump, will not just ball the water in the pump, it'll steam the water, and then seals and bearings are spent after that. You have to do a complete rebuild. So anyway, there's different things we can customize per with the operator the system wants. Printed circuit board is basically a computer at each station looking at what's happening at this site, whether it be water, wastewater. It doesn't make a difference. It's like I have an operator there 24/7 that doesn't get sick, doesn't go on vacation, and constantly watching. Pump come on, pump goes off, pump goes off. And you want a nice little sawtooth at a lift station. You can see that when you go into graphs, you'll have a sawtooth. Pump one, pump two, pump one, pump two, continuously. If you get something like this, where it goes way out of whack, then something's wrong. Or if you see where pump number one may run for a day or 2 days before pump two even comes on, there's a problem with the pump number one, because it's either partially blocked or the impeller shot, or it's just running very inefficient. But it's a way to monitor your equipment all the time and do preventive maintenance. Because unfortunately, not just in Louisiana, but most of this country, we run to fail, which means they put a piece of equipment out in the field, rotating the piece of equipment needs to be maintained. If you don't do anything with that piece of equipment, it will fail. And that's when the operator, I got to go change this pump and what have you. But this is a money savings venture. Every lift station we have, if you prevent one pump from burning up, it's paid for. On a water system, I've had a number of water systems that would say, I don't have the money within my budget to add this to it. Well, and I would say, if I can show you where you could save money on one category, one item in a budget and pay for itself, would you do it? And most of the time, 9 times out of 10, it comes out of chemicals, especially with chlorine. If you put in chlorine within your water system and then your water tower is only half full, you off gas in that chlorine. So you're doing 2 things. One, you're wasting money on chemical. The other thing is you're eating up that water tower. And I'm not going to mention any names, but there's a number of systems just here in Louisiana that I work with, where the water tower is half full on a regular basis. We had one system I could probably pull up now. The column pipe is full, but the bowl is empty. That doesn't do any good. So what that does, we monitor the pressure on water systems. Sometimes we monitor the pressure within the system on a lift station. We can run calcs or whatnot. It's a tool for engineers to do a station evaluation, especially at night. If you have a number of lift stations, that pump into like one main station going to a treatment plant or whatever, you can actually monitor the lift station, what time of day they coming on, how many times they come on together, and then you could factor in which size force main we need. Do we have it? Is it sized properly? Do we need to step it up another size? It's pretty much customizable with y'all would need as well. Mission also has manhole monitors where you can include that with include the manhole monitors when you're doing a station evaluation or a system study, where you can look at your surcharges within your system, and that way you could see like 1 inch of rain equated to so many gallons coming into that lift station would mean that pump ran even longer than the extent of time. So you can actually do a study, calculate it out, where we know what 1 inch of rain equates to 2 inches and whatnot. And by doing so, you can just about track your I&I, see where it's coming from, and find those point repairs that would help you. Main board, customizable, everything comes off, unplugged, so it's easy to wire. I'm not going to go through all of that for the time being, but comes standard with 2 analog, 8 digital, 3 relay outputs. So we can easily start and stop pumps remotely. We do it on a standard basis on water just about every day. We'll take a pressure from a water tower that could be miles away, and then at the water plant, by supply and demand, we'll start and stop the pumps, and then watch the reach its level, reach its demand, fill the tower back up, and then shut itself off. We can do it on wastewater. On that, I always recommend that we have a maintenance program within that, because we don't want to, as an operator, say, well, I'm going to turn pump number 1 on this particular station, and then it evacuates the wet well, and then there's no water left in the pump, but it's still running, and it's running dry. Well, then you say, well, Mission did it. Well, Mission didn't do it. You the one hit the on button and whatnot. So you have to have a system of checks and balances whenever you do something automated. And this is be no different than any other system that would talk to you about automation. The difference between what Mission does and other automated people is the cost. The more people that or more systems that get on this with Mission, it just keeps the cost down. Mission started, like I said, 20 years ago, and the cost has not gone up in 20 years. Think about all the manufacturers y'all fool with, any of them, and they cannot tell you that. Mission can. And the reason being, because of the growth, the more people that join, they're able to keep the same cost down, which it's not a bad business plan, because it just keeps more people just joining. We have people here from the city of Lafayette. Lafayette was the 3rd customer Mission ever had in the country. And then now I couldn't even tell you what today's numbers are, but tens of thousands between water and wastewater. I'm not going to bore you with this, but different size boxes for different uses. Like I said, back in the customizable. So we supply what needs to be there with the different size with the system. Old, new. You can see the touchscreen on the bottom. If you have a control panel with a dead front, typically that's where you put that flat pack. That's what's called flat pack. It's only 1 inch thick. So you can put on the dead front door behind the outer door, protected from the weather, and all the operator's got to do is open one door, get all his information without going into the backside. With ARC flash being pushed by NEC and whatnot now, unless you an experienced electrician or operator or whatnot, you do not want to go into 240 or the 480 side. So you just keep it in the front where everything's very safe to operate. This is only 12 volts, by the way. We'll take 120 volts in, reduce it down to 12 volts. Usually runs about 14 on the transformers, but it's still within parameters. Anything on the 24, we find. But again, this is basically a computer in a box. So if you put 120 volts to a computer, it's going to explode, right?
they let the smoke out. I've seen that. Actually, I've had one operator. I was en route to their system, and they said, "I'm wiring her up now." I said, "Don't energize it till I get there." I pulled up, get out my truck, and as soon as I walked up, they didn't even tell him anything yet. There's a blue flame about 1 inch long, and then poof, the smoke came out. He hooked the transformer backwards. So at 12 volts, we had 1200 going to that board. Didn't work too well. So, but pretty little blue flame, you know. So, I mean, this is a SCADA class, but I do more pumps and controls than I do anything. So just to let you know that all equipment comes with smoke in it. The trick is not to let the smoke out of it. You know, a lot of motors and whatnot. So most times we shoot ourselves in the foot. When I say we, I mean operators, and we're trying to maybe sometimes save money, cost us more money by trying to save 10 cents. And that's typically what happens. So I don't know if there's a pointer on here. Yep, there it is. It's not showing on the screen. Now y'all tell me. So anyway, pretty simple to hook up. With the analogs, analog simple is like flow meters, transducers and whatnot. You can actually see the levels in the wet wells. On the smaller stations, it's really not big a deal. Float operated lift stations is strictly dry contacts and you just start, stop, start, stop. But on the larger systems, it's getting more critical that we monitor the stations for the greater needs and goods. Because if y'all operating stations or designing stations, these pumps are getting bigger, bigger, and bigger. So you really have to protect it. So if you're going to spend $200,000 to put a lift station in, you should spend $2,000 to put something that's watching it. And as an engineer or operator, you can see everything that's happened within that site as well, without having to go to the job site to see it. So standard 2 analog, it's expandable. Standard is 8 digital, dry contacts, expandable, and then the 3 relays. The 3 relays, like I said, use the start and stop the pumps. Typically, that's plenty enough, but we can also include that. So this system, like I said, is made to grow as the system grows. So I just I just put this in a water system in Bayou Liberty, and they said, I just want the basic units. We just want monitoring, and I see what's happening. But 6 months from now or less, they'll probably go into full control, monitoring the complete water system. So when you put a unit at a water tower or put a unit at a plant or whatnot, we take over everything. We just look at it and okay, we need to do this, this, and this, and this. Because we've done so many water systems now and wastewater systems, we tell the system and we'll tell the engineers the best way to monitor a complete system. We've had customers that say, well, I want to leave this one out. We can get it later. Well, that may be the crucial unit you need to put out there to get the information back to start and stop all these pumps, to run your system. I know I'm boring y'all with IO, but I can only talk so much on this. It's so basic. I mean, it's the mission calls it the secret sauce. It's not what you see when you go out to the field. You see the printed circuit board, you see the wiring going in, but it's what happens at their end. Mission has 3 servers, 1 in Atlanta, it's actually in North Cross, just northeast, 2 in Ohio. So if we having a storm in Louisiana, no equipment's going to get ruined. I mean, we lost a lot during Katrina and whatnot when we lost control panels. So when control panels are gone, the actual mission, SCADA will be gone as well. But the reason they did that separate servers, if one goes down, we don't need the country shutting down. So the 3 servers are talking to each other at the same time. So if one happens to go down or they take one down for maintenance, and the other one just keeps maintaining the country, because the more and more systems that go on it, it just bogs it down. They've upgraded their servers probably 5 or 6 times in the last 20 years. I mean, they're huge. I'll tell you a really quick story. When I went to go see where the server bank is, it's a building, no name, just an address, You don't even know where it's at. Most of the servers for companies that y'all would know, Bank of America is one of them, where the money from Bank of America every night is transferred, billions of dollars goes to the Cayman Islands and back every morning. Did y'all know that? Back and forth. They make money. Because the way they explained it to me, that if you make a penny on a dollar by doing it every night and thinking of billions of dollars, you make a lot of money. So anyway, with that being said, there's a lot of companies that have their servers within the same building. It's completely 100% air conditioned, 68 degrees at all times. Mission has to do that as well, because since it's FCC approved and let's say big government is also watching, because with security and whatnot, terrorists, and especially since 9/11, they don't want anybody taking over a water or sewer system, because as engineers and as operators, I mean, you can think of many ways to hurt the general public with water or wastewater. I mean, I can tell you a list immediately, but you don't have to be on site. You can do it. You can do it from your kitchen sink, from your house, and but so anyway, with that being said, we have to monitor everything, make sure the person that's going online to look at a certain water system or lift station or what have you is that person. We've had people that say, well, I'm going to put a system here and I want this box to talk to this box and this box, and then go, well, that doesn't happen. The boxes do not talk to each other. When you go online, you go to the server. And from that server, you relay the information that you want to see. You could page it right then and there or look at it. But from the server goes out, gets the information you want, brings it back to the server, and then sends it back to you. That's the checks and balances we have. Because Mission also has a DOD contract. I have no idea what they're doing. Most of the people in Mission does not know what they're doing with DOD. But they as well has to protect their whatever data they moving back and forth. So it's critical that water and wastewater is protected as well. So you would not believe the red tape. And one of the caveats people forget to mention now, I've been with Mission since day one. I work for J.H. Wright, but J.H. Wright's been with Mission since day one. So the way they set it up when they first made the company, all the data doesn't belong to the water or wastewater system anymore. They have access to it. Let's say the Hammond. We use Hammond because Hammond's one of our big users. The city of Hammond's, all the information is on the server. But if a general public, like say, an attorney wants to sue the city of Hammond because they had a backup in a sewer backup in somebody's house, Hammond is forced to give that information to that said attorney. But because they do not own their own data, now, if they force to, the judge can tell the city of Hammond, we want this information, then they have no choice. But it's another checks and balances to protect the water and wastewater system, because once the information goes to Mission, it belongs to Mission the way they're legal, the way they legally set up that information. Now, and again, it's all for the system's protections. 5 minutes. I have 5 minutes. So anyway, I better not get on too many stories. But so anyway, Mission has, there's a lot of SCADA systems out there. Actually, they get less and less every day, because in this business, you either make it or you die, basically. There's a lot of offshore SCADA systems now that, since the oil business tanked, the oil field had tanked, they coming into the muni business now, but as soon as it all picks back up, they're going to be gone. So with that being said, you have to do as much as you possibly can do, monitor as much as you can do, control as much as you possibly do. But then the caveat is at the cheapest price possible. That's very, very hard to do, because, municipalities, it's always about the bottom line and about the budget. So with Mission, the reason Mission came about is because there was a municipality years ago that said, well, we'd like to monitor this. All this Mission SCADA started out with Bell South. One of the engineers for Bell South that developed it for Bell South said, well, we don't want that technology. So they just shelved it. And the engineer that developed it said, well, I'll buy it. And he says, and so they signed an agreement with Bell South. He bought the technology started Mission Communications. Here we are today, because the engineers at Bell South said, well, we don't believe cell phones is going to take off like that. Everybody's going to keep their wired landline. Well, we know that's not true today, right? You think Bell South is messed up? I shouldn't tell you, but I'll tell you. Speaking of cell phones, I should have turned mine off. Yeah, I just got here. The engineer that bought it only paid $250,000 for the technology he developed. I wish I'd have bought in. So anyway, most of the time I don't use this. I just get up here and talk. So y'all've never seen my presentation before, because I don't need the slide presentation. But anyway, customizable, like I said, solar-based units, rainfall. If you don't want to put a rainfall tipping bucket on it, we've done, it goes to the closest airport and gets the information. But this is Louisiana. I've seen it rain across the street from my house and not rain at my house. So it's hard to get accurate information unless you have tipping buckets within your system. Normally I tell like cities, let's put one north, south, east, west, and whatnot, and get the information. We can get more data. That's if we can do a study. If we're not going to do a study, it doesn't make a difference. Pressure transducers again, and that's a little elk relay at the bottom. All that does is we go into the control voltage of to start a motor, but since it's 12 volts on one side, we can't put 12 volts, so we can't put the 120 control voltage through it. So we use electronic relay where it's 12 volts on one side, 120 volts on the other side, close the relay, start the pump, and then reverse it when we're trying to stop it. Easy peasy. Solar units we've actually had in the field. These become real popular. When we had the amoeba skier with the water department and whatnot, the MRT, POEs and whatnot, we were building them as fast as we could get them out. That's kind of slowed up some, but the DHH actually helped my business. So I thank them for that because there was requirements, and then you can't see it, but that's a chlorine analyzer right there. That's becoming more popular with the cost of doing business, labor, fuel, less employees nowadays. It's hard to get younger people in this field. So a lot of systems are lacking personnel to go out and check and whatnot. So chlorine analyzers started out 2 years ago to be really, really popular. So I know. All right. Well, sorry. Sorry if y'all want to talk to me in person. I'll give some brochures. I'll leave them here. So other than that, I'm getting swamped by pink. So thank y'all.
I know. I'm glad we backed you down. Yeah, thank you so very much. We appreciate you joining us. Our next presenter is Michael Gervais, and he's a local bridge consultant with Contact Engineered Solutions. He serves the Louisiana-Mississippi market. He's been with the company a little over a year. Prior to joining Contact, Michael worked in engineering consulting within the oil and gas industry and also a project manager for a private commercial developer. Now, Michael's from Chalmette, and he has a degree in civil engineering with a specialization in structures from Georgia Tech, where he played college lacrosse. I just thought that was interesting, so I wanted to include that. Okay. He currently lives in Metairie, and we really enjoyed him joining the Contact team because we've been so busy since Michael came on board. So thank you, Michael. It's yours.
Thank you. Oh, no, this is fine. Yeah, this is totally fine. How's everybody doing? Thanks for having me. Really appreciate the time to be here. I'm going to jump right in. So this Conspan presentation, I have about 30 minutes, I'm told. It typically takes about 2 days to really go through a full training on this. So bear in mind that I'm not going to be signing any certificates of expertise at the end of this, but I'll do what I can. But yeah, so like it was mentioned, my name is Michael Gervais. I'm a bridge consultant with Contact, and we're going to go ahead and get started. So first and foremost, I want to point out I'm very blessed as well to have a partner like Gainey's here in Louisiana supporting my business. There are bridge consultants like me all throughout the country that don't have that sort of relationship with their precast facility. And so I'm very happy to be here. Very excited for what that future holds as we sort of continue to develop these conspan arch units. I guess real quick, just to kind of gauge the room, anybody who's not in a pink shirt, have any familiarity with contact, maybe context bridge division structures? Yeah. Okay. Sure. Okay, great. That's going to help. So going through today's topics really briefly, we're going to hit on just sort of an overview, some industry trends, some innovations that we have as Contech, and also our design approach. And then we'll wrap up with just some applications, some different sort of pictures and things to look at. I want to keep it as informal as you'd like. So if you have any questions for me, just go ahead, interject, jump up and down, raise your hand. We can do whatever you need to get your question answered. So really briefly about Contech, for those of you in the room who may not know a little bit about the company, what you see here is a graphic that's in our structures reference guide. I'm going to leave a stack of those here along with my business cards for anybody that wants to take one. But it's really just an overview of the entire portfolio that Contech offers, which includes that structures division, but is also going to include pipe and stormwater, which is going to be on the outsides of the stream here in this picture. But really, if you have something to cross, if you have a stream running through your project or some access to a site that you need, that's a pretty good indicator that we could probably work together as your bridge consultant. A little bit more about Contech. How do we do this? I'm definitely not a one-man shop. We've got about 60 me's throughout the country who help to really drive that business with about 200 individual support staff, engineering teams. We'll handle everything from start to finish as much as you'd like kind of along the way. So I'll talk about that here in just a little bit. So this is, again, just some branding, the bridge portfolio. And of course, today is all about precast, right? So I'm going to remove everything that's not circled there and really focus on these four topics. So the Conspan O series, the Conspan bridge systems here, jumping down to the B series, which everybody's most familiar with from a concrete arch standpoint. And then, of course, BIBO, which we're really excited about starting to grow that here in Louisiana. And then ultimately the Express Foundations, which again is a new technology that we're developing currently. So a little bit about those bridges, sort of how this process starts. A municipality, a private client, whoever the owner ultimately will be, will come to me, usually via some engineer or directly, and ask, hey, I have a 40-foot span crossing that I need to develop a solution for. What type of options do you have? And this is generally where we start. And so what you see there in the bottom x-axis is the clear span, and then all of our branding and different bridge spans that pertain to this chart here. And so as you can see, really from as small as, let's call it 12 feet, all the way up to somewhere north of 112 feet, we can develop a precast concrete arch to be suitable for that project. That's done in a variety of really fancy ways, as I like to call it, with the BIBO systems and a twin leaf, which we're going to talk about in a minute. Because you may be wondering how on earth we ship a 100-foot span concrete precast arch across the country on a single truck. And the answer is we don't. Quick industry trends. So buried bridge is really, I guess, the overarching title of what these precast arches qualify as with consideration for Federal Highway Administration. And so the buried bridge versus a bridge at grade, or a buried bridge versus a culvert, a standard culvert that everyone's obviously familiar with, something that I'm going to touch on really quickly. And then as well, the FHWA Accelerated Bridge Program. So this is, again, an example of kind of where this process starts. A client comes to us and says, hey, we have a conventional bridge. For whatever reason, it's no longer suitable for use. And so we're going to modify that technology, maybe develop some sort of a new solution. What are the options that I have? And of course, you know, with a conventional bridge, there's all this void space underneath that really is not utilized, and also brings about the, I guess, hardships from a maintenance standpoint of these vertical piers, scour, different things like that. And so what we're able to do with a buried structure, which is pictured here as Conspan O series, is bury that structure within that void space, minimizing that space, and then also utilizing that space to be more economical for the project. And so you can see here that that conventional bridge falls off, but really what's the comparison, right? What's the point here that I'm trying to make? And that's that a buried bridge versus a bridge at grade. And I always like to say as a caveat, sometimes a bridge at grade is the answer. If it's wetlands, if there's some reason that, special other waters, DHH is not allowing us to cut into this stream bed, that's fine. But when possible, a buried bridge has some significant advantages, specifically regarding shorter construction time, lower initial cost of installation. For example, about a 40-foot span concrete culvert with these precast arches will install generally in about 3 hours. And then we'll backfill up to the roadway and pour concrete within the remainder of that week. There's minimal to no long-term maintenance. I mentioned the piers, scour, things like that. These buried concrete structures are really going to shine brightest in the fact that you bury the structure, allow that soil structure interaction to take place, and walk away from it. Another is going to be one of my personal favorites down here, second from the bottom, bury utilities over the backfill in the structure. So that's really where it comes in, that we're able to utilize that void space, minimize on utility relocations, and also allow for existing or future utilities to interact with our structures and actually fall into the stream that we are ultimately crossing. So very customizable. We'll talk a little bit about that here in just a minute. So the Federal Highway Administration classifies us as part of their accelerated bridge construction program, which is really, really exciting for a number of reasons. First and foremost, it's really a great way, I guess, to work with each individual DOT, but it's also given us the opportunity through FHWA's proprietary products rulings, which if you're not familiar with, that is a very different legal presentation. But there are ways on public projects to specify proprietary products so that you have more comfort in your engineering design. And these qualify for that through FHWA. And so how do we do that? Technically, we are PBES. That is the prefabricated bridge elements and systems, essentially built off-site here. That's what brings me here today, built at Gainey's. And then includes features that reduce on-site construction time and the mobility impact time that occurs when building new bridges, which is what I just hit on here just a second ago. So that's a broad overview. Again, that's a big discussion and is something that FHWA has published for their proprietary products ruling. So now that we're through with that, I guess any questions just kind of off the top, any thoughts circulating? Yes, no? Okay. Context precast innovation. So I'm going to hit on the Conspan O series, the B series, and BIBO. What you see here on the left to your left is the Conspan O series. What you see on your right is a BIBO, which is more of that true arch shape structure. So I want to start off with a little bit of history. What you see here back in around 1980, Contech with the use of the Conspan B series. So that first version with straight vertical legs, which I'll show here on the next slide, really begins with the buried structure, kind of soil interaction applications all throughout the country. We started to identify different precast partners that we wanted to partner with and then start to develop solutions. And as you can see here, somewhere in the mid to late 80s, we started to produce that Conspan B series on a national scale. Fast forward to, I believe it's about 2005. We start to work on this design your own bridge system. And then through that process, realize that because of the form work that is required for B series and the limitations that puts you in, we really needed something that was going to be able to be a lot more customizable in 1 foot increments of span and rise. And so we came up with the Conspan O series, which is a proprietary product that I mentioned there in about 2012. And so that's going to be the bulk of what I'll mention here in the next few slides. So really focusing on the middle picture here in the bottom, and then to the right is the Conspan O series, O standing for optimized. It's an optimized B series. What we were able to do by flaring out the legs of the Conspan B series at roughly a 45-degree angle is actually minimize not only concrete, but also steel. So the same span distance of a Conspan B series will utilize less steel, less concrete, way less, and be easier to install than a B series of the same exact span. So the O series, believe it or not, that's always one of those, oh, wow, how does that work moments. It actually works by reducing the moment at the transition from the arch structure to the leg. Additionally, though, and a very intentional benefit is that you are able to incrementally increase with the use of the formwork, and this is where Gainey is definitely the expert and I'm not, to incrementally increase span and rise in 1 foot increments, as opposed to a B series, which would be a 12, 14, 16, jumps to a 20, a 24 foot span. There's a lot of space between where you may not necessarily meet those requirements. But then also, because we've flared out the legs, the span to rise ratio is going to reduce. And so we can fit these into very low rise situations, low height of cover, and really optimize that design. And so you can see that here, just again, sort of a comparison between the B series, the O series, which is really going to just optimize that clear span application, hydraulic area of flow, low flow specifically. So this is the Conspan O series. We'll talk about that really briefly. The top right is probably the most common for what we see here in Louisiana, Mississippi, specifically regarding when we have heavy rain events or any sort of rain coming down from snowfall. So I always like to point that out, that these can be buried as well within the waterway or hydraulic zone. That is something that we can look at in case of high water events. But say for 10 months out of the year, that's not an issue and it's pretty dry. These are all going to be in modular components. We have the precast foundations, which I'll talk about here, I believe, in just a second. But each individual unit is going to arrive after being delivered out of Gainey's, and then will arrive on site, arch units, head walls, wing walls, and be set in place, a 40-foot bridge or so within the matter of just a few hours. Most of these have not lasted beyond lunch before they're ready to backfill for the next day. So I mentioned, how do we ship these when they get above a certain span distance? That's going to be our twin leaf construction, which I have an example of here in a minute. But effectively, the way that works is we splice a concrete arch unit at the center point and develop a keyway. And I'm not sure how clearly everybody can see that, but there's a little notch kind of where those two guys are standing in that picture at the bottom middle. And so what that notch allows us to do is to suspend each arch unit, abut them in the center, and then use a closure pour, which is effectively like the last ice block in an igloo. And what that closure pour is going to do, which there's going to be exposed rebar in that zone, is going to allow for the true arch structure to then take all the loading responsibilities that are required for the project. And so that is, in a nutshell, in a very short way, how you splice a precast arch and ship it across the country for larger span distances.
We showed earlier, we were showing some of our projects, and we showed some pictures from Pine Hill where we did the twin.
Good,
So
awesome.
they were able to kind of see
Cool.
when we were making it here, and then, yeah.
That's perfect. Well, Pine Hill is one of my examples coming up, so everybody will know about it. Sure. Yes.
What is the determining factor for what type of the bridge goes in what area?
Okay, just if you'll repeat questions because they can't hear.
Oh, okay. So can you repeat it then one more time for me?
So what is the determining factor that tells you which type goes in which area?
Sure. So what is the determining factor that determines which type of precast arch unit we're going to use in which area? It's kind of a checks and balances. We like to provide a lot of options. Initially, what we're going to start with is the clear span distance. So what type of span are we looking for? After that point, we're going to look into the rise and also your height of cover to make sure that we're not going to cause any gradation issues. And then we'll also look at, if that span is above the 65 feet, we're going to have to now splice the arch unit. And at that point, it does, in some cases, become necessary to use a mixture of the modular precast units and a cast-in-place head wall and wing wall system to allow for some of those larger span situations. Or if it's a situation where access to the site is maybe particularly difficult, we will work with a contractor to develop a cast-in-place solution as well. So, sure. Yes.
The bottom middle
Mm-hmm.
design, you said that's a poured-in-place joint. When you bring the two arch pieces together, you're gonna pour the connection in place.
Yeah. So the question, I got you. So the question is regarding the bottom middle picture, and if that is a poured-in-place section at the center of each of the arch units. That's correct? Right. That's the question. And the answer is that's correct. They are going to arrive in 65-foot or less distances, depending upon the total span distance. 65 feet is typically where we can no longer ship an arch unit on a single truck for permitting reasons. And so what we do is notch a keyway with exposed rebar into each end of the arch unit and then utilize multiple cranes to suspend those units and abut them together. And then that closure pour will react with the exposed rebar to take on the loading. Sure. Follow up?
Some of the conspan designs that I'm seeing now,
Mm-hmm.
in St. Bernard Parish or wherever, they don't have a concrete bottom. They just have two, I'm gonna call them girders of foundation.
That's right.
How wide is that gap that you're gonna have to pour and put? Because plenty of times all they put, you don't even excavate. You just, the dirt bottom that's existing stays there and that's it. There's no rock bottom.
Mm-hmm.
There's no bedding or anything like we used to have with regular pipe.
So before I repeat that question, I want to make sure I'm understanding you correctly. The arch pour being atop the precast structure.
How wide is that connection or poured in place?
At the top midspan of the arch? Okay, so the question is, how wide is the keyway that is going to be poured in place on top of the arch at the midspan? It depends upon the design loading. It depends upon what loading classification we're looking at for vehicular passage and also live load. It's typically going to be about 3 to 4 feet in width, and then it will extend for the entire length of the structure. One continuous pour. Correct. Good. Okay. Moving here, just a picture, sort of some generic pictures. I'm going to actually skip through this just in the interest of time, because it sounds like y'all went through that a little bit here earlier with Formworks and how that works. The Express Foundations is another precast system that we're currently working on developing. This I'm really excited about. This is sort of a pet peeve, kind of side interest of mine. It's going to, like it says here, blend the speed of precast with the economy of cast in place. It's a significant reduction in on-site construction timeline and is also a significant increase in the confidence that you can have in what is eventually going to be there on-site. The way that it works is it's a formed up here at Gainey's formwork to develop this precast express foundation that you see pictured here. And what you see in the void spaces there in the center is exposed rebar. And you also see some of these holes here that you see grouted out. That's to allow for that fill to then connect multiple units of the express foundation as well. And that keyway, like we call it, you can see kind of notched in there to the top right of that picture. That is where the legs of the precast arch unit will set onto the express foundation. And those legs will be grouted in place. And so the way that this process typically works is we will have a contractor come out, lay a stone pad, maybe a pile cap, whatever the situation may be based upon the geotechnical recommendations. And then we will set the express foundation down onto that pad. This will arrive with the arch units. Those arch units are then going to be set into the keyway. The remainder of the express foundation at that point is going to utilize cast in place concrete in those void spaces with the exposed rebar to allow for it to act as the true foundation for the structure. And then the arch units are going to be grouted down onto that existing now express foundation. Sure, question?
Are the rebars at the bottom of the arch that interconnect with the express foundation?
Sure. So the question is, are there rebar that are at the bottom of the arch units that interconnect into the express foundation? The answer is no, they do not have to. The way that the express foundation works is really independent of the individual arch. The reason that we have the keyway and that we grout that area is because we do want to allow for some flexibility of the concrete in the arch. And so in tying it, we would essentially be removing that capability to flex with the live load and whatever's traveling atop. And so the two of them act independently, but obviously the express foundation supports the arch. So real quick on design approach, I'm really going to roll through these fairly quickly. Feel free to stop me if you have a question. Excuse me. So again, from the standpoint of a buried bridge structure, we're talking about the soil structure interaction and really allowing for these arch units to interact with the surrounding areas and also utilize the fact that we no longer have that void space of a conventional bridge at grade. What we use is a system called Gainey. It's culvert analysis and design. There's a lot of extra letters in there. I don't know who came up with that, but that's what it stands for. And what that is a finite element modeling software that we run out of our engineering office in Ohio to run every case for any situation that you would be seeing on your site, whether it's multiple live load cases running across the culvert sideways that a guy's in reverse for whatever reason when he should have been going forward. We're running a lot of different cases is the point I'm trying to make. And so you can be really sure that the arch unit that you're getting is fully capable for whatever loading requirements you're going to be seeing on that structure. And this here is just a quick look at what the inputs are. The output does not look very much different. The output just comes with some different values. But the way that this is input and what you're seeing here, in the yellow vertical lines there are going to be your piles. You're going to have your pile cap foundation just above that. That orange area is a select backfill zone to allow for that arch to not spread beyond the half-inch deflection that's required. And then the green is just going to be your standard fill that the geotechnical engineer recommended, and everything else is existing soils on site. We'll run this at each node. That's why it looks kind of like grid paper. Each of those nodes is an individual input of information dependent upon the loading that's going to be required. And so we'll run Gainey for every single arch structure that we develop. Another question that often comes up is, sure, deflection is important, so is hydraulic waterway area. We've pre-designed that as well, and so just a couple of slides here about that, whether HECRAS, HY8, lots of different options. Rolling through some applications, you mentioned St. Bernard Parish bridge replacements. These, we're really, really happy with how this program has gone. We qualified for FEMA funding with St. Bernard Parish to develop some rehabilitations and replacements of existing crossings in their residential neighborhoods, something that we definitely hope to continue. It's been a great partnership between Gainey's, Contech, St. Bernard Parish, and all of the engineers and contractors that we've worked with. This is that Pine Hill Road. It sounds like everybody kind of got a brief overview of that. Just a really unique project, especially here in Louisiana. What maybe was not mentioned earlier that I'll mention now is the reason we went to a BEBO arch instead of a Conspan O series is because we were able to eliminate the need for a deep pile foundation by switching from an O series to a BEBO. The reason that is because of being that a BEBO structure has more of that true circular shape, the vertical loading from a BEBO arch unit is larger proportionally to the horizontal loading as opposed to an O series, which generally has a similar loading in the horizontal and vertical direction. And so when you increase the horizontal loading with an O series, piles typically don't love horizontal load, right? And so what we're able to do here is, because we had the height to cover and also the rise area, was come back out with a BEBO and eliminate the foundation. And so just a story quickly about sort of working with clients, working with the manufacturer here with Gainey's, and also working with the engineers to develop the most economical solution for the end user. This is a really cool project that I always like to talk about. This is something that I really hope makes its way down here to Louisiana. A gathering place for Tulsa. Is anybody familiar with this? No? So this gathering place is just a hundreds of millions of dollar park that they developed in Tulsa that was majority privately funded. And so I don't know how to get into that family yet, but I'm working on it. But it is just a magnificent park, beautiful area. And what they have developed are what's called land bridges. And so what a land bridge is, typically when you think of it, would be a wildlife crossing up in the Pacific Northwest to allow for bison to herd and things like that. Well, it turns out they're pretty good for people too. And so what they've developed is a large crossing with the use of a double barrel Conspan O series atop a pedestal wall, which is what you see here, to allow for vehicular traffic underneath the arch and for people to cross atop it on the bike path, in the botanical gardens, whatever it may be, as though nothing has changed. And so that's what you see here in that picture. That's a land bridge. And this facility, I don't know if anybody's just kind of going up the country and going to roll through Tulsa anytime soon. It's phenomenal. It is a phenomenal place to visit. But yeah, that's all a Conspan O series underneath there. Yep. Thank you. That's good. I'm getting close to time. This is my last slide, so I'm going to really take my time on this one. Just really quickly, these last couple slides, kind of how this process works. Engaging me as early as possible. I'm here to help with anything that you would really like to know, even if it's just hey, I'm curious how the design your own bridge system works. I want to see kind of what's the next steps and how to work together. And so really briefly about that DYOB. If you go to our website, it's in the presentation, it's on my business card, it's on the structures reference guide that I'm going to leave here. There's a tab to design your own bridge, and with very minimal inputs, clear span distance, vehicular loading, roadway width, you can go in and actually design your own structure and get proposal drawings sent back to you within about an hour. What's also going to do is let me know that you did that, at which point I'll engage you and we can start to determine what about the standard proposal drawings that you got, do we need to tweak to make sure that we're really going to be in line with what you're looking for and developing for your client. And so what you'll get is something that looks like this. For the most part, the intention and best case scenario is that the DYO is not drastically different from what is eventually put in place at the site. But really the emphasis is on just providing you with options and support, and that's really what I'm here for. So with that, I'll end and see if anyone has questions.
Can you just briefly mention the New Orleans airport and what you're planning to do there?
Certainly. So the question was regarding the New Orleans airport and what we're planning to do there. I guess it's been a little over a year now. Stumbled into the right place at the right time and find myself talking about a precast arch culvert system that is going underneath taxiway GB, so underneath one of the runways. We've developed a very complex system with a Conspan O series with skews all over the place and connections to existing culverts and things like that. But this is an extremely large job and also extremely important. Currently, with the new airport terminal and with the setbacks that were required for it to be constructed, there is no maintenance access to this stretch of runway. And so our role is to bring that to them. And Gainey's has been a phenomenal partner on that. I know it has basically consumed our lives. And here in about 20 minutes, it's going to consume mine again. But it's been a really great project for us, something we're really excited about and has really helped to grow that business. This is at the new MSY airport, the New Orleans airport that was just built here. Sure. An existing part of the runway does not have a maintenance road beside it because there's an existing drainage ditch and canal that runs alongside taxiway GB. And so what we're doing,
Talking about crossing the Paris line tonight, or what they call the Paris line.
yes, yes. Mm-hmm. Yeah, so we are covering a portion of really what is ultimately a culvert outfall into a ditch to allow for the area to be paved atop that existing waterway. Does that make sense?
Yeah, I was just curious.
Sure, sure.
We pumped 25 foot of sand into that area where that runway was extended.
Yeah, it's been interesting.
A lot of sand.
Sure.
So this is one of our favorite partners, and you can see why. We are so excited about being a part of Contech. Really cool stuff, lots of great know-how. And so the joke about being a precast plant is you're always the wrong size, because if it takes 18 months to build capacity and a lot of money, and then now you're there and you have a downturn, and now you're too big and you got to scramble to get smaller. So we so believe in Contech. What you see going out there with the second bridge crane, the second gantry crane, the runner system all the way out. That's preparing for this job because it might be big for you. It's really big for us. So it's 115 60-foot arches that we don't know yet whether we have to store all of them before they ship. So we were happy to make that investment because we believe in you guys. Thank you. Great job.
Thank you so much. I appreciate you coming. We thought we were going to be in bridge production right now. So with that being said, we were going to do a plant tour right now where we would show you the bridge production. We're not in bridge production because you know what? Nothing is ever what you think it's going to be in manufacturing. So instead, Brittany Richardson, our projects development manager, is going to come up and just kind of go through some slides to show you what a typical bridge production is. You are more than welcome to stay in here and go through that. Or Tim, raise your hand. Or Tim, we got two Tim. Oh, look, that was good. Oh, yeah. Or Tim Sander will take, yeah, he's going to take, yeah. Hey, I got that thing for you to wear then. Yes. So Michael left cards and brochures up here. So make sure. Yeah, Tim needs his little thing. So if you want to go with Tim Sander outside for a plant tour, they're in production right now, and you're more than welcome to step out for another one, or you can stay inside here. And Brittany's going to go through a couple of slides on bridge production. Come on, Brittany, I got to introduce you now. So Brittany has been with us for 2 terms. Okay. First term lasted about 3 years in which she mainly did project management. And I think you hated every moment of it. Then she decided, I'm going to be a stay-at-home mom, which is the hardest job in America. And that lasted for a couple of years. And she realized, you know what? It's for my sanity and those kids' safety. I need to go back to work. And so for her second term, she's been with us roughly about 3 years. And I think she really enjoys being the bridge between operations and how it's made and the project managers who are in touch with our customers. And so Brittany's t-shirt for her anniversary gift was Crazy Book Lady, because this woman reads a lot, let me tell you. So that is a little bit about Brittany.
Thank you for that introduction.
Yeah,
I think I was most nervous about the introduction. and she patted me. So, hi everyone. I'm Brittany Richardson. I'm the projects development manager at Gainey's. And so I just wanted to talk to you about a little bit about some of the projects that we've done. You have heard about Pine Hill a lot today, and we do have some slides on that toward the end. But as Michael said, we have been partnering with a set of bridge systems in the Chalmette area. And so the first one we're going to talk about is the St. Aviv Bridge. We did this one back in April of 2018. This was actually one of the first bridges that we did that had a shortened length unit. So most of the units we had done up to this date were full length. We just poured the mold at the full height. And then each piece is the same length. We had to create a false floor, a section of wood underneath at the bottom of the mold that would lower the height of the units to make a customizable section, a customizable length of the structure overall. So what you see here is a 20-foot span O series bridge unit, and you see it being installed. Those foundations on the right are going to be, those are cast in place foundations by the contractor. And the contractor for this project was Hard Rock Construction. So this bridge is Chelona Drive. Chelona Drive was actually a 30-foot span bridge section. We produced this one back in July, in February of this year, actually. And this has several. It actually has 3 of the skewed units that he talked about just a few minutes ago. And I'll go to that. So this is actually a picture of in production of the skewed units, and how he talked about making the O series being optimized and having the ability to use one form and make it different sizes. There are legs on the form that you can pull apart or you can pull in, depending on the span of the piece. So you'll see the wooden bracing, lots of fancy woodwork there from our guys in the back. And we not only had to skew this piece this way, but we also had to make sure that they skewed this way. So it was pretty complex and very fun and interesting. We always love a challenge in tackling that. of it on the ground. And you'll see how it skews both that way and coming towards you. And that is a picture of it in installation. So you'll see off to the right, those shorter units are the ones that are actually skewed. Does anybody have any questions?
Say it's skewed, you were actually turning the channel.
Yes, you're turning the channel. Okay. And there is a picture of it installed. So this, we had 4 wing walls, 2 on each side and an attached head wall. One attached head wall, which is the face of the bridge that you see there, was actually on one of the skewed units as it was turning. That was where the head wall started. So that is the finished product. And here's Pine Hill. And you can kind of see the keyway, the cast in place connection that he was talking about a few minutes ago. You can see it poured all along the top of that arch where they connect. And this is also another view. If you look down at the bottom, this is an aerial view. You can see at the top, that's where we're actually in production of one of the pieces. And then back here toward the bottom, we're actually putting that together to pour the detached head walls up against it to make sure that it was match cast. And you can see the keyway very well right there. And it has dowel-in bars that we put in the piece. And so we actually install the female ends of these connectors into our precast unit, and they the male ends screw into the connection in the field so that you can grout in that area. That's the crew that did it. So this was Merritt Construction. They sent us lots of wonderful pictures on this site, and we got lots of feedback from both Contact and the contractors on this. This project had a lot of wing walls. So we actually had 4 wing walls on each side. So there were 16 wing walls total. And our heaviest lift on this bridge was actually one of the wing walls. So usually your heaviest lift is going to be your head wall because it's attached and that's your biggest piece. But on this project, this fella right here, that was our heaviest lift. It was about 30,000 pounds. Yeah, so the detached head wall that we had on this project came in 3 pieces. It came in 3 pieces. You can kind of see it right here. This is one, the top is another, and then the right side is another. And then you can see there's actually a collar that goes up the arch itself on the right side of the screen, and you can see where they come together. And then all of the wing walls butt up against each other and are connected mechanically as well. These anchors, so we pour the anchors first. We precast the anchors first, and they have epoxy coated dowel bars, button bars, and then they get poured inside the piece. And it ships in one piece. Yes, you're correct. And this picture is of our guys getting it done, because sometimes it's a late night, but they always manage to get it done, and it's beautiful. And there's the finished product. Does anybody have any questions? No? Well, thank you very much.
Great job, Brittany.
Yeah, great job, Brittany. We're going to take a quick little break, just in case you need to step out for a moment. And then our keynote speech, Greg Roach, is going to be at 3 o'clock. And then we have the grilled oysters and cocktail party, interactive, huh? And contest. Yeah, we have a contest. The drawing for, what is that thing that we're doing again?
It's Oculus 3D goggles.
Yes, they sounded cool.
They're really cool.
All right, thank you. So a quick break. We're going to be back in here at 3 o'clock. We're going to let the plant tour people catch up with us.
Man, I'll be honest with you. I always think that one day, it's not going to be really, really busy. And I'll just be sick for like mental health day.
It's amazing how like I haven't played video games since a kid. I used to, but I like forgot what it was like. I used to be so like in the morning playing probably screaming 15-year-olds yelling back at me. I'm like, dude, come on, you're 15. I'm like 32. Come on. Yeah, all right, come on,
Get a job. Buy your own Xbox.
I'm not getting moved. I'm not going to
I pay rent. That shit gets real then. Yeah.
This is the last one I built, but I ain't.
You should use the tag bill collector.
I sold my PlayStation 3. That was a sad day.
I've never sold any of that stuff.
The main reason I got it at the time was because it played through like use it for like.
I don't do social media. So like, on Facebook, like on Facebook, and then like I have an account. Yeah. I don't know if I've posted anything since like 2001, 2008 maybe.
My wife uses the Facebook Marketplace to like sell her art. That's where her art side business kind of took off. So it's awesome. Ever since March, I've been selling the Marketplace.
Specialized in nudes, huh? I tried Instagram. I was good. I did Instagram for almost 3 months.
Never did.
And then, like after 3 months, I was just like, I'm either too busy or not interesting enough. Like, I put stuff on there.
Shop here or your house?
My wife just that one for everybody.
Tell me it's a shop.
It's just a big. It really is. It's all fake. There's no positive answer. It's true. It's one or the other. It's either you have someone post someone off picture, and then you look at them, you go, "Wish I had their life." But then deep down inside, you know that shit ain't real. And then on the other side, it's like they're saying, "You just got so much rhetoric out there. It's just all hate." You know, screw all these bodies. If you saw me in real life, you would not act this way. Well, no. It's easy talking big things when you hit 1,000 miles an hour. Like, Facebook should have an ass whooping like, service. Like, if you post something stupid, like, you get an ass whooping. That's a problem with all that. Like, you go, like, in the world. I mean, everybody's just scared to get ass whooping. This is the just no value for life anymore.
It ain't going through.
And it's not like we really, you know, if one of our employees upset that Trump was behind Biden. And then like it's going to ruin the world, you know, because he hasn't really shut oil gas down. There's not going to be any more job opportunities. Like, you do realize, like, he is just a person. Like, there's a whole big-ass government that actually controls all this stuff. You know, like, he may have prerogatives, but there's still a damn there's still no, like, he didn't repeal all of the divorce stuff. He just modified it. He back on the tape up. As soon as the Democrat gets back in, regardless of it's this year, 4 years, 8 years, they'll go back the other way. You know? Still to be in my house now. Like, yeah. Not get paid anymore, girls with me on this. Don't change.
Buying them and flipping them.
do politics, just general personality. Yeah, that's exactly what it was. Like, I can't talk to you. Build houses and flips them unless they're business calls. Yeah, I saw people like that. And like the whole deal, the movement. Like, there was no right answer. The life that somebody like me, and that, you know, either I support the movement, but I can't understand what they're going through. I'm not doing enough. Or if I say something, it's a nice spot. Drew Brees is I'm not saying this shit was smart. Like, but what he said was get taken out of context and blow it into youth video. And Drew Brees, ideally, have an attorney which make all your tweets before you put them. Like, you don't have money to pay a PR guy to say, like, hey, can I tweet this? Oh, we can't afford for you to retire and live in this house and have a place to go. You know, it all plays out. We're seeing some stuff in our lifetime. Oh, yeah. I'm talking about that. 2020. I'm sure you know them. We'll get it. The water's cool enough now where it won't blow up or anything. If it goes through, it'll be bubble storm. They have to come do some online tests. I hadn't done that in 2 years. Take the online ethics course and take the little quiz. I don't think that. Yeah, no, just I think it's like every other year. I don't know if lobby him. Down. Andrew's just going so he can buy all of his marijuana paraphernalia. Sell it for twice the price. Being a government employee, you got to find another source of income. Yeah. It was funny too. We went last year with my mom. It was all of our family. My mom, brother, sister, myself, and my daughter. And my brother was like, he was on the family. Like, we walked over next to him and spent some water brownie. He was like looking at it. He's like, I want to eat this, but I don't want to be like, get drunk tested when I come back. So we got that result. The doorman. It's like, hey, you take tips? He's like, yeah. He's like, it's a product now. He's like, sweet. So how often do you I've gone 3 times. Once when I started, and then twice. Yeah, I've actually had it my whole life. All throughout high school and stuff. Random drug test my ass. There's 3 of us. Every 9 weeks we go get drug tested. Yeah. Sports. There's 3 of us there. Every 9 weeks. 3 of us and 6 or 7 random other kids. We didn't. We played sports. I don't know. I guess we qualified as club as opposed to sports. We played paintball. So they drug tested anybody from paintball. I'm not saying myself. So quite a few people in our team. It would have blown 2 votes to the team. you get drug tested. If something happens, you get drug tested. So, accidents happen. It's a problem. Right. It's clean. Yeah. I'm buying a new car tonight. You got early hits and red light hits. So it's not even that old. Oh, they gave you what I paid for. Oh, great. So minus tax, kind of license, but they gave you what I paid for. That's probably the only reason I'm going to get this expedition tonight. I think it's because I got it down to where in 2 years, 18,000, 20,000 miles, they're giving you what I'm paying for. Yeah, that's what mine was. Those costs are wrong. I did that one. I had a full CRV. It was like 2000. That wasn't. It was that. I guess it was 06 or 07. I had a 230. I used that for fucking rich so much. Most of them also, we even back to the great company I worked with, and having a company truck. So here's a question for you. Does an Oculus cost more than $50, $60? Yeah. I don't know if you accept that. Oh, the ethics thing. More testing is how I got that off. You don't even need the pan dropping. Let me ask you this. Yeah, but what is it? So it's not intentional. It's not a gift. If you don't, it's not any good, you can just turn it right on.
Okay, in 3 minutes, the star of the show will be on, our keynote speaker. Okay, we're going to go on and get started. Our keynote speaker today is going to be talking about above ground wastewater treatment plants, and it's Greg Roach. But Greg, being the diva that he always is during these presentations, told Cindy outside, hey, you're going to co-present with me, right? Because Greg, have you even looked at your slides? So going with the tradition of telling people what their anniversary t-shirts were, Greg's anniversary t-shirt said, I fixed it, because he loves to take credit for whenever something is fixed around here. He says, oh, I fixed it. So that's what we got his t-shirt. So, but next year's t-shirt, I already have it planned. I don't even hear Lisa's voice. Yeah, that's what it's going to say. I do. I love you. Here you go.
Oh, thank you. Everybody else gets bios and nice things.
You get roasted.
So here we are, dead last once again, and they're calling that I am the keynote speaker. So I feel very special that all of you stayed around till 9 o'clock at night to hear me speak. And it's going to be short and I hope fun. So I got here in 2002 and got introduced to what Gainey's did, and I had a full career prior to that, supplying to the precast concrete industry. I have a chemistry background. So a lot of things I was a little bit associated with. And so it was the first time I really took a hard look at wastewater and how to design to treat wastewater. So my early weekends with Lisa, we would drive to areas of Louisiana and I would take a look at old treatment plants, either built by Gainey's or our competition. And I would have to say back then, in my mind's eye, probably the average size system was maybe 15,000 gallons per day. And probably 70% of them were either steel completely above ground or partial bury. Now, first of all, does everybody understand what a packaged wastewater treatment plant is? It's a system that's something smaller than municipal that can be put on site for a regional, say a subdivision, as opposed to municipal, which would really be the final step on the evolution to wastewater treatment. So many areas in Louisiana, rural going to suburban, going to light commercialized and industrial, big need for packaged treatment plants because you didn't have collection lines and municipal sewer in a lot of regional rural areas. So what's happening today is we see a trend where, because of the cost and time to permit, subdivisions, if you hadn't noticed, are getting bigger and bigger and bigger. So 15,000 gallon per day is 70 homes.
Yeah.
No,
That's less than that.
40 homes.
40 homes. Yeah.
40 homes. So now the average size subdivision, we did last week, two 50,000 gallon per day plants. That was 2 weeks ago. Last week we did 100,000 gallon per day. So things are getting bigger and bigger and bigger.
We do a lot of 80s and 75s.
Yeah. And you know, you walk by something every day and just think, well, that's just the way things are. So why would somebody want to build a plant above ground out of steel? Well, what we heard is for some municipalities or utilities, they want to take a steel plant and put it somewhere for some time. And maybe as they grow into it, they'll take that and put in another area and then swap it out with a larger system. Or they know that 5 years from now, they're going to have municipal sewer. So they want to put it on the ground. And then when they're done, they could pull it out. Once you bury a Gainey's wastewater treatment plant It's there. So when they finally go to municipal sewer and they call and say, hey, you want to come take the tanks back, the cost of digging them up and taking them out is more expensive than being worth it. So there's definitely a place for a temporary plant, whether it be steel or otherwise. But let's talk about other reasons why things might need to be above ground as opposed to the Gainey plant, which has traditionally been partial bury or at grade.
So one of the main, I've
Go
got
ahead.
this one. So one of the main reasons that we find are the base elevations are too high. We've been encountering this time and time again. I mean, in Louisiana, it's kind of a no-brainer. We have a lot of high base flood elevations, and they're getting raised every day. Because of like the 2016 flood, we're seeing that the next slide you'll see is not just the base flood elevations that are high, but areas that are previously were not considered flood areas. So what happened in 2016 when we flooded here? Were we a flood area? No. Did we have flood insurance? No. But we got a foot of water in this building. So areas that used to not be considered, now they're mapping out. These are these special flood hazard areas, and it's getting more and more prevalent. And so what you don't want, because it is a hazard to everyone's health, is you don't want your treatment plant to get flooded, right? You don't want flood water to come in and then that push out the sewer water and then that mixes all in and it becomes a hazard, a health hazard.
Well, and you go back a slide.
Yeah.
And code says that your top of your treatment plant should be at or above 100-year base flood elevation.
Right.
So here was, at the time, the largest above ground system. This is in Athens, Louisiana. Athens is northeast of Ruston. So when you think of high flood elevation, you think of the coastal areas of Louisiana.
Right.
This was at the bottom of a quarter-mile hill just prior to a stream. And when it rains, if the stormwater runoff, we've already had that system halfway underwater. Yeah. Yep. So go ahead.
So, why above ground? Well, because we have flooding and we're trying to avoid the treatment plants being inundated with the flood waters. And previous to what we're developing here, it was, you could only think, oh, if I have to be above ground, I need to use steel. And that was the only way to address it. Another reason that we need to go above ground is industrial areas. We get a lot of calls and they just don't want to dig. They don't know what's under that ground. They don't want to have to dig up. They may have, existing utilities going under there. They would much rather not have to open up an excavation at an industrial site. So these are just a couple of industrial sites where we put it on a slab.
So I recognize these. On the left, that's Port Fourchon, and that was high. I think it's base flood elevation of 12, ground of 0.
Yeah.
And so
They called and they said, our base flood elevation's at 12. I'm like, well, good luck with that. That was what we're going to do.
I talk about innovation, and very rarely do you get an aha. What usually happens is you have somebody that has a problem, and incrementally you begin to solve the problem.
Mm-hmm.
So we had a whole bunch of people that wanted treatment plants down in Grand Isle.
Yeah.
And I think we did. And so, yeah, we can make something custom for you and give you a small system like you see on the left. And we struck a nerve. They said, oh, you can do that. We're tired of steel plants not really lasting. So can you build this? Can you build this? And we started getting bigger and bolder. This was just completed actually this month at Olin. And same issue there where they had no base flood elevation issues, but they don't like to scratch the dirt because it's a huge bureaucratic process at Olin to dig anywhere there without lots of paperwork and angst because they're not sure what's down there. It's an old plant.
So there's a lot of reasons for.
So it's precast.
Yes, sir.
All precast. Yep. Above ground.
But above ground, that means you can reduce the thickness of the wall because you don't have much earth pressure.
Exactly.
Yeah. Yep.
Yeah.
Yep.
Mm-hmm.
So this is what I walk past over and over again. And you don't say, wait a minute, why are we doing this? So you've heard through the years us talking a lot about microbial induced corrosion, the corrosion of wastewater. If you're not aerating domestic wastewater, you create hydrogen sulfide gas through aerobic digestion. It's called biogenic corrosion. You create sulfuric acid and it will eat away at concrete or steel or whatever. Concrete is a 100-year solution in a pH neutral environment. And these are aerated systems. So the wastewater on the inside is a pH of 7. But while concrete will last 100 years in a pH of 7 wet environment, steel won't. So steel, in the presence of oxygen and moisture and warmth, is going to be a corrosion point. So we look at these systems and we just say, well, that's just what steel does. So over and over again, what we're hearing is these small rural towns bet the ranch on creating capacity for wastewater treatment. They have a 30-year debt, and 15 years into it, the structure is failing, and now they need to replace it. And that's tragic because all the mechanical equipment should be the first thing that's going out.
Right.
So can we remember where that
Yeah,
is
this
one of the
is your
schools,
part.
Assumption Schools? Yeah.
Yeah. So, and that to me was what was really sad, is because we got contacted on the Assumption Schools. Greg and I think Blake, you can see him in that picture right there. We went down there to look at these treatment plants, and every single one of them was pretty much in this condition and just falling apart. And it was appalling. And these poor schools were still in debt paying for some of these treatment plants, and they have to replace them already.
What do you call a partial buried steel plant filled with water? A battery. Yeah.
Yeah. So this is Mary Dale's video, Greg.
It's a steel plant. You can see right through it. Up at that steel support, you can see right through it. And then look at the bulge. That's supposed to be a 90-degree angle.
It's fixing to
And on
fall.
the far side. This is 10 feet from a house. So when plants are above ground here in South Louisiana, they don't seem to fare any better than in the ground. Look at that. So there's another one ready for catastrophic failure. Unbelievable.
And in this next video, this is the same plant. He zooms in and you can see it leaking. Look at the water dripping down from it.
And I'm less worried about the leak. What I'm worried about is catastrophic failure
Yeah.
any day, right? It's just about ready to let go.
And this was out at
It
Saline.
is another small upstate Louisiana town. This is handling their entire town, and same problem. It is ready. It is ready to let go.
Plus, it's got a whole bioculture.
They call that tertiary filtration.
Yeah. And this is Labadyville. Yeah, this is Labadyville tank. For some reason, it's on this weird angled, partial buried tank. But you can see on the inside, it's falling apart as well. And that's one in another Assumption School. So those are just some videos to show you don't have to stick with metal anymore. Metal is a poor choice in this environment. You now have an option. You could see daylight through it on that side. And that was a really powerful picture Greg took.
Yeah, so this is down in Thibodeau, and it's in a low-income neighborhood.
This is the one that he just showed you in the video that's about to rupture.
And we just set those tanks maybe about 3 weeks ago, and we're plumbing it out as we speak. And we hope that will be a very good friend for many, many years. The town, and I think they got that through some grant.
Yeah.
But what's important is, not a civil engineer like you guys are, but you're looking for 50 to 100-year service life out of things. And so the good news is the major investment they're making shouldn't have some shortened lifespan because of its holding capacity, right? There should be mechanical equipment that you have to replace, maybe piping at some point, but it should be something that can service that community for at least past the term that they're paying for the debt.
Right. So, I mean, when you look at metal versus precast, you're looking at the same upfront costs when you're above ground. If we're in the ground, we're usually a little less. Same foundation needed, with the benefit of usually when you have a steel plant, they have to dig down for the hopper because there's this large hopper that extends into the ground. So you don't have that with ours. It's just a straight slab. And then you get the same treatment process result, if not better, but metal is only a quarter of the lifespan. So it just doesn't make sense. So that's, the more we had all these systems come to us and the more we've worked on it, like this is really going to solve a huge problem, especially here in Louisiana.
Price-wise, Athens, we were specified, but then for the Marydale, which is down in Thibodeau, the engineer gave it it was a steel system with a precast alternate. So we got a firsthand opportunity to see how we compared price-wise. It was an interesting thing that happened. So there were 4 contractors bidding. 2 of them went with the steel plant, and 2 of them went with the precast plant. And what the 2 people that went with the precast plant, first of all, we were friendly with them. We had done other work. So because we're also contractors, what we were able to bid them was a turnkey price. And so what they said was they felt safer in the bid because we took on the responsibility because we were a larger part of the contract. So for the steel plant, they were responsible for infield welding. How much labor do I need? What will my cost truly be? And they felt like by getting the turnkey price, Gainey's made the tanks, Gainey's designed the systems, Gainey's got it permitted, and then Gainey's installed it. So they felt like they had a surefire way to get their preferred markup and make their money. And so, and we wouldn't have gotten that if the steel system was a lot cheaper. So what we got was they were within neck and neck.
Right.
So while it is more expensive than our in-ground traditional system, it is about equivalent to a steel system. Yep.
Right. And this is just some more pictures from Athens. This is the treatment plant. You can see the handrail that we install above it so that you have, if you get up there, obviously you're above the 4-foot OSHA rule. So you have to have the handrail and the ladder for your operators to be able to get up on there and maintenance it. But at least that way, you know, you can get up there, they can operate safely. All your equipment is up there, so you don't have to worry about the floodwaters getting to the equipment as well. So it's amazing to me. It's just so beautiful how well it's stacked out, and you can see how clean it come together.
Same advantages that Gainey's package treatment plants. We think a lot about the people who operate them and that the tests that they have to meet. So we've done a lot to make our system easier to operate. Sludge returns, which return sludge from the hoppers of the clarifier. When I got here, we would do a 30,000 gallon per day plant. It would be 60 foot long. And the first cell was cell 1 and the clarifier was the last cell. So you have this 4-inch sludge return running on and off with thick, sticky sludge. And between the blowers cycling on and cycling off, they were constantly clogging. So what we now do is we do what we call our wraparound plant, where we go this way, and we make a turn, we come back this way. So now cell 1 is right next to the clarifier. So you see little tiny sludge returns, and that makes it easy for the operator. Just, you know, that 7-foot sludge return rarely clogs. If it does, it's a lot easier to clean out than a 100-foot sludge return.
Right.
Yep.
And so if we, this is a really good picture. Greg took this video, not picture, of one of our weirs. He sent this to me and I said, where did you download this from? He said, no, this was at our plant. And it looks really neat, but you can see how clear the water is, how smooth and laminar the flow is you're getting across that weir because it's protected. So what we do when we have to meet more strict TMDLs, because as Danielle knows, they're all strict these days. So when we have to get down to 10 BOD and 15 TSS, we can address that now. In the past, we always thought, you know, well, the only way to get to where we need to be was to add in tertiary filters. Tertiary filters have a place, and we'll kind of touch on that. But to get down to 10, 15, which is pretty much the standard going these days, we can add in EQ. So you put in additional capacity. Usually it's roughly 20% of the plant capacity. And then you can take in those surges when all the kids go and pee as soon as they get into school, or they go potty, Lisa. They go when all the kids go in, or everybody gets home in the afternoons and does some laundry and washes their dishes. You can knock those peak surges down because you can hold it and then meter it out and dose it over a nice scheduled time period. So then you get weirs protected like this.
So 10 state standards says 20,000 gallons per day per linear foot of weir at peak hourly flow, and people put in just enough. We double it.
Mm-hmm.
So you protect the weir on the back end, and then you protect the weir from surges on the front end. The weakest part of an extended air system is a gravity hopper clarifier. You greatly improve the performance of it by having no hydraulic surges. We all know about INI. I&I becomes less and less of a factor if you're doing these two things, which are relatively inexpensive. So early on, when DEQ said 10, 10, 10, 15, people were running out spending lots of money on filters. We're confident, and we've done it 50 times now.
We have the DMRs.
with flow equalization, oversized weir length, we're easily getting single digits in BOD and easily hitting the 15 on TSS. And certainly when we get down lower to that, when we get into 5.5, we're happy to put on expensive mechanical equipment, but there's no need to get down to a lot of the limits that are out there now. Yep. Oh, who knew, Cindy? That was the next slide. So
it's like it just happens.
Yeah, Aqua Aerobics spoke earlier. This is an Aqua Aerobics tertiary filter. This is a municipal grade filter. It's a disc filter, and it's smart. It has PLC, and it controls itself and monitors itself. It gives you reports, and it's a good friend. Once you turn it online, easier for the operator. All he has to do is just open up the door, check on his diagnostics, and it'll clean itself and let you know if there's any issues. Yep.
So when you need to get down to 5.5 and you need a guarantee that you're going to hit those numbers, that's when we start looking at tertiary treatment. The other thing is nutrient reduction, and we're seeing more and more of this. And what we're doing to address it is we're adding anoxic zones into our plants. So you add a zone in your plant where you have less air. So you still have a little air in there, but it's a whole lot less. You dial it way back, because in that oxygen-rich environment, certain bacteria can't live. So you need heterotrophic bacteria. They live in non-oxygen environments. And then you have autotrophic bacteria that live in oxygen-rich environments. And the twain do not mix. And so if you create these areas where you have less oxygen, then you can have those heterotrophic bacteria. And what they do is they take and convert the nitrates and nitrites, and you get nitrogen stripping, which allows you to remove some of the ammonia in the plant.
She's smart, isn't she? Smart.
Yes, it's a separate tank. So each individual cell. So this is its own tank. It's still hydraulically connected. Anoxic zone is usually what we do first.
And also it depends.
Yeah.
So great case study. 2 years ago, our daughter is a junior at University of Louisiana. They were building a new apartment building, and so they needed an 80,000 gallon per day. We build an 80,000 gallon per day for a housing subdivision. It takes 5 years for them to come to capacity. This plant went from 0 to 80,000 gallons per day in a day when all the students showed up.
Yeah.
So they had full loading in one day. So about 2 months in, LUS, who is the utility, called and said, we're not hitting our number. Well, what number are you not hitting? We're not hitting on nitrogen. So we went out there and we met with them and talked about it, and they had ideas and we had ideas. And what we wanted was to set up an anoxic zone on one of the sludge return cells. And he said, well, I like that, but what about over here as well? The beauty of a multi-cell system as opposed to a rectangular steel system is we have controlled air here, so we can turn air up, turn air down, and create different zones. So he played with that for a month. And I called him and I said, Charles, I'm just running through. You want me to come on over? He goes, no. I said, why not? How's your nitrogen? Undetectable is what he said to me. Yeah, so that's pretty cool.
Yeah, it was really neat. It was a huge success story for nutrient reduction. And then also watertight. So we have the technology to achieve water tightness with our precast tanks. So the way that we have traditionally been doing this, so we have two different types of molds. If you went on the plant tour, you saw our standard steel molds. And so those can produce monolithic pores. But when we do custom work, which that's what these tanks were built custom because they were much larger than our standard tanks. When you do custom work, you use the modular forms. Well, you can't do a monolithic pour with the modular forms. So we would have to form up our base. We put in our water stop. We have all these different tricks and trays. I think there's a picture coming up. Hold on, let me go back. Yeah, here you can see the water stop here. You can see their L bars coming up from there. They even come in and put epoxy around it. So that they do a lot of things to get that cold joint to have a really good seal. So they go back. Let's see, hold on, sorry. So first they address this here in the plant, but then they have to address the seam in the field because there is a mid seam. And so then they go in and seal that, and then they do water tests. and Danielle hounds them like a hound dog to make sure that they get all their water tests in, right? But they have a form and they have to measure in the different cells where their water test is when they leave the site, when they get to the site. They have all these different measurements and checks and balances.
Well, so the business has now grown where there's a lot of demand being created. So we've invested in a steel mold.
I'm so excited.
Because Lisa, while we were shorthanded due to the coronavirus, was actually out in post-production.
Danielle, you were there too.
And Danielle. And so see all these wall ties? So we're using crystalline waterproofing, and then every single one of those wall ties has to be patched and checked. So it's just too much labor for the size of the systems we're now doing. So we now have a steel mold. It'll be produced very much like our conventional system. No steel ties, no cold joint, no water stop, and it'll be much quicker process.
So excited about the labor savings on Tim. So, and we can do a huge range of sizes. Actually, just recently, we've had 2 different people contact us on 500 gallon per day above ground systems. So we've had 2 different interested parties on
wildlife
that.
and fisheries.
Yeah, and trees and trails. I think they were interested originally in that. This is the one Greg mentioned earlier in Port Fourchon, and then this is Marydale. So 6,000 to 80,000. 80 so far is our largest above ground system. That doesn't mean we can't go bigger. But Greg, if you need bigger.
So we were working with one of the home builders, Horton Homes, and St. Tammany Utilities, and they have a project, 660,000 gallon per day ultimate build out. And so we proposed our partial berry system, and they said, well, can you make something with a little bit fewer cells? And so we got together and go ahead, Cindy, lay it out.
Okay, so what we knew that we could produce and ship economically, I kept going back and forth between my estimating and myself and design. And what we came up with was we could do 25,000 gallon holding cells. It'd be a 25 foot by 12 foot in inside width and length. I want to say those were 8-inch walls, at 8-inch walls, because like Elias said, you know, depending on the berry depth, it doesn't have to be super thick. So I think this was a partial berry system. And then you've got, we were able to do single hopper clarifiers. What we like about that is with single hopper clarifiers, you're not taking like 4 or 5 sludge returns and returning it to the front of your system and hydraulically loading the front of your system. So it's a much more efficient if we can get it down. So we've got that, and it's a more consolidated footprint. So this footprint right here is 87 by 41, and it's 150,000 gallon per day holding capacity. It's 3 50s.
Heaviest lift, 50,000. And so that's easily one of these Tadano rough terrain cranes roll onto site, and we have, it's not expensive to set it.
Right. No. So yeah, we costed it out, and they were extremely impressed by the cost savings versus some of the more municipal style systems that they were looking at. I want to say we were almost half the cost of one of the municipal plants that they were looking at. This is just a profile view of that system. And then we gave them a couple of different footprint options. So this is 600,000 gallons per day in holding capacity. This was one option. And then here, this is the one I like the most. And I think they, if they were going to go with it, they're going to go this route because it centralizes all your EQ. So you can take your lift station and pump into one place right here. So you can enter here. All of this is hydraulically linked. And then you can discreetly enter each leg of your treatment train and then go out and combine for your chlorine contact chamber.
And then single discharge point.
And single discharge point.
Yeah.
Yeah. And then you wanted to go over a couple more of the little things that we have added?
I think we've covered that. So one of the main complaints we heard when I first got here was wastewater treatment plants are loud and they smell. Well, if they're loud, you turn the blowers off. And when you turn the blowers off, then it smells.
Yeah.
So we found ways to hit different noise ordinances in different areas. And simple sheds, we customize them with venting baffles and then sound attenuation batting on the inside. And so we can get them down into the low 60s. And, you know, conversations are in the 70s. 60s is pretty darn quiet. Yep.
Pretty quiet. Yeah.
Yep. Flow measurement. In Georgetown, they have to start up, and they're transferring water from the old plant to the new at 300 gallons a minute. This is flow. Pretty close to what they should expect if you have lift stations hydraulically overloaded. This is flowing out of the chlorine contact chamber over a 69-degree denox rear with ultrasound transducer. Immediately above it, taking real-time flow measurement, and it's also a fertilizer flow.
And we already talked about mission earlier. And you wanted to just kind of touch on the different.
Yeah, on these
chlorine?
larger systems, tablet chlorinators are going to start becoming cumbersome. So we can do gas or liquid and meter it in as needed. So we're ready to go to small municipal systems, right, Cindy?
That's right.
Yep. And you guys are ready to go on to break, I think.
Yes, look at that.
There we go.
So I have, get the door prize, and I have the cup right here already, Trish, with the names.
Greg. Yes, I'm sorry. Yes, Elias.
Elias has questions.
Yes.
Those treatment plants, you paint the inside of those plants.
No, pH neutral, no corrosion.
So it will not attack the
Just like our classic partial berry treatment plants. So Lisa has a fun life. I told you when I first got here. For the weekend, let's go around and look at some early plants. And there was a lot I didn't like.
You just had to show me a good
Cold roll bar, security to hold the gratings down, corroding in place. Little, zinc plated eye bolts corroding in place. Burned edges of grating corroding in place. Inside of the plants, immaculate. So concrete in a pH 7 wet environment is a 50 to 100 year structure. We are making sure that we have proper embedment depth. We have high density self-consolidating concrete. We're using crystalline waterproofing. I have never, how long have this company
I've been here forever.
I would say we're in business making packaged wastewater treatment plants for close to 40 years. Is that about right?
40 years in May.
And I see no deteriorating concrete tanks. Just haven't seen one. Septic tanks is a different issue, a highly corrosive environment.
Yes.
We're actually part of, we wrapped up that task force finally. So we were part of a national task force on microbial induced corrosion for 15 years. It was a lifetime. And so, some really great things came out of it. And he's absolutely right. I mean, as long as you're aerating it, we haven't had that problem. And let me tell you, we've looked at a lot of treatment plants. A lot of treatment plants, I'm like, no, I am not walking on top of that. And I am here ready to call the police to come get you. Okay. So
we have the video too.
Yeah. No, I love the video.
Good question.
Yeah. Any other questions?
I call it 3/4 inch cover. I want 1 to 1.5.
Yeah, we typically do 1.5.
Pacified inside the highly alkaline concrete. Yep.
So I was going to tell you, Greg, I'm so sorry I raked you over the coals because I felt really guilty about it the whole time you were speaking.
I think Elias is better than me.
I know, no.
I see it in your eyes.
No, Greg, I'm trying to apologize, okay?
She pulled me aside. She goes, why can't you be like Elias? Then you have something.
Okay, so listen. So just real quick, we're going to draw for our grand prize. This really geeky thing that Cindy thought y'all would like, okay?
It's super cool. And just try not to run into walls in your house.
And we ordered it when we were doing the wastewater conference in April, but this came from China, and they didn't let anything come from China for a long time. So finally it came in. Yeah. And so, yeah.
We're sure all is contamination.
Yeah, I know. It's been in Cindy's home for a little while. Oh, keep
You get multiple.
Let me guess, Elias.
No. Oh, I haven't seen Lionel Franklin.
He's not here.
Yeah. So, Lionel.
And he usually wins.
Yeah, he's won a couple of times. It just feels rigged, don't you think? Okay. So let's see. Oh, Al. And I seen Al out there, and I think he's won before. Didn't he win last year? Mancusa? Al,
come on down.
Can you ask Al if he's he's the nice looking guy with the peachy fishing shirt on. I say this just to get a rise out of him, and it works. So I'm pretty certain Al won last year.
He might have.
Yeah, it's amazing how the same people always win. I never win anything.
Must be a lucky star
other than your
following.
love. Al's coming. Al, didn't you win last year? No, you don't want him? You was fair and square. Okay, he doesn't want it. Okay.
Right.
Well, we'll let you come for free. Oh, you already come for free, don't you?
Yeah.
Okay. All right. That was really nice of him. I wouldn't be that nice if it was me. Tim Brown. Tim Brown? I don't. Okay. Okay. So, Tim, you need to thank Al because you now have some new goggles. Tim Brown.
Yes.
Yeah.
Going once, going twice.
I know. Okay, so while we're waiting for Tim to come in and collect his goggles from China, let me do it like China. Anyway, that was good, huh? China. Anyway, so while we're waiting for him to come in,
Don't encourage her.
I know. I might do it 20 times now. He's not here?
No, that's my balls.
Okay, you're gonna go get him? Get him, because if he okay, we'll let you
That's
take him. But we're gonna call him and let him know that you got these goggles, okay?
No, I'm taking,
Torgana.
Okay, so we have this little promo video that Cindy just threw together to promote our wastewater conference, which will be the next time we see y'all. Unless you want to just stop in sometime, you're always welcome to stop in. And this is promoting the conference on April the 30th. Thank you, Cindy.
You're welcome.
You want to tell them how you created it?
Because they're crazy people. You'll see.
Yes, yes.
And we had lunch where?
Oh, La Trattatera.
La Trattatera.
Something like that. Trattoria. I don't know.
Oh, thank you.
Details.
There's always
details,
somebody
I know.
that you.
La Trattoria.
So,
Yes.
so your goal is to slaughter the language
Of
in
every
port of call.
country I ever go to. Yes, I know.
Lisa.
Yes, Greg. Stop damming up the roadway, Greg. Come on, let people through.
But Lisa, it's the Hoover
It's the
Dam.
Hoover Dam.
It's the Hoover Dam.
It's exciting. It's concrete in all its magnificence.
Say Hoover. It's from. Hey, Lisa.
We're here at the Fanay.
The Bayina. Hold on.
No, I'm pretty certain it is the Fanay, and it is fanabulous. At first, I thought that was the ocean right there, but it's not. It's the Puget Sound.
Well, I think that might be how they say it in Louisiana, but here in Seattle, I think I might have heard it once or twice called the Puget Sound. But wait, what are you saying?
No, it's Puget. It's Puget. So you pronounce that Puget.
From Venice, Italy.
Good morning.
So, Lisa, here we are
And Manarola.
of Cinque Terre,
Cinque Terre.
and the scenery is so lovely. So, Lisa, what is this?
Cappuccino Dale Cappuccino.
Hold on.
Yeah.
Sorry.
See.
Can you say what is that?
It's
Cap-
see.
cap-
Cappuccino.
And say that for us, Lisa.
Yeah.
Cappuccino.
Yes. See.
Cappuccini. Thank you. So, Lisa, here we are after our magnificent dinner. And where are we going?
What do you mean where we're going?
Where are we going tomorrow?
The Orbitarium?
The Arbitrarium.
Something like that. But
So, Lisa, here we are in our final evening in Venice, and
yes, we're at a Becchetta restaurant, and we're having a Chianti Classic Coke. It's from the Pieve de Spartania vineyard.
Spalten. Thank you. That's the first word she's mispronounced all week.
Yeah, we'll pull again since Tim's not here.
You pull this time.
Okay, I'm pulling this time because you're like, yeah. Nope, he brought him back. Michael Boudreaux. Michael Boudreaux.
If not,
If not,
you're bringing it to Tim.
yeah.
Yes.
Okay, well, we'll wrap it up. Yeah. So if any call, nope. Okay. So I guess we're going to be bringing it to Tim. Okay. Yeah. All right. Well, thank you. Thank you, everybody, for coming. Lisa, if you want to come up, we have cocktails outside, char-grilled oysters, all kinds of fun games. We're
So
really
let me,
excited
yeah,
you're
so
here.
it's an interactive cocktail party. We're really excited about the games. We have remote control cars for you to race. Yeah, I know. It's pretty exciting. We have all kinds of fun games out there. And we have our famous panty dropper punch. You heard me. Yeah. Our pink punch, whatever you want to call it. But anyway, it's a really good punch that we like to serve when we have events with char-grilled oysters. So please eat, drink, and be merry. And see us again in April. Thank y'all so very much.
Bye.
Thanks.
Thank you that's watching online.
Hey, and if you haven't gotten your PDH CEUs from us within about a week, that means Cindy dropped the ball, so contact her.
Upstairs.